Good morning, everyone. Thanks for being here. So the first session after dinner is always difficult, but so this session is about architectural design, and there will be the presentation of 3 technical research papers and 1 new idea paper. The first one will be about architecting digital twins, presented by Aurora.
Okay, thank you for the introduction. Good morning. I'm going to present the mentioned work, of which Elena Navarro, Carlos Cuesta, and Ubetson are also co-authors. Due to time constraints, I'll focus on the most relevant. This one. Hello?
Yes.
Okay, as I was saying, due to time constraints, I'll focus on the most relevant aspects of the presentation, and the other aspects can be consulted in the article. How many issues today? It doesn't work.
No. The keyboard. No,
Doesn't work.
Hi, Ma.
This is because I'm moving here.
Yes.
Okay.
Now it's working.
Okay. The digital twins concept has evolved from the initial definition in 2002, and since then several definitions has been published. For example, the first one from an ISO standard.
Can you come closer to the microphone?
Yes. Yes, the first one from an ISO standard, which defines digital twins in the manufacturing field. Another one, the second one, by Minerva, in which digital twins refers to the physical component, the logical components, and the relation among the physical and logical entities. Minerva also defines a set of properties that a digital twin should
Can you use this one? Because I'm
yes. Minerva defines a set of properties that a digital twins should satisfy, and some of them are essential and others are optional. The way in which the proposal satisfies these properties will be, and their definition will be provided later. Digital twins is considered a promising approach to developing complex systems. Most of the proposals focus on developing digital twins for a specific use case or need, and rely on describing a prefixed software architecture. So we could say that there is a lack of modeling approaches that help to architect digital twins. The aim of this work is to propose a domain-agnostic approach for architecting digital twins. Digital twins involves the notion of direct mapping as a design rule, that is a direct correspondence between concept in the problem domain and entities in the solution space. This is also driven behind the domain-driven design, which defines a dual strategic and tactic process in which a set of patterns are applied during the software design. These aspects have led us to define these research questions. The first one, is it possible to apply domain-driven design for architecting digital twins to satisfy their properties? And considering that the answer is true, the second one, does this proposal offer results with higher satisfaction of digital twin properties than other existing proposals? We have adopted a design science research methodology, since these research questions focus on the design of novel artifacts to solve the identified problem. Digital twins architecture must include the relevant abstractions from the domain, independently from configurations. Our proposal is driven by these properties that we will define, and also their comparison and trace to domain-driven design concepts. The proposal provides a method for identifying types of digital twins, the internal structure and the domain model, and also the relationships among the different types of digital twins. We can see here the schema of the process, that is an iterative process. Digital twins are supported by the concept of bounded context. That is the context in which a particular object is used. The strategic design step has 3 different sub-steps. In the first one, we identify the likely context of use, or bounded context, regarding time and space. A different digital twin, we identified a different digital twin for each one. And the result is the identification of different physical objects in the system. Each of these digital twins can be single or a composite one. We have also to determine that. And we do it depending on the control level required. And the result is a map of logical objects of the system. Then we map types of digital twins to bounded context. We identify different types of digital twins in the system, not individual digital twins instances. And each one of these type of digital twins or bounded contexts will work as an independent system fragment. And finally, we identified the interaction among the bounded contexts, the integration points between them, and also the data flow between them. Here we can see diagrams that are part of the strategic design for a wind turbine system. We can see the graphical description of the physical system. We can also see the different physical objects identified. And finally, we can see the logical objects map with the trace among the physical objects and the logical objects of the system. The bounded context expose the functionality through the open host service relationship, and we can see the trace and that several logical objects subsume different physical objects that was initially defined. After the strategic design, the tactic design defines the structure for every type of digital twin, as we will detail in the following. The tactic design can be seen as a sort of a decision tree. Every desired digital twin property can be mapped to a certain architectural construction, and the resulting structure would depend on the set of capabilities that we would like the system to have. The internal architecture of the type of digital twin be specified in the hexagonal architecture style with the 3 layers that can be seen in the image. And the properties that a digital twin may have been traced to a specific layer as we will detail in the following. The first one is the domain layer at the center of the architecture that captures the logic of the domain. This is a specification of the use case of the digital twin, and it focuses on the digital twin rules, logic, and workflows without introducing any technological detail. This model is key to satisfy the first properties. Representativeness and contextualization conform one property. Representativeness means that the logical object must mimic the status and features of the physical object, and contextualization means that all information and features of the physical object relevant to the context of use should be considered in the logical object. This is a function of time and space. And also reflection. That means that a physical object is timely and univocally represented using the values of the attributes, the status, and behavior of its logical object. And to satisfy these properties, we can use these domain-driven design concepts. The first one, entity, that refers to each concept univocally identified in the digital twins domain. And may be mutable, that means that its state may change. And we have an example here of the electronic controller that was initially modeled or identified as a physical object, and now is modeled as an entity used to define the control policies of the wind turbine. We also have or can use value objects. Every concept that is embedded in the digital twins, or it could be some kind of complex property of an entity. We also have an example here in which the power output has been defined as a value object that represents the metric electric power. We can also use aggregates that are compositions of one or more entities and value objects, and are used to maintain which business rules must satisfy once a transaction ends. We also have an example, the wind turbine, that combines the wind turbine itself and also the electronic controller to allow us to refer the wind turbine as a single concept. The next property, predictability, means that a logical object of a digital twins may be used to simulate its behavior and interactions with other digital twins to determine the outcomes in a likely future or context. For satisfying this property, we could use domain services that represent the behavior of the digital twins using entities, value objects, and aggregates, and relies on the application service layer for any technical detail due to the dependency inversion. And we also have an example of a domain service, the simulator WT service, that includes methods for the analysis of deformation, stress, and crack. The next layer, in the next layer, every service that is exposed to the clients are public in this as a public API. This layer delegates to other two layers when needed due to dependency inversion. Its main features are the ones included there. It abstracts the domain logic, hiding the details, so it exposes the relevant business cases as application services. Also, it's responsible for the notification about changes in the status of domain objects that may affect other system elements. And finally, it includes facilities to deal with potential problems or damages as part of the public API that it exposes. This property augmentation refers to the first feature. This other property, accountability and manageability, refers to the second. To the last feature, and these properties can be satisfied by the open host service relation that was defined previously. Also, another example here of two application services that are grouped by functionality, one for the power generation methods related to the power generation and methods related to the health monitoring. And the last layer is the infrastructure layer that is responsible for all the technical capabilities of the digital twins and of the architecture, and it's responsible for isolating and protecting the other layers against changes and necessary dependencies from clients, and also infrastructural issues. And the DT properties traced to this layer can be considered optional, as I said before. So more details about them could be read in the article. This is the complete tactile design diagram that we have seen in small parts. All the components, it includes the components of all the three layers. We can affirm that domain-driven design can be applied to the design of digital twins, and so we can answer positively the research question number 1. We have conducted a qualitative evaluation based on an anonymous survey answered by practitioners not involved in the proposal that were conducted by email. As the table shows, the average evaluation of all mandatory properties is above 1, except by replication. But replication is not explicitly addressed in this work. This is one aspect to improve in future works. It is worth highlighting that composability is perceived positively if compared to the reference proposal. So, this result allows us to answer positively the research question number 2. And as future work, we plan to obtain feedback from more practitioners. We plan to apply the proposed process to design a fluid-fetched digital twin architecture in the healthcare domain to check its actual impact on real-world development. We also plan to conduct a formal case study evaluation to identify the main issues in the existing process, and we of course, will refine the proposal. And that's all from my side. Thank you very much for the attention.
Questions from the audience? Yes.
Hello, it was a great presentation. I noticed you didn't mention anything about ubiquitous language that's usually associated with the domain-driven design. Were you planning to do that maybe afterwards, or?
The language, do you mean the the language.
Ubiquitous language, because usually when you do domain-driven design, you make general models so you can design with
Yes.
project managers, with business people, because you don't want to go into too technical details, and that's also great maybe to...
Oh, so do you mean a glossary of terms to share with people from business, or I'm not
Yeah,
sure
because
if I understand.
you need a language that everybody understands.
Oh, yeah.
You know, because project managers know nothing about domain model, they don't care.
Yeah, they don't understand nothing about the model, but they understand the domain.
Yeah, that's what I'm just trying to say. Maybe,
Yeah.
Just maybe mention.
Yes, so the first part in architecting the digital twins is understanding that the architect has to understand the domain language that the business people is using, yes, of course.
Thank you.
Good morning, thank you. I was wondering whether you can explain again the evaluation, the comparison, because maybe I missed it, but I understand that you compared domain-driven design and then the 5 dimensions. That was not clear to me. If you can elaborate a little bit, thanks.
Yep. I had to exclude this slide with the explanation of the process for the evaluation, but the first step was selecting like a reference proposal, the most used proposal for architecting digital twins in all the domains that we have checked. And this proposal is called 5 dimension. It defines 5 dimension for the digital twins, the physical one, the logical one, also services and the data, and I don't remember the other one. For the connection among the different parts. And since this was the most used, we wanted to know if our proposal is more expressive, or it could be more suitable for architecting digital twins than this one. So the first part was that, and then we elaborate a survey, and the questions were, is this proposal satisfied this property? And the expert practitioners contacted had to answer with the level of satisfaction to every proposal. So this is the comparison method. I don't know.
Can you give them an example system?
Yes. The diagrams we have seen were made by one of the architects that were contacted at the beginning, and he designed the system, and we used this design for asking the others.
Thanks.
So thank you very much. To the second paper that will be presented by Sebastian. Yeah, it's an integrated approach to package and class code to architecture mapping in MAP. So, looking forward.
Yes, good morning, everyone. I'm Sebastian from Cal State University, and this piece of work is together with Sipani, who's a PhD student of mine, so he's the actual mastermind of this work. If you like that work, let him know. If you don't like it, well, I'm here till noon, so you can tell me. So I won't repeat this bulky title, but pick up on a few things. So it's obviously about code to architecture mapping. In the past, we developed two different versions of this. One is class-based and one is package-based. So that's what we tried to put in the title, and we didn't really succeed. So why do you want to do why do you want to do code to architecture mapping in the first place? And the motivation for that is architecture degradation, which we generally define as the continuous divergence between what we intend to do on an architecture level and what we actually do. So if we speak in general terms, this is about decisions that are followed up by wrong actions, so to speak, or decisions that follow up other decisions and contradict each other. But for this work specifically, we're talking about decisions regarding modularity. So we're talking about having something like a box and lines diagram depicting which models we expect, where we expect the dependencies to be, and where we prohibit them. So that's the specific context of architecture degradation for this work. And I'm sure you understand why we don't want architecture degradation. You want to assure certain properties by defining a proper architecture, and if you violate that architecture, the whole quality attributes are in danger, of course. One way to make sure that this doesn't happen too much is to check for consistency on a frequent basis. There are, of course, techniques out there, and I would say the mostly commercially most successful techniques are pretty much all the same. They say, okay, you have to define what your modules are. So you develop something like an architecture model or a high-level model, it's called in some approaches, which is manual work, hard work. Then you map your source code to the modules of the architecture, which is also manual work and even harder and more cumbersome. And then finally they do something automatic. They create something in the original approach called the reflection model, which looks very much like the architectural model, complemented with certain information like where are dependencies that we didn't expect and that we prohibited. So the red lines, arrows, there should be arrowheads, but you certainly get the direction. So this is the automatic step. Now the problem is most realistic systems don't consist of 5 code files. There are many more. Most realistic systems don't even consist of 25, but rather 25,000 files. There wasn't enough space on that slide. So this is still a lot of work. And for that, of course, there exist approaches to try to automate the mapping step, which causes most of the work. And we also notice in empirical studies, this is a real roadblock for people to apply such techniques in practice. 2 of these approaches, or one root approach, comes from our group. We called it InMap. I think it's short for interactive mapping because it's essentially a recommendation system telling the architect or software engineer in general, I think you should map this source code file to the following module. So it takes as input such a high-level model and your source code, and comes up with recommendations on a file level or class. Its prototype is for Java on a class level, where to map these things. And then the architect can confirm or accept and reject these recommendations. And after he or she has done that for a couple of things, the approach takes that information, refines the recommendations, and comes up with new ones again. So that's something we presented here at the conference 2 years ago. In the same year at ICSA, we proposed hierarchical InMap, which does pretty much the same, but instead for classes it takes into account the hierarchical structure in the code, packages or directories in other languages, and tries to map these things instead. So it makes suggestions of where to map complete packages. There was a certain trade-off. For the first one on the class level, we were quite happy with the performance in terms of precision and recall. We achieved almost perfect recall and also very good precision. And unfortunately, in hierarchical map, it was just the other way around. As you can already maybe guess, if you only map packages and you have mappings where you do something for individual files, these are definitely cases that hierarchical map won't get. So recall was lower, but also the precision, unfortunately. That was the motivation to come up with the integrated approach that we described in the paper for this year's conference. Just a few basics on how in-map conceptually works. So for each module, that's the rectangle on the top, and each file we compute a score. The technique is based on information retrieval. The score resembles kind of a TF-IDF score. And what we do is we interpret each source code file as a document in a corpus of documents, strip away irrelevant information and condense it to essentially the class name, method names, and a couple of other things. And then we interpret the module as a query, consisting of the module name, a module description, and everything that has already been mapped to the module. If you are somewhere in the process, in the middle, then you have things, class files already mapped to the module. The module description is something we exploit from documentation. That was the novel part of InMap. We don't really need some initial seed mapping to make this automated suggestions happen. In the beginning, we take a description of the module from documentation. And then we compute a score for each combination, and then take the highest scores for each file, and rank things. Don't want to go into details here. And the same for the package-based thing, where we do this for the whole content of a package and then look at the distributions a bit and make recommendations. For the integrated approach now, the question is really how do we deal with the scores that we get for individual files? How do we compare them with the scores for whole packages and stuff? So what we did for the integrated approach was to, in the first place, to modify the computation of the similarity score a bit. We consider possible naming conventions in the fully qualified name. If there are references to module names, we built that into the score. And we also factor in existing accepted or rejected recommendations of classes that are related, meaning having dependencies to the file that we are currently looking at. We don't do a full dependency analysis or source code analysis step here, because the technique as it is quite lean and just based on information retrieval, but we look at which files are maybe referenced in there, factor in a certain factor for related classes. The more exhaustive step or change was to develop an integration strategy in the sense of when do we recommend packages, when do we recommend classes, and there we go for the package recommendations first, because if you can map a package fully, then you get rid of 100 recommendations for the individual files immediately. We do that, of course, only as long as they are good enough above a certain threshold. And then we also have several rules that specify how the recommendations propagate, so to speak, through the hierarchy of packages, meaning we eliminate sometimes recommendations or replace some, which is essentially here. That looks weird, but let's go ahead. So assume we have a parent package P and sub-packages, and also individual files in that package, and we already have computed some recommendations for these children. And it turns out that for each of the children, the same module M1 is the best candidate for the mapping. Then obviously we replace that. Before we show them, user, it doesn't matter how good the score are, we replace these three by the recommendation to map the package P. In a similar way, or not in a similar way, the other way around actually, if we have rejected a recommendation for the parent package, then what we do is in the next iteration to definitely present recommendations for the children, as long as they are about a certain threshold. This means they also overtake possibly other higher ranked recommendations for other packages. Other rules include if children are mapped to different modules, there will no recommendation for the parent package ever. Doesn't make sense. So if on the left, if you have 2M1, 2M2, and 2M3, there will never be a good package for the parent. And if all children are rejected for a module, so is the parent implicitly. It doesn't matter how well the mapping would score for the parent, it will never be shown to the user. So we tried this out for a couple of open source systems. As you can see, they are pretty small, maybe a bit of goodwill, you can say. Some are medium-sized. The point here being, what we need for an evaluation like this is a validated intended architecture, a model of that. We need to know what are the modules, what dependencies are allowed, and we need a validated mapping so we can compare the results of our approach with that. So it's pretty much a set of 6 open source systems that's used a lot in our community for doing that. We collected a couple of metrics. There are even more in the paper, but I think these are the ones that really matter. We looked at the code coverage, meaning how much of the code in terms of number of files or classes are correctly mapped as a relative number. We look at the recommendation precision, so what's the relative number of correct recommendations, and we look at the actual effort, which means you need to check if the recommendations are right, that causes certain work, and then you have to deal with everything that is unmapped. The results for that are okay-ish, I would say. In the class-based InMap, the classical one, we still achieve very good values. 97% of the code is covered. The average precision is 86%. And if we set, we set the actual effort here to 1 as a comparison, as a baseline for the other ones. Package-based, as expected and shown in the past, drops in code coverage by 10%, and also the precision is lower, as I explained in the beginning. But we have a lot less work to do, just 18% of what you do when you do the class-based mapping. And as we hoped, the integrated approach lands somewhere in the middle. So code coverage is, fortunately, still a bit more towards the package-based mapper, but the recommendation precision is actually quite good, moving more towards the class-based performance, while not increasing the actual effort by too much. So I think you gain more than you have to pay here using the integrated approach. As a conclusion, we think that's another baby step in automating the mapping activity and architecture consistency checking. And of course, we would like to go further here. We still have problems in certain types of system decomposition. What I mean by that, if you, for example, have a system where you have, let's say, a framework part of the system, and you model a certain abstract module where you have interfaces and the abstract classes, and then you have another part of the system which implements that part of the framework in a certain way. This causes dependencies and similarities in naming that are hard to resolve at the moment. So there we get still some false recommendations. Well, we get the right one in the end, but you want them immediately. Then we would like to measure real efforts, of course. Here we have a model kind of where we assume comparing or checking a recommendation is simpler than coming up with the right mapping yourself. But how does that really look in reality? Furthermore, An interesting setting will be where the architectural model and the mapping are developed at the same time in iterations. Right now we assume the model is set and then you do the full system mapping like you have a legacy system and want to do consistency checking after decades of development. But what if you do that in a more incremental way? And last but not least, we would like to come up with more advanced recommendations saying things like map this package to module M1 but these 2 classes, or map everything in these 4 packages to a certain module. So still some things to do. Maybe you have more ideas. I'm open for questions. Thank you.
Yeah, thank you for the really interesting talk. I liked it. Well, my question is whether the intended architecture has to be perfect in the approach, or whether it would also be possible to think about just having some partial or even uncertain information there. And maybe for the background, I'm asking because we're looking at interpreting sketches of architecture diagrams, and then probably you might have question marks or even mistakes in the extracted intended architecture. Would that make sense to combine, or would you say no, it has to be certain and trustworthy, the intended architecture?
I think it makes perfect sense and goes towards what I mentioned for future work, the more realistic scenarios of how these models and mappings are developed. So that's what we observed in workshops, that people start creating 1 or 2 modules, then start mapping these, and then they see, yeah, okay, that's all right, and now let's go to the next one. So I think it's a lot about imperfect information and incomplete.
Yeah, in general, probably the intended architecture could be outdated somehow. It would be nice to recommend even changes to that.
Yeah, more
sometimes,
likely than
not
yeah.
so often, maybe.
Yeah.
Okay, thank you.
Other questions? I have one on the usage of the threshold. I was wondering if they are global or should be defined differently because you compose in a different way. So the thresholds that you were mentioning on the propagation of the rules.
Do you mean system global or?
Yeah.
Yeah, at the moment they are global per system, but you
Would
can
make sense to set them differently according to the parts?
I think it's already hard to set the thresholds well enough for a system. I think it will be even harder to do it on a module per module basis.
Exactly.
But it's, yeah. No, I think there are still also other parameters for the approach. I'm not sure if adding 1 for each module will be usable, to be honest.
So thank you very much. And we switch text. Thanks. So we go to the 3rd paper. And it's about recommender systems. And will be presented by Andres Diaz Pache.
Yes.
Yeah.
Hello, everybody. I'm Andres. I'm from Argentina, from University. And this is a joint work with my colleagues, Hernan, Santiago, and Claudia. This work actually was part of Hernan's PhD thesis. So the main situation and the main motivation for this work, Hernan was working a lot with developing JavaScript applications, and one of the challenges or things that you have to deal on your daily programming and developing and designing tasks is how to select different technologies, different libraries, frameworks, APIs, and combine them in your design or in your code to meet some, satisfy some functional requirements. So it's been argued that this task is very challenging for JavaScript developers because of the landscapes and the different alternatives that you have for the different problems. Technologies are evolving almost every day, so it's more like, I mean, some people call them like, this is more like a technology fatigue. They call this situation, to me it's a little bit of exaggeration, but it gives an idea of the problem that you have in order to select and filter and compare the features of the different technologies. To alleviate this problem, there are some search engines, specifically for JavaScript, like in npm compare or npm, in which you can get some comparison or some short list of alternatives that you can use for a problem, but sometimes these engines are not very effective. Of course, you can always resort to some like general purpose engines like Google or Bing, or maybe now ChatGPT. But these engines have their own pros and cons. And this is a small example of how the situation may look like. For example, if you want to get some code for extracting a barcode from an image and then use that in your website, you may use npm, for example, and write some query like I want to extract a barcode from an image, and then you may get some technology, for example, ByteScout. But then when you look at the features, you discover that this is a paid service in the cloud, and you don't want to spend money on that. Also, you may discover that the service is not very popular or may have some bugs. Then you try your search again, and then you may get another alternatives, but maybe those are not well maintained, not very popular, and so this story goes on. And at some moment, you may decide to go to a different engine, and maybe you get this QAGA library that seems to work better, but then you go back to the other engine, and then you see the features of that technology. And so this process goes on, and maybe challenging. I mean, it's not super difficult, but it's difficult to get the right technology for you and to do the comparisons. And these technologies are always evolving. So the idea with this work was to assist the developers, providing some recommendations, or as we call it, like some technology selection problem, in which you can get a list of the most relevant packages for your task, and then use some tool to do a quick comparison of the features. So what we did was try to combine information from different sources, from different engines, basically, and on top of that, we look at the features, and we use some machine learning approach to try to learn some of the comparisons among these alternatives. I mean, using machine learning as many people do these days. So we created this recommender system that works in two phases. We have one. The first phase is on my right, that is called ST retrieval. ST comes from selecting technologies. And then on that part, we initially get a first list of candidates, basically combining outputs from different search engines. So that's not the most difficult part. And then on the second phase, we try to create a machine learning model that learns how to rank these technologies, or hopefully refine the outputs of the previous stage. We also consider some constraints on these technologies, like if this technology is going to be deployed only for a browser or only for Node.js, or there's no constraint for the technology, because in some cases we need to look at the constraints of the technology in order to use it in your application. So let me give you some details of the first phase. First, as I said, in this first phase, our developer, our designer, submits a query to the different engines you have available. In this case, we use npm compare Google and Bing. And then you get different lists and different rankings of technologies, and then we use some strategy for combining those results. This is more or less how it looks like. So you basically get, for the same query, you get all the list of technologies. For JavaScript search engines, you just get the names of the technologies. When you use the other search engines, as you could imagine, you have to do some processing of the pages that you get, and do some entity recognition in there, and pick the technologies automatically from the pages. So it's a little bit more complex, but still doable with the technologies that are available today. So we call this kind of search is called a meta search strategy, which is well known. And at some point in the end, we do an aggregation of the rankings. So this is how it could look like with npm. So for example, for our query, we get the top 4 results are these libraries that are shown in there. And then if you do something on Google, for example, and this is from 2 years ago, probably. Then you get this result that you may get some duplicates, so you need to remove the duplicates, as you could imagine. And then we use different aggregation functions to do the merge of the technologies. In particular, the one that seems to give the best result was this Bordafuse method that basically considers each engine as a voter, so each engine is given a score to the different technologies that you get in the list, taking the length of the lists, like, hold the point here, would be here, yes. So for example, if our list has 3 elements as the maximum of the elements that you can get, and for example, here you get 3 points and then 2 points, and here you get all the other points, and then this method simply aggregates all the scores for each of the technologies, so you could get this ranking. This is not the only way of doing the aggregation of the result, but it's one of the most well-known ways of doing this. And of course, you can do it differently. Remember that in this phase, we are just creating a first list of candidates, but this is not like very intelligent combination of things. So this is the output. Sorry. This is the output for the first phase, and then we try to give this list to the second phase of the recommender system. In this case, for learning this model or for building this model, we collected information from many different projects for JavaScript from GitHub and NPM, and then we did this offline, and then with that information, we built the model. So the first part of the model was trying to get all the features, the different features of these projects, like the usual features that you have in this project. For example, number of downloads, number of contributors, number of issues, number of stars that you have in the project. That is a proxy for the popularity of the project. Also, we were taking some metrics from the code as well. And we also look for each project at the different technologies, JavaScript libraries that were mentioned in the project, and also link these two alternatives for that, the same technology, using like a huge knowledge base of technologies. So we created this matrix. And in order to assess the popularity of the project, we use a metric called, this is a proposal, we propose this metric that we call it CDCEL, basically stands for Community Degree of Selection. And these metrics try to assess how a technology is used in different projects. So we put some metric for that, and we look at the project based on the popularity, and then we were taking into consideration if the technology was used in the different projects and basically the popularity of that project, and then we were aggregating all these scores. So this metric is based more like on a ranking of the technologies. And based on that, we create rankings for the different technologies. We call them training rankings because for each technology and their alternatives, we were creating these kind of rankings here. And then with this information, we assembled this data set. In order to learn the ranks, we use a technology called learning to rank that is basically used for this kind of task in which you are interested in learning the relevancy of the different packages. There are different variants of learning to rank. We use a variant called pairwise, which basically is a binary supervised task in which you put the different pairs of the technologies as a row, and then for each one you need to decide if the first one is more relevant than the second one, then you put a 1 and you put a 0 otherwise. So we created this data set, and we use this ranking was based on our metric. And then there are different algorithms for doing this. We just pick one, the GB rank, but nowadays there are other alternatives based on deep learning for doing this kind of task. And then we did an evaluation of the whole recommender system. So the first part, as you could imagine, is we need to assess somehow how if the rankings, when they are combined, are better than the rankings that you get individually from the search engines. That was our first research question here. And the second one was to assess if, when you have the combined rankings and you go into the second phase, if the rankings or the re-rankings that you get in that phase were better than the alternatives that exist today. I didn't mention that part, but NPM use internally a technology to do the assessment of technologies. This is based on AHP. So we made a comparison of our technique using machine learning against ASP. So I'm not going to show all the details of the tables and the figures. You could get those results in the paper, but basically I will show you how we did the setup of experimentation. For the first question, we initially got an initial set of queries. We asked 2 senior JavaScript developers to produce these queries, like I think 35 queries. And based on those queries, we run all the search engines, we get all the packages, and then we have also some people to assess the result of the packages to see if the packages were relevant for the queries. And then we took some metrics like precision and number of hits to see if the results from the engines and the packages and the combining strategies, which one was giving the best result. In this case, the combined rankings were a little bit better, like depending on the case, between 20% and 30% of improvement, which is something that we expect here, because if you get individual rankings and then you do the combination, statistically you should get like at least some improvement or at least the same results. So, but this was necessary to check or to go into the second research questions when we evaluate the second part of the recommender system. For the second part, as I said, we gather like 1,000 projects from different projects using JavaScript technologies. Then we use these 2 JavaScript to create some rankings of the alternatives of the technologies. That's what we call here reference rankings, because we needed to assess if the rankings given by the machine learning model were good or bad, and there was no way to tell that, so we had to create our rankings here. And then on the other hand, we automatically created, out of this repository, we created these training rankings for the model. So then we used GPRank to build a machine learning model. This is the automatic part. And for these rankings, we also feed them into all the other alternatives that were NPM and NPM compare, that uses it doesn't use HP, it uses one that is weighted average method. Basically, you are weighting all the different features. One thing that I didn't mention here is that these 2 tools take into consideration a couple of features, but here we are taking like 500 features of a project, so this the amount of features that you get here is much larger. And then we took some metrics to assess the quality of the rankings. Here we also obtained some results and best results for our method, like again between 10% and 13%, and some improvement. In some cases we got up to a 30% of improvement in this is, remember that we are looking basically at the first position of the ranking and see if we get the most relevant package in the first part of the ranking. So this is not, if we are not saying here that the package that you get are the best package for the task, as judged by a human. We are saying the package that you get at the top seem to be the most relevant ones for that query, which is slightly different. So in this kind of, and I will be wrapping up in the next slide, for this kind of work, we discovered that using this engine gives better results than the traditional existing engines that you have for JavaScript. Maybe in the first 2 or 3 positions you get the same results, but if you want to expand your search up to 10, let's say 10 packages, then you get better results. Of course, depending on the query, you may get some variations. And we also have some threats to validity in this experiment, like, for example, the choice of the queries that we use. So I said we work with 25, 35 queries, but that could be not representative of the whole spectrum of queries that you could have in your development task. Also, for this metric, as I mentioned, we use this CD cell metric that as a proxy for popularity of the package, and we could argue if this is the best metric to judge the popularity of the package, or we could be using something else. And another thing that we did here for simplifying the experimentation was we did everything in a batch mode. Basically, all the results, so this recommender system works in a batch mode, so you get all the results first and then you do the recommendations. We would like to do this in a more online fashion, so that's part of our current work now, because that's the real setting in which the developers would be using this kind of recommender systems. And something else that, I mean, we got better results with our recommender system, but we still don't know which features are the most important ones in the performance of that recommender system, so we need to further investigate that. And this brings me then to the conclusions. Basically, with this recommender system, we wanted to help developers to find quickly very good candidates for their queries. The queries that we were using were mostly functional ones, so I need to solve this functionality. So one idea that we would like to do now is to expand this query to consider some other information than typically quality attribute information for these libraries. We need to see how we can map that information to the feature of the packages. Another thing this is an ongoing task now, that we would like to conduct a user study with JavaScript developers to test this recommender in the field and not just like an offline experiment. Although when we have to use these developers in the evaluation, they were in some way judging the relevancy of the packages, we would like to do something larger or with different case studies. Also, within the same kind of technology or same kind of idea could be extended to other technology selection problems, like for example, selecting big data technologies or maybe some other kind of packages like Ruby or Python. And the last thing that I mentioned before is that we like to have some idea of which are the features that are mostly predicting the relevancy of the packages, and for that we are planning to use an explainability mechanism, as many people these days again. And so this is it for me now. Thank you very much. I'm happy to take any questions you may have.
Thank you for the really interesting talk. I have one question about the ground truth, the ranking that the experts produced. And usually, or sometimes as a human, it's hard to do a ranking and you say, okay, actually, like the third, fourth, and fifth, they are all the same, but there is quite a difference to the third one, for example. So was it possible in the rankings to say something like that for the experts, that they would say, okay, this is the first, the second, the third, then there is a gap, and then the other three are good, and then there's another three? Or did they have to strictly rank the approaches? And if not, maybe that would be interesting to look at whether this maybe improves even more the results if this input ranking is not strict.
Yeah, you're right. Well, because of this pairwise way of working, they were given pairs and they will have to decide this one is better than this one. And that's because that's the way we do the tagging and this technique works. And also in other rankings or for the query, they have to say it was like a binary answer, like this is relevant for this query or this is not relevant for this query. So we were not that deep into why the one is better than the other. But yeah, it may be interesting to look at it as well.
So they couldn't say, okay, they are the same. They always had to choose.
Yeah, they have to choose.
Okay.
In some cases, they could say they are the same, but it was we didn't allow them to give a lot of context in the responses. That's like, why is this better, or they could do something, but in the end, we didn't take that feedback into consideration.
Yeah. Then one thought for the future work, actually, probably that would be interesting then to also compare to ChatGPT. What it does as a baseline. So what can it do? Is maybe there you could even already ask about the quality attributes as well, and it might take it into account. So that I think would be really nice to compare as a baseline.
It's a very good idea. Because, we started this work 2 years ago, and now when I show this last part, I say, well, maybe, or even in the first part when we are collecting from different information sources, we could ask ChatGPT to see which are the relevant packages for this query. Yes.
Yeah. Okay. Thanks.
Thank you for the talk. I have a question about, you present in one of the slides Stack Overflow, and you said that you made some ranking and So my question is that,
this one?
No, it was an earlier slide where you showed Stack Overflow and the results of it.
maybe.
Yeah. This this. It doesn't matter now.
Yeah,
but
okay. Sorry.
The most important that in Stack Overflow the discussions are mostly on more than one technology. Like they compare multiple technologies together. For instance, you have, for example, Apache Kafka and RabbitMQ, and then you find in the discussions, okay, if you care about performance, then you go with Apache Kafka. If you want good documentation, then go with RabbitMQ. Okay. So my question now: you make your ranking based on technologies. Yeah. So I was wondering, how did you get out the technologies from the Stack Overflow?
Yeah, I understand. Yeah, for this kind of general purpose search engines, we were looking at the technology, like an entity recognition problem, and then we have some rules, some additional rules on top of that to look at the technology. But we didn't go in that level of detail, that understanding if the text is saying, if you have this problem, then pick this one. We didn't go into that. But I see the point, yeah, that the condition for using this library could be saying something interesting about the rank, or we would just discard the technology, because the way this is explained is saying don't use this for this, and then we shouldn't get the ranking.
Okay. Maybe another point for the evaluation, if you want to extend this work. You said you evaluated the results based on the query. Okay. Maybe a better approach or a standard approach for information retrieval to evaluate the results based on the task. How relevant is it to the task? So you can find in the literature some already created tasks, and this can maybe help in evaluating the approach.
Yeah, thank you. Yes, a good idea. Yeah,
okay.
We'll look into that.
Thank you. My question is, do you have any plans to build in something that explains the ranking to the user? And in terms of informed decision making, I probably would like to know, okay, why should I use this? Not only that I should use this because it's on the top of the list, but why? Because if it's a reason that doesn't matter for me, because I don't care about great documentation or something, then I would pick something else.
Yeah, that's the idea that I was mentioning at the end, that we will like to look, first of all, at the features, at least to say which features are most relevant for picking this, or for suggesting this package for the task. Also for doing some debugging, because at some points we felt like, it was not clear why this package make it to the top 10. So we would like to see there's some need to do some adjustments in the algorithm, but yeah, definitely we need to look into explaining why some features are more relevant. In the current search engine, this is all basically, they have a very fixed, a small list of features, and they just put some weights on the features, which gives some explanation, but then the number of features that you get is very basic. So maybe they are not, I think, connecting to the other question, is they are not looking at the task of the need that you have with that library. Thank you.
Okay, so let's thank the speaker. So we move on to the presentation. It's a new idea paper, and it's about ethics and decision making guided by ethics concepts.
Hello everyone, I'm Razi. I'm a PhD student at University Amsterdam and ICSA. Today I want to present Ethics Ever Decider game, which is a game to enable reflection on ethical consideration when making architecture design decisions. Let's get us start with, what is ethics in the context of software engineering, or SE ethics? Actually, SE ethics refers to a set of principles that help software professionals to adhere to welfare, justice, and privacy of society and individuals. Why do we care about SE ethics? Because as you may know, software system over the last decades caused many ethical issues. Let me bring you an example. It has been reported by many persons that black and dark skin persons fade into the virtual background on Zoom because the use algorithm are not able to detect faces of dark complexion well. To address such issues, actually, there is a need to take into account some ethical considerations at the earliest stages of system design. I mean, when making architecture design decisions. By ethical considerations, we mean stakeholders, ethical concern, ethical values, and ethical decisions. So in this study, we aim to enable reflection on such consideration among software architects, when architecting software systems. To reach this goal, actually, we designed a card-based game that we call it Ethics Over the Site Art game. That is a redesign of a game that was proposed by Patricia Lago a few years ago. And yeah, we customized this game from an ethical perspective, and we are using, to reach our goal. We played this game in 2 international IT companies in 4 sessions, each including 4 professional software architects. Okay, let me explain about the game. For designing a deck of cards and templates, actually, we used a case that is called discrimination by design. This case is about tuning a library management system that wants to avoid some female categories, wants to avoid the access of some female members to some categories of book, like feminism, women's movement. And based on this case, we designed a deck of cards and templates. And in the next slide also, I will explain about the game setup and how we need to play the game. The first card is project card. This card actually describes the context and the purpose of the system. Another card is a stakeholder card that it describes the role of game players that is based on 3 overarching stakeholder roles. I mean system user, system development organization, and indirect stakeholders. That in this card we are explaining about the goal of each stakeholder and a list of values that each stakeholder may concern with. Another card is the ethical value card that it describes an ethical value term along with its definition. This card can help players to have their own values. 2 other cards are ethical concern card and white card. Ethical concern card actually describes an ethical concern related to the system. It includes also an example of solution that each player needs to provide to resolve such ethical concern. And players also need to say, okay, this solution have some effect on some relevant values, for example, by saying the impact is very positively or and negatively, and so on. The white card also provides an opportunity for players to express new concern. Oh, what I did, okay, sorry. And the last card is the event card that it describes an unpredictable event along with the consequences of this event on some relevant values. And also we had some templates for recording decision and the rationale behind this decision. One of them was for each player, and another one was for the group to make a collective decisions. Okay, for the game setup, as you can see, we had 4 players. This is just about the arrangement of the cards and template. Yes, and just one thing, because the game was role-playing, players had to identify their role at the beginning of the game because they needed to play based on this role. And for playing, just consider player 1 wants to start the game. She or he actually needed to take 1 card from the stack of ethical concern and white card, and each player needed to provide a solution for resolving such concern, as you can see. And after that, they needed to discuss in a group and select the best solution for resolving such a concern. Okay, in a similar way, each player actually needed to take 1 card from this stack. And after each player played once, or in another words, if after actually 4 ethical concern addressed, the group needed to draw one event card from the stack of event card to see, okay, what can be the effect of or consequences of this event on the previous made decision or also on the future decisions. After doing all of these things, it means that one round finished, and if a player had time, they could also start a new round. Okay, and to see if we reached the goal of this study, actually we used 2 research methods, one participant survey and another one qualitative analysis. And based on this method, we found this result, that the game could enable players to reflect on the different solutions to resolve ethical concern. In between, we observed that, okay, the game also is helping them to bring the agreement and disagreement points to the forefront. And also, the game prompted players to make ethical decisions and provide reasoning behind such decisions. We detected 3 types of ethical reasoning. One was about a value trade-off, another one was about the weaknesses and assurance of decision from an ethical perspective, and the last one was about the certainty and uncertainty of decision from an ethical perspective. And the last finding is that the game enabled players to reflect on value operationalization and value trade-off by different ways. For example, by enabling them to discuss importance of different values, by discussing value conceptualization, by discussing negative and positive effect of solution on values and quantification of these effects and so on. For the future plans, actually, okay, we want to do maybe a larger data collection, or providing a list of value conflicts that they are common in the architecture design, and also finding a new way to orient discussion around ethical considerations when we are making architecture design decisions. Yeah, thank you.
Questions from the audience? So I can start asking?
Yes.
So when you were showing about this decision and how to then decide, how do you see the interaction?
How do you see the interaction among the participants of the game? Is there?
Yes, as I said in the result, actually we saw many agreement, disagreement between them. That this agreement also was around 4 points actually. For example, which solution can be helpful? For example, they didn't have any agreement on such this kind of things, or they had also agreement and disagreement about the values that can be affected by this solution, or the positive or negative of the effects or quantification of this kind of effect. They couldn't have, sometimes they couldn't reach the agreement, and they had to just, just say, okay, just let's select this solution. Maybe in another, for addressing another concern, we can just, satisfy, for example, player 2.
I was thinking, besides agreements or disagreements, some kind of coalition, so that they somehow try to collaborate and then kind of have subgroups of participants. Does make sense to look for friends and enemies in the group, something that groups the participants. I don't know, and it's a question.
I didn't understand very well.
So instead of agreements and disagreements, I was thinking more in the direction of forming a coalition, so kind of group of participants that can collaborate to make then stronger their decision. So 2 or 3 participants, they decide to form a group and kind of being, I don't know.
Yeah, it can be also, yeah. But yeah, we didn't consider these things in our
yes, future
Yes,
consideration.
that's true.
Further question from the audience? Yes.
Excellent idea. I'd love to play it one time. In your presentation, you have a setup of 4 players. Is that the optimal size, or can it be scaled up or down? Or?
No, actually, there was no any, restriction for that. But, the ideal size of, we had to also care about the time and, just they want to discuss. If we had more participants, maybe it was so difficult, to get an agreement at the end. Yeah, but also it's possible, maybe to 4 also we can increase the numbers. Yeah.
Hello everyone, my name is Mohammed Suleiman. I am a postdoc in the University of Groningen, and I'm going to present to you today an exploratory study on architecture knowledge in blogs. But I'm going to start with my presentation with the question why we have chosen to explore blogs. The motivation for this came from a previous study which we have conducted 2 years ago. Specifically, we asked software engineers to resolve certain architecture tasks and to find architecture knowledge using the most popular web search engine, Google. And for this, they searched in Google to solve their tasks, and they found results from Stack Overflow, from technology documentation, from GitHub, and also from blogs. And what was interesting in this, that blogs showed to have the most architecture knowledge. It also showed to be the most retrieved by Google. So this motivated us to study architectural blogs more specifically, given that also Google had a lower precision to find architectural knowledge. Also, this study provides us with the data set of 718 blog articles evaluated from software engineers from being relevant for architectural tasks. The first challenge we faced in this study is that blogs are a big of mess. So blogs are different than Stack Overflow. Like Stack Overflow is just a single website which you go there and you can find the posts directly. But blogs are everywhere, thousands of websites. So there is no category. We don't know what types of blogs exist. And this came the first question we have: what are the types of architecture blogs? So I'm going to present the most top 3, and the rest you can find in the paper. So the first or the most popular one is what we call community blogs. And these are open platforms where software engineers can write blogs inside. The most popular one is the D-Zone and the Medium platforms. The majority of them are open for all the topics, but there are also certain platforms which are specific for certain architecture topics. For instance, data integration info is a platform for just data integration design issues. The second type of architecture blogs is called technology vendor blogs, and these are hosted by technology vendors such as SAP or Microsoft. They have their own blogs, and the content of these blogs focus on their products. The authors of the blogs articles are sometimes even the developers of these technologies or experts for these technologies. The third type of architecture blogs are personal blogs, and these are focusing on the personal experience of software engineers. So they simply create a blog for themselves. They write their experience about architecture knowledge inside. The most well-known one is the one from Martin Fowler, but there are many, many of personal architecture blogs. So the takeaway from this results that blogs are very diverse. They have different authorship and different policies for hosting the articles. Google retrieved mostly community blogs and technology vendor blogs. Okay, we now have some map about what types of blogs. We want to know what architecture knowledge exists, so we want to know what are the topics discussed in these architecture blogs. So to answer this question, we analyzed the data set we have using grounded theory, and specifically we found 5 topics for in the architecture blogs. I'm going to present 3 of them for the time now. The first is to elaborate and evaluate a solution, and for this topic of blog, the blog article focus on a single architecture solution. Could be technology, or it could be also a pattern or an architecture diagram. And the author of this blog evaluate this solution. For instance, in this blog article, from Neil Brown, he evaluated the Amazon SQS. He spoke about its feature, and then he kept listing, evaluating these technology regarding latency, availability, scalability, security, reliability. This article is tens of pages, so it is a very long article for evaluation. Another topic of architecture blog is about how to design. Okay, these are types of blogs which try to provide certain guidelines or rules on how to design a certain architecture for either a certain domain or a certain types of technologies. So the content of this blog focus on provide these rules or steps, and also support these rules and steps with certain use cases which you can apply. Like here is the content focus on the routing topologies for performance and scalability with RabbitMQ. It presents the problem, it provides 2 solutions, and then it presents certain design rules when you select which solution at which time, and after this there are a list of use cases which are discussed in this article. The last one I will explain is the how to implement, and this is different from how to design. How to implement provide the architecture and explain how can you implement this architecture in practice. So it focuses on moving from the modeling or from the architecture to the code, and for this sometimes the source code or snippets of source code are provided to show how to implement a certain architecture. So these are the 5 we found using the qualitative approach we followed. During our analysis, we found out that architectural blogs are very involved. They are spent in tens of pages. It is very hard to analyze each content and each line of the architectural blog, specifically using qualitative approach. And that's why we adopted a second approach to explore the topics of architecture blogs. Specifically, we followed a topic modeling using LDA to explore the topics in architecture blogs. If you know what LDA take as an input is the set of blog documents or articles, and also the number of topics which we expect to identify. As an output, the blogs are categorized based on the topic. However, topic modeling cannot tell you what does each topic mean. In order to know this, you need to determine the most important keywords in each of these topics. So, based on these keywords, you will understand what the definition of these topics. We applied this approach, and then we got these results. We got the result that there are articles about JSON and other about MessageMQ service, microservices, messaging, Kafka, and data analysis. However, these are not the topics we are looking for. We want to focus on architectural knowledge concepts, like patterns, components, connectors. This is what we want to achieve. But the topic modeling are biased using these terms, or technological terms. So to resolve this problem, we introduced an extra pre-processing step. Specifically, we used an architectural knowledge ontology from Stack Overflow. We replaced these technological terms with the respective architectural knowledge concept in the architectural knowledge ontology. And we ran again the topic modeling algorithm. And from this, the definition of each topic is not just the terms, but also ontology classes. So each topic is defined using ontology classes and also terms with it. And accordingly, we got finally more reasonable results. So for example, here the first topic has a patterns and component and has architecture design. And accordingly, this is design using patterns and components. The other topic has components, connectors, and terms about quality attributes. And these articles try to achieve quality attributes using component design. And accordingly, we defined the other topics using the topic modeling. So now we have 6 topics from the LDA and another 5 topics from the qualitative topics. So it makes sense that these topics match each other and are related somehow. We conducted a significant test to determine this. We find that some topics are actually respective and to each other, like here, comparing solution, compare and evaluate technologies. These are respective to each other. But also some topics complement each other. For instance, you find how to implement technologies and components significantly co-occur with elaborate and evaluate solution. This is happening because in order to evaluate an architecture solution, sometimes you need to implement it. For example, to make a benchmark. So these relations somehow complement each other to support us to understand the architectural knowledge in these articles. We also determine the significant co-occurrence with the types of blogs. So, for instance, we find that personal blog focus on how to implement and implementation technologies and component design. We also found that community blog focus on patterns, on architecture patterns. So our takeaway from the 5 minutes for the best paper. Our takeaway from this that architecture blogs involve certain special topics, especially about patterns, how to design, evaluating solutions. And also using LDA and architecture knowledge ontology provided reasonable results which can be reused to classify other sources of knowledge. Certain types of blogs are specialized in 1 or 2 topics. The third question, I will go into it quickly given the time constraint we have, that the topics we identified, maybe you asked the question, what is the benefit of these topics to the architect? For this, we evaluated the benefit or the relevance of these topics to 3 of the steps of the attribute-driven design. So, for instance, here for the identified design concept, where you try to find solution alternatives for a design problem, we find that you can find that in the blue lines, these are the numbers of articles retrieved by Google, and the violet ones are the relevance given from the software engineers. So we find that the amount of returned topics are really similar in all of them. However, the relevance is different among the different topics. This shows that Google is not optimal in determining the topics specifically for this design step. In the second step, select design concepts, we try to compare different solutions. And for this, you can see that compare solutions is the most retrieved, but also the most relevant. Others are having similar relevance. However, there are some topics returned by Google which should have less relevant and should be less returned by Google for this design step. Accordingly, this is the we can have the takeaway that some topics has a more benefit for certain design steps than others, but also that web search engines need to be improved to find the right topics for the right design step in order to improve the effectiveness of them. In summary, okay, we found the types of architecture blogs, the topics of architecture blogs using two approaches, qualitative approach and using also LDA. We also determine the benefit of these topics or its relevance to the different design steps of from the ADD process. And with this structure, we try to provide this structure to support researchers and practitioners to find architectural knowledge in blogs. The future work tends to improve the searching for architectural knowledge in blogs. For instance, architecture blogs are not tagged, so they are everywhere. You don't know if this blog article is about architecture or is about coding. So tagging architecture blogs, automatically classifying architecture blogs based on the categories we have identified, re-ranking architecture blogs for the search engine. Finally, also extracting the knowledge in these architecture blogs and sharing it with software architects and integrating this knowledge with other sources like Stack Overflow or also other software repositories. With this, I'm done with my presentation. Thank you for your listening.
Thank you for a very good, clear presentation and interesting work. While the focus of the work was on what is out there in terms of their types, but an interesting question is, who reads these blogs? Did you get any insight, or is there any, maybe coincidentally you hit ones that were more popular than the others? Do you have any insights into that?
You mean who reads these blogs in...
There are definitely a lot of writers, it seems, on software architecture, but who are the readers and what is like...
You mean...
the ones that were maybe more read by developers, software architects, and whatnot?
You are speaking about the authors,
Yeah.
like we
no,
analyze...
readers, who read? The audience. Who's the audience?
Yeah, we didn't investigate this point, okay, like who read the blogs itself, okay, but also it is like how can we know who search in Google and read the article, okay, at the same time. So this is a bit hard to know, but maybe possibly from the, some articles has comments, but not all. Like some articles have comment, possibly we can know from them. So yeah, this can be maybe the way to go if we want to answer what you ask for.
Yeah, and if I have time, a follow-up question. How about the correctness of the information in these blogs?
How about what?
Correctness. Like quality of the information.
From the data set we had from the previous study, we had a relevance from 1 to 5, a Likert scale. We excluded all the articles which at 1. So we had actually more than 1,000 articles. But we had to exclude about 200 articles because of this point. Okay, then we have from 2 to 5. Okay.
We have another question there.
Hi, very nice work. So I was wondering, used manual coding and at the same time LDA, so kind of automated coding, and I was wondering why. So it's like a scalability issue that you try to address with the automated coding, or
no,
you missed something as a coder and so you had to intervene automatically?
Yes, I will tell you. The blog articles are large, some of them, okay, or actually many of them are quite long, like we're speaking about tens of pages, okay? So indeed, the article has a topic, has a general topic, but the content sometimes deviates right and left and they discuss lots of things inside, okay? There is not really, it is hard to analyze everything, okay? So with the qualitative analysis, we were able to find the high-level idea of the topic, okay? But if you want to apply qualitative analysis for each sentence, then you need to annotate each sentence. You cannot, it is time-consuming, you cannot do this. Like we did this before in Stack Overflow, which is okay because a post is 1-2 pages, but a blog is 10 pages. So you cannot do this. So we had to automate the process. Okay?
So last question there.
Thank you for your presentation.
Yeah.
I suppose that you consider only blogs written in English.
Yes.
Yes. I'm asking this question because, for instance, in France, there are several blogs on the topics, but they are in French.
Yeah.
Do you think it's worth to look at other languages? Why I'm asking this question? Because I think there is also the culture behind that can give different results. So do you think it's worth? And if yes, do you have an idea how you can consider other languages?
Yeah.
Thank you.
Indeed. Actually, when we conducted this, the previous study, it was conducted in Germany. Okay, so because it's conducted in Germany, when you search in Google in Germany, you get also German pages. Okay, but we had to for this German page, we could classify them in a qualitative manner. But if you apply LDA, it is hard because then LDA will be biased to the German terms. Okay, so we had to exclude them, unfortunately. But your question is valid in terms that if you want to focus on another language, you need to collect data just from this language, or you find a way to translate. Not sure if this will work with the technicality we have. Okay? Thank you.
So we don't have time for other questions. Let's thank the speaker. Now it's time for the second paper.
Dovrebbe essere aperto sotto.
That is titled What a Concept of Organization by Vincenzo Grassi, Raffaella Miranda, e Diego Perez Padassin.
Sì.
And Raffaella will present.
When we have the full screen, forse in vista, se tu vai. Ok, thank you. Sì, grazie. Thank you, Patrizio, for your introduction. And indeed, this is a joint work with Vincenzo Grassi and Diego Perez. And I will show you our first result towards the characterization of anti-fragile system. So, as we have heard in this day, one of the main challenges when dealing with software architectures is being able to deal with quality attributes and to evaluate them. Quality attributes such like performance, energy consumption, reliability, and so on. And we believe that it is important to have a common vocabulary describing clearly the terms to which we refer and the system aspect that each term describes. So let us take, for example, the dependability quality attributes. You can find a lot of terms describing the behavior of the system when dealing with problems, with fault, such, for example, recoverability, reliability, resilience, robustness, and self-healing. And then, more recently, also anti-fragility. So to deal with this jungle of terminology, Avizienis and all in 2004 started providing a definition of dependability as the ability of the system to deliver services that can be justifiable, trusted. And together with the definition came a taxonomy, where dependability is described, along three main pillars: attribute, threats, and means to attain dependability. And they also defined the chain of dependability traits: fault, error, and failure. So anti-fragility now brings with it a new vision. It is not only the ability of the system to deal with fault, but the ability to system to improve after a change. So our question, with the goal of having a common understanding, is it possible to include anti-fragility into the dependability taxonomy? Or if not, how can we update and expand it? To do so, we started considering reasoning using a conceptual framework, a quite classical one if you want, We have a system composed of hardware and software components together with their attributes, and the system, of course, interacts with an environment and have to satisfy functional and non-functional requirements. And the quality of a system depends on its ability to fulfill the requirement in the given environment. Of course, to be able to evaluate the quality, we need to reason on abstraction of the system, so on models. But to be able to understand the ability of the system to deal with changes, so to be anti-fragile, we consider different types of changes that can happen in the system or in this whole framework. So the first type of changes that we considered are the real changes. In this case, changes happen in the real world, in the system or in the environment, and trigger a change also in the virtual world, so in our model. Another type of changes that all of you know, the requirement changes. Again, they happen in the real world, and they can lead to an evolution of the system, so to be able to fulfill again the new requirement. And then we have a different type of change. In this case, the system and the environment remain unchanged. What change in this case is our perception of the system. So in this case, we have a change in the real world, because, for example, we collect more data or something like that. And this new knowledge can bring an evolution of the system that will improve it according to the knowledge that we have acquired. So now we have these three types of changes. How can we include these changes in the dependability taxonomy? So of course we have to compare changes with false. And the first thing is that indeed real requirement and knowledge changes can be considered as fault since they trigger the chain of dependability threats. But does the concept of fault cover also all the type of changes? Of course, faults can cover quite well real and requirement changes, but are not able to deal with these new type of changes we have defined, the knowledge changes. So the first extension to the taxonomy that we propose is to include, changes there as a possible threat together with false, and to add the knowledge. Now that we have this new type of change, we need to understand if the means to attain dependability that has been considered so far are enough, and how these changes refer to anti-fragility. So the novelty, if you want, with respect to the classical changes are the knowledge changes that are able to trigger this virtual chain that can lead to an improvement of the system. So these type of changes should not be avoided, but instead should be encouraged and exploited to learn how to improve the system. So we need a 4 category in the means to attain dependability that we have called change, triggering, and exploitation. Again, since these changes are the ones that improve the system, then they are at the basis of our definition of anti-fragility, the one we propose, and we say that a system is anti-fragile if it implements the virtuous chain we have defined. So, in other words, if it is able to trigger the occurrence of knowledge changes and exploit these changes to improve itself. And then the extension of the taxonomy that we propose is this one, where anti-fragility can be seen as an attribute of dependability, and a threat for anti-fragility are indeed the knowledge changes with means to attain it, change, triggering, and exploitation. Good, now we have our vocabulary, but we need now further work, And this is really our first result. And now the next steps are indeed how can we architect anti-fragile systems. And so we have defined a set of research questions on which we plan to work. They are centered around the relationship between the type of changes and possible architectural element, and about the investigation of the possibility to exploit the self-adaptation principle to obtain anti-fragility, and to understand if it is enough. And as we were discussing in the previous session in the other room, it is really important also to have a way to assess the anti-fragility. Now we have just the vocabulary. And so it is important to be able to define metrics and methodology to be able to assess the anti-fragility, and also to explicitly take into account the different type of uncertainty and how they can interact with the changes and with the anti-fragility assessment. Thank you very much for your attention. And,
yeah, many thanks, Rafael. Very nice conceptual framework that you presented. I was wondering if this makes more sense for certain applications. Thank you. If it makes more sense for certain application domains where we're looking at anti-fragile systems, where in other domains we would be more inclined towards fault tolerance or, I don't know, reliability, resilience.
I suppose that for each specific domain you can define different type maybe of changing and so on. And I'm sure that for certain systems, for example, if you want to have systems that are really focused on quality, for example, security, then this anti-fragile concept is good. But I have seen it used maybe not well defined. That's why we tried to formalize in some way. It is not really formalized, but at least we have tried to define the boundaries. I have seen it used on really every type of system. Also, okay, the economic, the managerial, really for every domain. But yeah, I'm still not sure that for everyone it would make sense.
Could I follow up on this briefly? So is the level of uncertainty playing a role? I'm driving a crazy.
No, it's fine. I need a bit of support.
Is the level of uncertainty in the system playing a role on how far we would like the system to be anti-fragile? Because I'm guessing that the more uncertainty you have, the more... Please go ahead.
No, indeed. The more uncertainty you have, the more difficult it will be to guarantee a certain level of anti-fragility. And but you know, yeah, of course, because if you have, you need a starting point, you need a model, and if you have everything is uncertain, then how can you guarantee? So, of course, you can try to mitigate in some way. You can try to understand, but being successful in having at the end an anti-fragile system, well, I'm not sure of that. Yeah, thank you.
I'm really done.
Okay. Yeah, thank you, Rafael. Yeah, very interesting. Since you were inspired to fault, error, and failure chain, I wonder whether, I mean, now changes that you introduce, they can have analogous error and failures, no? Like, for example, a change could be an internal change that does not propagate somewhere else, you know? So I have like an additional research question to your list. I mean, investigating if this classification can be useful, like, you know, fault, error, and failure, like evident outside the system, and a change can have this aspect of being hidden or revealed partially or revealed outside. This could be, I don't know, an interesting dimension.
Sure, we can surely investigate also something like that. At present, we just imagined, yes, that changes were triggering something, and we imagined using the chain that the fault was at the end transformed into a failure, so we were able to detect it in a way. Because you see, but you are right, it would be interesting, because you see, when we considered the real changes, so we thought, okay, this will trigger a change in the model, for example, or the requirement will trigger a change in just...
It depends on the types of
but yeah, sure. No, but that's surely an interesting point to investigate and to go deeper into this analogy with the dependability taxonomy. Thank you, Vittorio. Thank you.
Questions?
So actually, I'm thinking. Yeah, I was just giving priority. So I really like it because similar to the talk in the working session yesterday of Ian, that he was putting in positive way, no? Because you do the same, no? You look in the positive instead of negative. But I'm kind of thinking that anti-fragility is a kind of special attribute, because for the other ones, so all the other attributes are connected somehow. But I see that this one is strongly connected with many. So if the system will be more anti-fragile, will be more available, so the availability will increase, or I don't know.
I'm not sure about that, you know, because an anti-fragile is a system that is able to deal with that fault and then improve with respect to that fault. With respect to other, I wouldn't say that it is more available, for example. But, well, Vincenzo has another opinion.
The main difference is that anti-fragility refers to a particular kind of changes, what we have called knowledge changes. So the idea is that in anti-fragile system, it should be able to exploit this improved knowledge to make the system better than it was before. So what does it mean to be better? It could mean to be more available, more safe, more secure, etc. But our concept, our idea is that by anti-fragility, we should have this learning dimension. This is what characterizes an anti-fragile system. First of all, learning and improving use learning, more knowledge, the additional knowledge to improve the system.
Yeah, yes, indeed. Indeed, I was focusing on the better part and try to understand what does it mean, no?
And indeed, you are right, it was really related to the talk of Ian yesterday when he was introducing this technical credit, and we were discussing how to exploit also this part. Thank you, and for all of you that don't know, I am the PhD student of Vincenzo Grassi.
30 years.
No, maybe not 30, but it is a joke in Vittorio myself.
So we are now on the third talk, perfectly on time. The talk is about, it's already there, detecting consistency in software architecture, documentation, usability, coverage. And Jan will present the
Yeah, thank you. So when we look at software architecture documentation, we can find different kinds of artifacts. For example, we have some models that present the different components that we have. We can also find some textual, natural language documentation that has maybe even some different information, but some information should be the same. For example, here we have the facade is the entry point to the service. We can find that somewhat in the model. But there's also some information that's maybe easier to see or to spot in the natural language documentation. For example, the layered architecture, it's not that easy to see in this component model on the left side. So that we can combine these information, what we can do is we can create trace links. For example, here we have trace links. We can find where's the same information in the model, where's the same information in the natural language documentation. And for this, we presented a few years ago at ICSA an approach to create some trace links. And if you look closely now here, what we have in the text and what we have in the model, we can spot some differences that shouldn't be there probably. Because, for example, we have the cache component. The cache component is never mentioned in the documentation on the right side. So maybe that's some kind of inconsistency. Why is the cache there? We don't know anything about the decision here and and why it's there. We call this kind of inconsistency unmentioned model elements because the model element is not mentioned in the natural language documentation. Another thing that we can find that is somewhat inconsistent is if you look at the last sentence here, the common component contains utility functionality, and then we look at the model and then we see, wait, there's no common component. So there's also some kind of inconsistency, and we have to figure out why is it not in the model. Maybe it's not important, but at least we should be aware that there is some inconsistency, and we should notify the architect or the users of this, wait, here's some inconsistency, and you have to deal with it, either resolve the inconsistency or maybe don't resolve, but it's up to you. And so the idea that we had is that we combine this. We combine the trace linking, we combine, or we use the trace linking to detect these inconsistencies, at least some parts of them. And what the major idea here is we don't look at the parts where we can create trace links, but at the parts where we cannot create trace links, or the trace links are missing. So here are also then the research questions that we had. We had the previous approach that we call swatter, that detected the trace links, and we found maybe it's not the best one, and we need to have some adjustments so we can apply the inconsistency detection parts. And so the first research question was, how can we improve the performance of these? Also, then obviously we have two further research questions. So can we detect these unmentioned model elements, and can we detect the missing model elements? So these model elements that are described in the natural language documentations, but it's not in the model. So accordingly, we extended the traceability approach and then added our novel approach to identify these inconsistencies, and we also created a replication package that you can find online. So also, when we are looking back at detecting inconsistencies, it's not a new idea, and there were also some work, previous work, but if you look closely, there's mostly work at detecting inconsistency between code documentation and the code, or for example, looking more specifically at requirements instead of real documentation, or and also some work about the inconsistency detection for software architecture, but it was limited to more formal texts and to some specific component diagrams. So there was no real work looking at these inconsistencies that we thought can be there when we are looking at natural language software architecture documentations and these software architecture models. So to give you all some background, because that's important to understand the full approach, we look at the swatter approach to create these trace links. And the most important parts here are that we first analyze, or that we analyze the text in our text extraction and step, and then perform some kind of element identification. So first, we try to figure out what are parts of the text that should probably be in the model, so that we can later then connect these parts that we identify are potential, are recommended instances of our model, and use also the information from our model extraction to compare them and to create the trace links. And here we step in and say, okay, when we have the information and we have this element identification of potential recommended instances that should be in the model, we can also use that to identify some inconsistencies together with the trace links that we have. And so we step in there, use these recommended instances that were created during the traceability link recovery step, and apply some further filters and and other heuristics to then identify the inconsistencies. So, but let's look first at what we did to adapt the traceability link recovery slightly to improve the overall or enable the detection of inconsistency. First, when looking back at SWOTR, it was a good approach, but they had some drawbacks. For example, compound nouns weren't properly handled, and things like user management or something like that, these compound nouns were problems, and so we added and adapted heuristics to deal with these phrases, especially noun phrases. Additionally, some problems of the original SWOTR approach were a lot of times the project's name was in the text, and sometimes this caused also problems. So if we can just supply project name once, we can easily filter out these parts to increase the traceability results. And then also, because we are dealing with natural language, we had to deal with word similarity stuff, and then updated how we use the word similarity, and for some of these parts and heuristics that we use, and used in the end a combination of Winkler and the Levenstein distance. But now let's go to the actual detecting inconsistencies, and let's start with unmentioned model elements. And actually that's a quite easy part to do if we have the trace links, because then we can just simply look at absent trace links for model elements. Let's say we want to have components, and each component should at least be mentioned once in our text. So if we cannot find any trace links for this component, then we can say, okay, there might be some issue because it's not documented in our natural language documentation. To allow for some more configurations and according to the project that we have, sometimes we want to have more than one trace link or more than one sentence that states something about a component. Sometimes we don't want to have some documentation about certain parts of components because we think it's not important. So then we can have some configuration options like the minimum number of needed trace links, the type of model elements that needed to be checked. Do we want to include components only? Do we want to include interfaces as well? And also regex-based whitelisting for components, like let's say from the beginning, we don't want to look at any caches. They are not important for us, so we can whitelist caches so they are not mentioned as inconsistencies. The a little bit harder or much harder step is actually detecting these missing model elements, these that are documented in the text but somehow missing in the model. And here we make use of these recommended instances that I mentioned earlier. So we can say if we detect some parts of the text that we are certainly sure should be somewhere in the model, but we cannot find it anywhere in the model, we say it's an inconsistency regarding this missing model element. The problem here is we have to make sure, or the SWOT approach wants to have a high recall. So it wants to create a lot of recommended instances that are later filtered out because they cannot be matched to some model element. But on the other hand, if we have a lot of recommended instances, we have a lot of false positives for our inconsistency detections. So here we have to figure out what's the best middle ground, and therefore we said, okay, let's try to keep a high recall in the recommended in the traceability link recovery part, but filter these recommended instances that we think aren't then actually real model elements. For example, we use dynamic threshold filtering regarding the overall confidence that we have, that it's a model element. We have confidences for names and types, for example, the component type or an interface type or that's actually the name of a component. The number of occurrences, for example, can also be some issue. If something's only reported once in the document, maybe it's not important and then it's not a model element in itself. And also, we then applied some blacklisting or some filtering based on unwanted world unwanted words. For example, we have general software engineering terms that are used throughout the whole document, but they are never ever any kind of model element. Let's say some programming language and so on. And for example, there can also be project and domain-specific words that in some cases can be model elements or components, but in others aren't. So we provide the user an easy way to just supply these as word lists, so they are never reported as inconsistencies. To evaluate these projects, we used to evaluate the approach. We used 5 projects from different domains with different sizes and different programming languages. So we had so we could try to generalize it a little bit more. And for the first part, we wanted to know what actually, so the research question, what are the improvements that we have? And for this, we used the gold standards that were used during the SWOT approach, and then calculated different metrics. I'm only focusing in this approach on some of them. And if you look at our results here for the different projects, we can see that the precision is mostly really high. The recall is also quite high. And what we also have here, we not only looked at the most recent versions, but also at all the versions of the documentation if there's some issue with that. To compare it, we have the old SWOT approach. We also created some baseline approach, and then we have our new approach, and we can see that we actually achieve quite high precision and recall and F1 score. But now for the inconsistency detections for the unmentioned model elements, we also created a gold standard for that. The precision is mostly high, but there's also not that many inconsistencies regarding this type, so we have to check further in future studies, but we are pretty confident that this can be quite well detected. And the harder part was the missing model elements, and for this we didn't have any gold standard, so our trick was to artificially create this inconsistency by removing model elements from the model. And because we had the trace links beforehand, we knew exactly where these inconsistencies should appear, and then checked if we can actually detect these artificial inconsistencies. And here we can see the recall is quite good, but the precision sometimes is really low. That's most of the time because we report too many inconsistencies. And there still needs to be some work done, but overall we are quite confident with these values, because this problem is actually really hard if you think about what does it mean, what is a model element, or what should be a model element. That's not easy to tell all the time. So overall, we have good results with some outliers, and the problem is, especially when text and the model diverge too much, we get quite low precision, and that's something that we still need to work on. The flexibility in our study is that we had only few open source cases, and it's unclear how well this generalizes to other studies. And the artificial inconsistencies that we introduced may not be something that appear in this regard or in this form in the natural real world. And also with the gold standards that we created, there might always be some potential bias. So to sum this up, we looked into this inconsistency detection using trace linking, and for this, we first improved the traceability approach and then proposed an approach to identify the missing model elements and these unmentioned model elements using these trace links or the absence of trace links, and evaluated using these 5 projects with quite good performance, at least outperforming all the baselines that we had. And the future work, most of them I already mentioned. And also what's the new hype thing here is we still have to experiment with deep learning and language models. Our first experiment didn't show any improvements, but we still have to look into that further. Thanks for your attention.
Any questions?
Question from the audience? Okay, start with a question. So some years ago, we made a study with some practitioners to try to understand what are the inconsistencies between an architecture and code. I don't think we consider the textual, but still, we identify different type of inconsistencies that you can have, and some of them actually are not a problem at all, because sometimes you have just a name that is different in the code, and then you don't want to have all this noise. So do you consider different type of inconsistencies, or you plan to look into that?
Yes, this is just the beginning, so to say, because there are a lot of different kind of inconsistencies. Let's say we had in the example about the layered architecture, and in theory we can check is it actually a layered architecture, so some kind of architecture conformance as well. So that's something that we want to look into the future. This was the beginning because we thought these structural information or these structural problems are the more easy parts to check, but it's already hard enough.
Thank you for the presentation. I have a question regarding the, you spoke about identifying components in the documents, okay? And I suppose you use something like name entity recognition.
Yeah, so it's kind of named entity recognition, but not directly the same as named entity recognition, because it's usually for persons and organizations and so on. And so it's a similar problem, but not the same problem. So we created an own kind of named entity recognition algorithm.
Okay, is this a rule-based algorithm, like you put rules for this, or this is
yeah, it's heuristic, rule-based,
okay,
or pattern-based parts, yes.
How do you think would this affect the generalizability of the approach? Like let's say I brought an architecture document from not from your repository, and I run your approach on it. How would it be the result? Or just, nothing is perfect, I know, but yeah. I just want to have an impression about this.
Yeah, so we created these heuristics without knowing the data at first. Mm-hmm. And I think these are pretty general like ideas and how you could describe these things. For example, some rule says we have a name and then the type of the component, something like that. So we identify this could be a name, this maybe could be a type like component, and then we have rules like that. So it should be generalizable, but obviously if there's some wild other kind of notion that someone uses, it probably will fail at some point.
Okay, thank you.
Yes, thanks for your talk, very nice. I was wondering, what is the relationship between the text and the model, or do you consider them completely independent, or might it be that the text is a bit generated from the model, for example, or?
I would say they're independent, and that's why I also say this is a consistency problem and not a conformance problem, because it's hard to say what actually is the truth here. So I would say these are equally legit parts of documentation. Models have some other purpose than natural language documentation. So I would say they are independent, but obviously there's this overlap of, for example, structural information and so on.
Yes, yeah, exactly. And then my next question was going to be, do you consider one of them more right than the other one? If you detect an inconsistency, you need to somehow prioritize them, but then you don't really.
Yeah, so that's why we detect inconsistency and not say some things, or we don't, or I think we cannot resolve the inconsistency, because sometimes you have guidelines in your documentation that probably shouldn't be changed when someone changes the model. Afterwards, sometimes it isn't, so it's hard to tell what actually is the truth here. So we just want to make the architect or the overall user aware that there's something or some problem there, some inconsistency there.
Okay, can I ask one more or not?
I would like to give space also to Boris, and in the meantime,
So thanks a lot for your talk. I think this is really interesting work. My question is actually very relevant to the previous one. We always teach our students that the ground truth is the code, the implementation. So if you have inconsistencies in the architecture documentation, you should actually look at the implementation and see what's actually realized into the system.
Now, you have not mentioned this as a future work, but would this be an interesting path for you to actually see, okay, there's inconsistencies between the textual description of the models, but what is actually the truth compared to the implementation?
Yeah, I think so. That's an interesting path, and that's also what we want to look in the near future, at least. The problem here again is, let's say we have guidelines. Something like microservices should not depend on each other, and then some code violates this dependency issue. Then, I mean, it's still something I'm not sure if you can say, okay, then I think the rule is obsolete and dependencies are okay now. I think at least for these guidelines and stuff like that. But maybe we have to classify these types of design decisions and then say, for these it's okay if the code is the correct one, and for others, like guidelines, that should be checked manually.
If I may offer a kind of way forward, so besides the source code itself, usually some of this information is also mentioned in other sources like code comments. People actually write in the code comments something about dependencies, or which could be checked as well for consistency, or in issues repositories, or sometimes even in code commits, pull requests. There's a lot of sources that you can tap into to find out what is the ground truth there.
Yeah.
Just food for thought.
Thank you.
So let's thanks again. So it's now time for the last paper of this session. It is documentary software architecture design in compliance with the ISO 26262. And is a practical experience with models, I expect.
Yes, just so.
And will be presented by Marco Luca.
Just a second, we have a problem. Io l'avevo caricato dell'email e mi ha mandato errore. Cartella però. Questo. Perché non so perché non carico. Vedi, qua ci sono documenti in... Puoi ricaricare un continuo. Da PC. Non era 7.3. Sul telefono c'è caricata, qua non...
We have a problem in consistency since the phone is
You get the refresh the page now. Ecco qua, documenting sent, yes. Yes. Questo qua uso prima avanti? Sì. Ok. Provo se funziona. Sì. Okay, so good morning to everyone. I'm Marco De Luca, a PhD student from University of Naples, where I'm part of the Reverse Research Group, together with Domenico Amalfitano and Annarita Fasolino. Today I'm presenting to you our work with this very long name, Documenting Software Architecture Design in Compliance with the ISO 26262, a practical experience in the industry. The motivation behind our work are really simple. Documenting the software architecture design can be a challenging activity in industries for safety critical domain. This can be amplified when software development must comply with the guidelines that are outlined inside the safety standard, like the ISO 26262. Several works in literature have described and showed some suggestion and indication to overcome these challenges, but they are not always easy to translate into practical solutions. We think that industry need concrete procedures and well-defined guidelines to support the safety standard. So how we proceeded? We performed a survey with the industry safety expert from the automotive domains, and then based on the result of the survey, we defined a software architectural documentation template that aim to overcome the challenges that emerged from the survey. Then we validated the proposed template with a case study that involved the same expert that we enrolled in the survey. So the goal of the survey was to understand which are the challenges and the issues that are mostly frequently encountered by the practitioners when they are developing software inside the safety critical domains that have to comply with the chapter 6.7 of the ISO that is about software architecture design. So we recruited 3 software engineers from 4 international software companies that are involved in the automobile domain, and together with them we executed 3 focus group sessions moderated by one of the authors, and the other 2 analyzed the answer of the interview, and we extracted the main challenges. The challenge that we have extracted are grouped in 3 categories that reflects the structure of the ISO, that is divided in properties, principles, and requirements. About the properties, we identified, for example, challenge about the consistency management or challenges about documenting the SAD with the hierarchical structures. Moreover, about the challenge, we identified for all of them a challenge about verifiability of the principle, because we means that our template tries to help the practitioners in verifying these principles that are outlined inside the ISO. For example, we can see principles about restricted size of the interface. Moreover, we identified challenge about the requirement. For example, the ISO asked to the practitioners to find mechanism to easily identify the safety-related part of the software, or to document the configuration and calibration parameters. So from what we understand from the focus group and the emergent challenge, we can say that most of the problems are related to scant documentation and to an improper use of the designing tool. So we decided to propose a documentation template. Here we can see our documentation template that aims to provide a set of solutions to manage and guarantee the consistency, to support the software architecture design refinement process, and to hide the verification of design principles that we find inside the ISO. So our template is divided in 2 main packages. The first one is the architecture view that is composed by a component diagram and also from an architectural breakdown package. As we can see, this package has a self-relation because the idea behind this package is to give a top-level hierarchical view of the whole system, and after through a refinement process, we can break down the architecture going into deeper levels of details. The second package is the functional requirement view that is divided in static view and dynamic view. Actually, the dynamic view is grouped in scenario view as described in the ISO. Scenario view can be alternative scenario, failure scenario of the dynamics interaction. The static view is essentially composed by a component and connector diagram, and the scenario view is composed by a specification view diagram where we can find a textual scenario description. In case that the textual scenario description isn't enough to describe the rich semantic of the scenario, we can enrich the textual description with the use of the activity diagram or with state chart diagram. Moreover, the dynamic view is composed by a sequence diagram that can be refined in the case we need to highlight we want to highlight the dynamics interaction. For example, we can refine a sequence diagram to put more emphasis on the interruption level or maybe on the scheduling interaction. Moreover, for the component diagram, we also proposed another guidelines that the practitioner can follow to document the single software component. As we can see, a software component can be described with this interface that can be provided, required, or external, and you can have configuration and calibration parameter. So now I'll just show you an example. Here we have an example of the implementation of our proposed template inside the Enterprise Architect, the design tool that we used. As we can see from this picture, the project structure reflects the structure of the template and is divided in the two main packages, the architecture view and the functional requirement view. Here we see an example of the high-level hierarchical view, and also in how our template can support the breakdown process of the architecture, because here we have the macro component that can be refined in a smaller one till the lowest level of detail that we want to have inside our documentation. This is an overview in how our proposed solution can cover the identified challenge. Now I'm showing to you some practical example of our template, and this is in this small table I also show you which of the challenges the solution that I'm showing wants to cover. For example, here we have the detailed component diagram that wants to give a one-shot view on all the information needed for a component. For example, here we can see the provided and required interface, and if this component has got calibration and configuration parameters with the relative link to the documentation of these parameters. Also, with the use of a stereotype mechanism, we can mark a component as safety related to cover, for example, this challenge to easily identify the software related part of the software. We can also mark interface if you want, other than the component. Here we show how we are able to manage consistency in our documentation template. Once that we have defined the single component inside the top level architectural view, and we want to reuse a component inside a new diagram, we can justly inside Enterprise Architect simply drag and drop this component in a new view. Every time we are doing this action, we are instantiating an hyperlink instance of that element. Whenever I make I edit this component, for example, I change his name, this modification is propagated to all the other instances of that element. So so we are able to ensure consistency between all the view and the components. Here, an example of how we want to model the top-level view of an interruption with the use of activity diagram and interruptible activity region. All the action inside this interruptible activity region are activity that can be interrupted by an asynchronous event. Finally, thanks to the feature of Enterprise Architect, we can generate XML files starting from the component and the diagram, and with the use of this XML file, we can evaluate complexity metrics that can support the analysis for the verification of the principles that we find inside the ISO. So, how we validated our documentation template? We conducted a case study that aimed to answer the following two research questions. The first one is to what extent the documentation template is accepted by the practitioners, and to what extent the documentation template is able to overcome the safety-related challenge that we identified. So, we enrolled the same 12 experts from the 4 industries, and together in each company separately, together with a project manager, we chose a closed project and 6 requirements. This requirement was not designed nor implemented or tested by none of the subjects in order to not bias the evaluation of the subject. Then, 2 authors and the project manager implemented the top-level architectural view and the component inside our template, and we asked the subject to model the requirement. Then, we asked to them 4 open questions to answer the first research questions, another 60 closed questions to understand for each challenge how our templates performed. So, answering research questions number 1, all the practitioners said that they found improvement on the proposed documentation template with respect of the previous one. For example, they found enchantment in automated consistency management, and they found useful the detailed view of the single software component. Moreover, they found very promising, for example, the generation of the XML files for evaluating the complexity metrics. But also, they pointed out some limitation, like the lack of a traceability link to the requirement tool that are already entered inside these companies, like IBM, DORS, or Confluence. And they found also a lack of a mechanism to support the multi-user and collaborative work using our template. About the last research questions, we found that our template was able to overcome all the challenges, except for the one that I show you here, where a practitioner found some shortcomings. For example, they found useful the interruption model, but they did not find that the template can help in the checking of their restricted usage. So, to conclude my presentation, as future work, we would like to mitigate threats to validity, because we want to extend this proposed template to other companies, and also we would like to introduce a reverse engineering tool to help the migration from existing documentation inside the companies that maybe want to use our documentation template. Finally, we would like to apply machine learning or natural language process approach to the XML file for automated verification of the design of safety design principles. Thank you all.
Questions? So let's try again. I make the first.
Okay.
So about these limitations that the companies fight,
yes.
How they are important. So the company are ready to use this approach, or what they said?
We are starting with a company to a full redocumentation process using our template that can be a future work to. Now I'm helping them to use all these templates inside their companies, but I can't say which one is.
Thank you for the presentation. So you mentioned that you extracted some properties and principles from the ISO 26262 standard. So
can you speak loud? Can't.
Okay, I start again. So thank you for the nice presentation. You mentioned that you extracted some principles and properties from the ISO 26262 standard. And my question is, which part of the standard did you extract it from? So, because there are 12 parts.
From chapter 6.7. Is that?
Yeah, okay.
It's called Soft Architecture Design, the chapter.
And there, I'm guessing that there are several requirements. So how did you choose?
The requirements are chosen from the focus group that we had inside the industries. We speak it to them, and they said which are the most challenging requirements of these. For example, about the requirement, there are only few requirements here, because they said to us that this one were challenging, the other one maybe they are not.
Okay, thank you very much.
You're back.
No other questions? Then I think lunch is waiting for us.
Yeah.
Before we stand.
Thank you.
test for the next session.
Yeah.
I think I need a microphone to be able to speak, to talk to the speaker who's remotely. Maybe just take that one. For the next session.
Yeah.
Okay. Ralf, kannst du mich hören? Kannst du mal was sagen? Ja. Ah, okay. Ich höre dich noch nicht, du bist noch gemutet. So, ich lege mal alles runter. Da. Komm. I'm trying to talk to Ralf because he will present something in the next session, but he is not hearing me yet, I think. So maybe he just went briefly, I don't know, to the bathroom or whatever. I'll call him. Ja, ich wollte ihn eben anrufen. Jetzt sehe ich, Ralf, dass du dich nicht mehr mutest, aber ich höre noch nichts. Perfekt.
Ich bin da, ne?
Ja, super. Man hört dich auch gut hier im Raum.
Super, das ist gut.
Sehr schön.
So sorry, switch to English.
Yeah, sure. there's
no, sorry,
people in
I
the room.
just grabbed a coffee, but I think that's in Italy acceptable.
Sure, yes it is. Should not be cappuccino, you say?
After lunch.
Ah, okay.
No,
So we hope it was not a cappuccino they are saying
it's
here.
I think you call it an Americano in Italy. So it's an espresso with some hot water.
Now, can we somehow... You also have your video on, right? But I wonder whether we can also show it here. That would be nice for the present. No, I can't. But maybe if you try to share the slides, then probably... but
should I do? Okay.
That's the question. Now we see you, yeah. But it seems we can only see you if we are not sharing the screen ourselves.
Okay, so let me check whether I'm able to do that.
And now I see that you see me here as well.
Okay, so we try to share.
Also, yeah, I can also share them. So I also have your slides here. It's actually the question whether you would rather share them or I should share them. And if I share them, whether we'll manage to show Ralf's video, because it's no fun to listen to a presentation if you don't see the speaker. We've seen that in some of the presentations, right?
Yeah, I guess so, yes. So just a moment.
So in that sense, it will be better if Ralf shares, I think.
So Anna, the only problem me sharing is, as I said, I'm in another meeting shortly before of all these back and forth with my calendar, and therefore I don't have too much time to prepare. But let's see.
If you prepare it now, maybe.
But I mean the other meeting also online, you know.
Yeah.
With Teams.
Ah, okay,
you know.
okay.
So.
Yeah. I mean, otherwise I can also do it, and then we'd have to... It should be possible that actually we see your video even though I share the slides. We can also test around with that.
Anna, can you now basically see my slides?
No.
No? Okay, funny. Just a moment.
Now something's coming up, yeah.
Okay.
We see the desktop, I think. And we see now the Referentenansicht.
Okay, so sorry, sorry for that. Obviously, I hit the wrong screen to share. Just a moment.
We still see the desktop now, so it is maybe...
I have to stop.
Yeah.
And again, so let's do that. Stop 1. Fine. And
now we see the PowerPoint. And this is perfect. This would be perfect now. This is actually a nice view that we have here now, because we have the slides and then we have your video next to it.
Okay, good.
But, yeah,
okay,
I
so
don't know.
I try to
I mean, I will show like 2-3 slides at the beginning of the talk, so it won't be your turn at 1:30 sharp, but it will be a few minutes later, so I don't know whether that works. Or shall we try that I share them and somehow manage to show your video? That would be the other option.
No, I think, Anna, if there's some time and you know, I'm coming from the other meeting sharply, then I can prepare for that. And once you say, please share, Ralf, I think I should be able to do so.
Okay, that would be perfect, because then here the screen is really nice and we see you here.
So what I realized in the sessions before, now you, Anne, with your micro, that's perfect sound for me. But Jan, for example, when Jan talked at the, you know, at these, how do you say, booth, there with the 2 microphones, that was, the sound was not the same quality like it is now for you.
Probably this one is not even enabled for the remote participants, is it? Because we had this also in the very first session in the morning where Heiko was saying it doesn't work. I'm not sure. So I'm not sure whether it was actually this microphone being somewhere else picking up the sound, or, but we'll take this, using this microphone then for the speaker.
Yeah, because that is really brilliant sound.
Or some of those. Okay.
And for the question and answer session, so let's try, because I also understood the questions were sometimes a little bit quiet, not so loud, but I think I try, and otherwise probably you need to repeat it, Anna, or something.
Okay, yeah, then just let me know. I mean, then I can repeat. I think usually we handed a microphone to the speaker. I'm not sure now whether the other microphone is also less loud, maybe. Yeah, but just let us know, and then then we can do that. Let's see.
Okay, so but then I can stop sharing, Anna.
Yeah, I think then we're all set and can go for lunch.
You go to lunch, exactly.
Yeah.
So
did you have lunch already?
Good
Probably.
Italian food.
Yeah, no, it's really nice. That's a good thing of having a conference in Italy, that the food is always perfect.
Yes, I'm really jealous, and probably I also make a comment during the session. It's just because of the teaching, you know. Otherwise, of course, I would have preferred being in Italy there and enjoying the conference with you.
Yeah. Okay. So
so thank you, Anna.
In about an hour.
In 1 hour, Anna.
In about an hour. Yeah, that's.
Yeah, sorry.
1:30. Yeah, okay. Good. See you later. Bye.
Okay, so in 1 hour. Okay, thank you. Bye.
Bye. Yeah, but as now currently no more people are coming into the door, I think we can just start. And it will be just some introduction at the beginning, so whoever comes late will also be still able to participate. Yeah, so let me welcome all of you for our last working session on the validation of software architecture research. And yeah, I will say just a few words at the beginning, and then we have 4 inputs actually, but you'll see that on the agenda in a little bit. So here we go. Yeah, I put this into the programming. If you would like to discuss how your research results should be evaluated by PC members of conferences, then this session is for you. Then I think we would be interested to hear about what you think, because this is really about several perspectives, I think, on this questions, and also the PhD researcher perspective. I think that's also relevant. So this maybe just one slide and before the agenda about the starting point where this idea for the session came from. So the session has this idea of asking ourselves, how shall we validate software architecture research? And our starting point for actually asking these questions were two starting points. One, very practical one, was doctoral researchers asking us, and when I say us, it's also Ralf Reusner, who's here online and whom I've been discussing a lot about this, and me. Doctoral researchers asking, so what should I validate about my approach? And before, when we were both working on performance prediction approaches and model-based, architecture-based performance prediction, the answer was kind of clear. We said, yes, there are different levels of what you can validate. It's about the accuracy of the approach. Can you actually make good predictions? But also about the applicability. Is it actually usable for people, this modeling language, for example? And finally, it would be nice to evaluate cost-benefit. Does it actually help developers, and is it worth the effort? Which we then usually didn't do. We just say, okay, one should do that in future work because it's really hard. Okay, so that was clear, but then some PhD students did other kinds of work, and then were also asking, so what should I do? And it was not so clear to us anymore. Maybe the only guidance you can give is it depends, but that was somehow not satisfactory. So we were trying to somehow transfer this idea of coming up with certain things that are reasonable to validate also for other kinds of contributions. So that was one starting point from the doctoral researcher's perspective, let's say. And then the other more recent one was also discussion actually among PC members also of this conference. So how can we assess research contributions? So sometimes in discussions in the program committee, there is not necessarily consensus of what is now acceptable or not. What can we expect authors to validate and what we cannot? And to me, or also to others, it seems to be more clear for some other software engineering disciplines. So for testing, if you show that your approach can test better and finds more bugs, okay, it's fine. But what software architecture research is more multifaceted, maybe. It's about humans using it, so it's somehow harder to grasp what is actually the way to go. And with a question mark, maybe this is the reason why we see little software architecture research at conferences like ICSA, because their reviewers maybe would say, no, it's not enough validation, it's not clear what the approach is, but that's harder maybe for software architecture research. So that was one other starting point, that maybe it would help if we come up with an understanding how to validate our research, which we then can also present to the other communities saying, this is actually now valid what I did, so please accept my paper. I'm exaggerating it a little bit, but yeah. And the question for this working session now is, can we achieve somehow a better shared understanding in the community and provide also guidance as a community, both to our doctoral researchers, also to PC members, but also to PC members maybe of general SE conferences, on what is good validation of software engineering research. Now, this session is organized in this way, that we have, as in the other working sessions, especially on Tuesday, some input talks by Ralf Reusner and Angelika Kaplan, who actually will have a joint one, and then Ilias, where is he? Is he here already? There. We'll say something, and then Paris was, okay, you can confirm that he's here. He also cannot leave because he has an award to get later. That's good for us. And then later we can have some discussion, and also similar to the other group working sessions, there's also the question on what we want to discuss, so the idea to maybe have some breakout groups. I set up a joint Miro board at this link, where you can already now during the talks collect ideas of what we should discuss, and then we can vote on what to discuss, and then yeah, discuss. So just now you can see that there. So please, if you want to enter topics there, then use these as sticky notes. Then we can vote easily also directly on that board. Okay, so that's all from my side. Then I would hand over to Ralf, and we hope we can hear you and see you. Let me unshare this screen here. That's this one.
Yeah, it's muted.
Yeah, I think you will. So Ralf, we can't hear you yet. If you're saying something already, you're still muted. Are you saying something? You're still muted on Zoom. Ah, okay, he's nodding.
So now should be able. Okay, so thank you very much, Anne, and also from my side, welcome everybody in the room. I'm very sorry that because of actually teaching, I was not able to make it. So this morning I was still in the lecture hall here at KIT. So I'm very happy that I can be here now in this online virtual mode. And now we try something very special. Angelika, who is present there, and me, we jointly try to give a presentation together. As Anne introduced, it's about, coming from the question actually what to validate when to do research. And on the one hand, you could say, well, that's actually easy because, there's quite some work in an empirical software engineering out. You have a lot of guidelines, for example, here, quite remarkable from the ACM Zigsoft, some empirical standards for different empirical methods. So this way, they not only explain the terms, but they also tell you, for example, what to do and then what is an acceptable empirical study in these terms. And now, this also, you can continue with that. You can say, well, for example, you also have these, probably these ACM badges, where you, for example, they explain to you what does it mean that a result is reproduced or that the results are even replicated, and so on. So in that, I think we have made a good progress also in our community, having these standards and these badges and that agreement about that. However, what is, in my opinion, a remaining open issue, very much like Anne said in the introduction, is actually, is it that, do we have an agreement what actually to evaluate? So if you have made a specific contribution, is it clear what the authors provide as a validation? And then on the other hand, also, is it clear for the reviewers? Do we have a community understanding when reviewing a paper, here at ICSA, for example, what we expect from a paper to have evaluated? And just that you understand, just to make the point a little bit clearer, now let's think about two scenarios. So you could say, well, we have a paper here, for example, as a reviewer. It's about a novel language for modeling software deployment. Obviously, that fits very well to the topics of ICSA, so we can't desk check the paper. But now you could ask yourself, as an author, but also as a reviewer, well, what should be evaluated there? If people define a language, for example, via a meta model, then of course ask, well, can people really make use of it? Is it applicable? Then you can ask, well, for whom? For the experienced user, for someone who knows UML. So it's not clear. Then you can even ask, well, besides that the language is applicable, is it actually useful? So does it provide any benefit for something? And then, of course, you can only hope that in the paper it was clearly stated what was actually the purpose for the language, because we all know, when meta modeling, meta models strongly depend on the purpose they are intended for, or the models, according to the meta models, are intended for. So in that way, you could evaluate it, but well, is it really done when people publish about a new language? And then you could ask, probably sounds like naive, so is it really better than alternative languages? And then better could mean many different things. Is it better understandable? Is it more concise? Is it more expressive? And so basically, for whatever you decide, of course, you have a lot of advice from for example, the papers I mentioned. But the problem is it's actually not so much clear what actually to evaluate if someone says, well, I have a new meta model here. Well, it's not clear for the author, and it's also not clear, I guess I would say, for us reviewing it. And now we have a different scenario, and also intentionally I have chosen something which is a little bit closer to my own research, also architecture-based performance prediction. And now you imagine someone has a very funny idea saying, okay, I would like to predict the performance of a software system depending on the graphical size of the components in the architectural diagram. Now you would say, it's probably not as easy as that, but okay, that's an idea. Now you could ask, well, what is the evaluation? How evaluate that? And actually what I have seen quite often as a reviewer, not only at ICSA and the precursing conferences, also in other conferences, is that you do a kind of plausibility checking. So you vary some parameters of your prediction model, and then you check whether the output is also somehow plausible. And now in our funny model, where we use the component size to make a prediction, we could say, well, if we increase the size of the component, then it's getting slower, at least says the prediction, because that's plausible, because heavyweight components use more resources and they're becoming slower. We all know that's a nonsense thing. Just changing them by plausibility and saying that's a validation. And I've intentionally chosen this ridiculous example of using the component size because you could also with a pretty obviously ridiculous model argue quite a lot with plausibility. Okay, now the evaluation option 2, and that's certainly also not the only other option, we compare it to a baseline. So if we make a prediction, how does it compare, for example, to other measurements or to other prediction models, or in a more narrow sense to other prediction models which have a similar idea than I have. And again, it's not so clear. Well, in performance, you could always say, please measure, but it's also clear, what you can measure is only in implemented software. You can't measure the performance of a software architecture. So again, that's conceptually not so clear. Once you decided how to evaluate it again, then things are clear. Then you can say, yes, that's now I know how to measure, for example, software performance. There are frameworks for that and so on. You can do that. And now again, it's relatively clear how to perform such evaluations, but it's relatively unclear what we as a community should reasonably ask for as a reviewer, or we have to provide as an author. Now the main point here is that it's only just 2 examples, and you could continue that. And of course, it's not only has to do with architectural modeling or making predictions. Architecture is actually, let's say, in software engineering-wide topic. Depending on the contribution you want to make, depending on your research object, we not really have yet a clear understanding what to evaluate. And now you could say, well, one obvious insight already from these 2 small examples here, from these 2 scenarios, is that obviously what we want to evaluate, or what we should evaluate, depends on the kind of the contribution, or more generally on your research object. It's different from a language and a meta model than, let's say, for a mathematical prediction model. And now you could say, well, what kind of contributions do we have in the area of software architecture? And like a professor with your infinite wisdom and close to God equality, you say, it's obvious, 4 different kinds of contributions. Top down. We have models, architectural models for something, prediction models. We have meta models, so languages for modeling, it's also a contribution. Then we have some algorithm for managing or analyzing these different artifacts, models. And then we may have also approaches, which is similar to the algorithm, but of course means manual work, and for the development within of and for software architectures. But of course, that's just the first attempt. And now I'm happy to hand over to Angelika, who really did the hard work and looked into the literature and looked together with others what is actually the kind of contributions we find in current papers of ICSA and EXA.
Yes, thank you. So in the following, I would like to introduce the second attempt that we conducted. So it follows a more bottom-up and more systematic approach. So, and basically this approach was published at the ICSA last year, and if you haven't read the paper, I would highly recommend to do so. So the goal was actually to create an overview of current state of the practice in software architecture research. And we also wanted to start a discussion what standards to set as a community. So the paper had in total 3 contributions. So the first contribution was a classification scheme for the evaluation of software architecture research object. I will explain that in the next slide a little bit more in detail. And according to the scheme, we took papers that were published at ICSA and EXA, starting from 2017. And we classified the paper according to the scheme. And based on the observation that we got and insights from this literature study, we also formulated some proposals for the community. So please, Ralph, could you click to the next slide? Ralph, could you please, that's the next slide, okay. So in the following, I would like to formulate or introduce the classification scheme in more detail. So a paper is basically the major important communication medium when it comes to sharing research results. And we said, okay, a paper could or should at least have 1 research object. So a research object is defined as what actually the researchers try to investigate. So we formulated or set up a list in advance with these research objects that you can see on the left side. And during the reviewing process, we also checked if there are more items that we had to consider. And on the next slide, we see the properties. So the properties is basically the evaluation goal, what you want to show about your research object or the contributions that you made. So here we basically adapted a de facto standard, so the ISO standard 25010, and also adapted a classification scheme that is also well known in the literature. So we adapted here for analytical methods, the classification scheme of Tavinius et al. And of course, the property has to be evaluated. So here for a baseline, we took the ACM empirical standards that we saw on the first slide. And next, I would like to present some kind of results. It's just an excerpt. It's not actually the full results that we get. So here we have a bubble chart, and you see on the y-axis the research objects, and each for the x-axis the property that were investigated, and also the evaluation method that is used. As you can see here, most of the coordinates are represented, more or less, but let's go to the results on the next slide. Here we have an overview of the actual research methods that were used and the properties. And here you can see we have a cluster for the product quality and also for the technical experiments and case studies. But what we can see here in the charts that we have a diversity in the research objects and in the evaluated properties, and of course the corresponding evaluation methods that researchers use. So we could not see any systematic approach, at least it was not visible. So this could also mean, this is actually a kind of good thing that we can also say our community is very broad in research. But as I stated before, we have no systematic approach. So on the next slide. Based on the observations and the results that we made, we also formulated some proposals. And one of the proposals was to develop guidelines. And based on the questions, how do research objects, evaluated properties, so the evaluation goals, and corresponding methods interrelate. So we can also further subdivide these questions in which properties are important to be evaluated for which kind of research object, and what evaluation methods are the most suitable for these properties. And actually, for ongoing and future work, there's also another idea that we also tailor this or extend this classification scheme, including template evaluation questions. So also the questions can more operationalize our research process, and it's maybe also easier to structure in paper and also for reviewers more comprehend and in this kind. So for the next slide, I would hand over to Ralph again.
Yeah, so thank you, Angelika. So indeed, as Angelika said, so obviously the evaluation really needs to be dependent on the property and on the research object. So that is something which became also clear through this literature survey. And now we are asking how can we formulate now such a kind of agreement, what to validate. And one idea was that we say, okay, we formulate validation questions. And of course, they need to be, and that's what we called as good software engineers, template questions, where we say, okay, they need to be specialized, of course, because they are not yet specific enough, but a certain template we could use to formulate the validation challenge, the validation task. So for example here, when we say, okay, people provide a new language, for example, given through a meta model, then we can, for example, say, okay, one of these validation template questions is, can the language, named my new language, express, and now some of the following, which makes sense, real-world scenarios, community case studies, example models from other published approaches, and that is simply, would be a validation of the expressiveness. And then, of course, you could ask, well, what is actually the pragmatics or the goal of that meta model? And then you can try to find out, to which degree does models of that meta model really support these pragmatics. And of course, the pragmatics can be very different. So even for our deployment examples, there are various reasons why you want to model or analyze deployment diagrams. And it's clear that probably not one language fits them all, but you could, specialize this template here. Or again, I'm in the area where things are probably relatively simple compared to other areas in software architecture. So if we have a prediction model, then of course we want to, know something about the accuracy relative to measurements, or if that is not possible because there are no measurements, for example, in terms of reliability, often there are not good reliability data available, then you could at least ask for compared to other prediction results from other established published models. And then, of course, what's also very important when you make statements about prediction models is, of course, how easy is it to get the input model? So what is actually the value of the prediction? Because if you ask for values which are very hard to get or equally hard to get than the predicted value, then obviously the value of the prediction model is not so big. And that, of course, is something which also should be validated. And that's the second question in addition to the accuracy. And now, actually, Angelika and me, we are coming to the end of our talk. So basically now what we were wondering here, and it's also something which we connected also discussed in the steering committee is of ICSA. So would it be a nice idea to have a kind of working group of interested people who basically think about that question, what is a good classification of our research in order not just to classify for its sake, for its own, but to attach to a research object or to a contribution, a certain agreed set on template validation questions. And by that, of course, in my opinion, it would be a great help to the authors, but also for the reviewers. And probably some of the discussions in all those steering committee and program committee meetings could be simplified if you say, yes, there's a certain degree or levels of validation questions we can have, and then does a paper fulfill that or not? And that is something, as I said, we want to have that an open process, so everybody's cordially invited to join that. And of course, Anne and me are very happy then to present the results of such a working group in the ICSA steering committee. Thank you very much. Of course, we are happy for any other kind of ideas and feedback. Please contact Angelika or me or Anne. And thank you, and then I'm happy to hand over to Anne.
Yeah, thank you, Ralf, and Angelika as well. I think if there are some immediate questions, maybe we could take them. Otherwise, we'd have the other two inputs, of course, first, and then we can really go into the discussion. So just if there's now something, yeah, okay, Mohammed? Could you ask this way, because otherwise Ralf won't hear.
I have a question about this taxonomy, okay? Like the taxonomy is focused that there is a certain entity or object to be evaluated. But what if we have a research outside of this taxonomy? Like we have something else. So what should we do then?
Very good question. So first of all, in an ideal world, we perhaps could really partition all the kind of research on an abstract level in a finite number of partitions of classes, and then we say our classification is complete, because on a more or less abstract level, you could say, as I said, you know, we have probably a quite complete list here. So any kind of, at least constructive research ends up being in, let's say, one of these 4 classes. But of course, you're right, perhaps it's not complete, and perhaps it's a little bit too idealistic. And then, of course, you could say, well, at least on those classes where we agreed on, we could offer that support. But of course, let's say there's an additional class, so nothing of the above. And then, of course, you are in the current state. You don't have an agreement on what to validate. But still, at least for those classes where we could agree on such a standard, it would be a help, even if it's not complete.
Okay, thank you.
Yeah.
Okay, thank you. Now, next up is Ilias here, who is more on the empirical standard side, maybe, or has been working on at least the question of how to publish and evaluate artifacts, which is also really related, or I mean, it's even a different question whether we should all make all our research open, available according to open science, open data standards, and so on. Yeah, but let's see what you have to say about the topic.
Okay, thanks. I have some opinions about the topic. I haven't prepared any slides, but let me share some opinions with you. So this is, you know, I have to see that. It's fine, no worries. Great. I guess everyone, including the online people now, can see basically, again, the different types of artifacts, right, that we have on the website. And these are basically some badges. And I don't know if you understand the difference between the badges, or if you had to understand the difference. I had to, because at some point I was also chair together with Thomas of Artifacts Track at a different conference, SIMS. So basically, and also reviewer, right? So basically, what I want to say here is that there is a functional artifact, which basically is you have evaluated your approach, right, with a way, and then you provide something that we can use to check that basically your results track, right? This is the functional. Then you have also the reusable badge that basically tells you something more than just we can reproduce your results. We can also probably use it for further research, right? And my point is that these kind of badges, which are there for quite some time now, for 4 or 5 years, I mean 6 years, they are rarely used. I mean, there has to be a reason, right? They are rarely used. Basically, there is a reproduce and replicated. And what is it? Yeah, you can check it out. Basically, results reproduced is when the main results of the paper have been obtained in a subsequent study by a person or team other than the authors. Other than the authors, right? And then replicated. The main results of the paper have been independently obtained in a subsequent study by a person or team other than the authors without the use of the author-supplied artifacts, all right? That to me says something about a little bit also the quality of the evaluations that we have and what we kind of try to bring in this community, but also in other communities, to be honest. For instance, at SIMS, at ICSA also, I'm reviewer there for the artifact track. We don't see many kind of replication studies. We don't see this thing because, well, I don't know why, maybe you have an opinion, but it seems that we tend to produce something, especially in this community. We find it good, we discuss it a little bit with our colleagues, we go for it, let's say, and then we tend to pick the easiest way to have an evaluation, okay? And that's kind of happens again and again. We don't go through the thought process that was just presented to you. Typically, many times, we don't just try to find the best method. We try to find the method that will work for the deadline, right? And the instantiation of the method, not only the method. A quick example. For me, it is much interesting to see that you have evaluated, or I have evaluated, a new method with 5 practitioners that don't have a conflict of interest with me, right? And they can be a bit independent than with 10 practitioners / students. Many of those students will have a direct impact, you know, and something to have to do with me. So we're thinking about numbers, right? So we're thinking about, oh, 10 will look better than 5 in this case. Oh, no reviewer would say something about, you know, 10 people using my method. It's a conference paper, right? So we try to find. So I agree completely with this previous, also with Ralph and with you. I agree completely, but there is a little bit of a risk here of if we put, let's say, some guidelines with numbers in them, people will try, of course, as you understand, to hack it, to go for the number. The number doesn't say much, right? I mean, if we are kind of, in this example, if we have 10 people that have a direct kind of dependence with us in our research, they are probably inclined to say something good about our new method, right? And I'm not saying that I didn't do the same. I did the same mistake. I think we have to be a bit more honest about it, and you know, kind of as a community, I think we have to be a little bit more open-minded when new novel research gets introduced and is not evaluated to the level of the journal. There's no big evaluation, for instance, for a conference paper that we might have set even in this, guideline. But the novelty is high. I think so if we have a guideline, I think we should count for other things, because we cannot blindly look at evaluation. Okay, tick, tick, tick. No, there has to be, and anyway, reviewers don't work this way. Right? That's why we have 3 reviewers and they have a discussion, and some people might focus more on the evaluation, some others might focus more on the actual contribution. Okay? I had another point about the types of contributions, which was completely covered in by Ralph. One more point, I wanted to make has to do with, let me check my notes. I wanted to also give another perspective from another community. So we heard previously that basically there are a myriad of methods, right, that are being used in architecture and evaluating architecture-related research. That's not the same in all communities, right? And that's a difficulty, I think, that we have different methods because we have different contributions. At SIMS, we did something similar with Danny Waynes and Patricia and Thomas Vogel. We looked at how do we evaluate our research for the past 10 years, okay? This is published, 2019, I think. 2020, something. We'll have to check. This is published, you can check it out. It's really how do we evaluate self-adaptive systems. And it turns out that when designing the study, the literature study, we thought we will have like 10 different methods, and we will look into the methods, and we will have a nice mapping of the methods and everything. In the end, it turns out that we are using technical experiments, like to 90%. Of the time at SIMS. There were like, in 10 years, so many papers published, 1 or 2 interviews, studies. So these were the numbers, right? So, so it doesn't mean that all communities are, let's say, so rich as ICSA, EXA, when it comes to evaluation methods, and I think we can look at it as a strength, let's say. But of course, there is an issue here, because we have to align our understanding as authors and as reviewers even more than in other communities. That is clear that evaluation is done via control experiments, and then we might disagree on how to set up a control experiment in the best possible way. But probably we are pretty aligned when it comes to the research methods to use for evaluation. So these are 2 points. I don't know if I'm allowed to say also one more thing. I was also this year in the artifacts track, so this track here, as a reviewer. We didn't get many artifacts. I don't know why this is. I mean, we need to probably take a stance here too, as a community, and maybe increase even the incentive, because as an author, honestly, that you have an accepted paper. And this year we had plenty of submitted papers, right? So even accepted papers. So you might think, why only 4 artifacts? We had 4 artifacts submitted. I checked 4. So why 4 artifacts submitted, right? I mean, various reasons. I guess one of the reasons is, especially if you have like a full paper, you have spent quite some time working on this stuff. Then your paper gets accepted, and you're like, I'm going to throw this for getting a stamp on my paper? Probably not. So we need to kind of revise a little bit the incentive mechanism here for artifacts, and maybe even another idea would be to group artifacts, have an artifacts repository. At SIMS we do have something If you go to selfadaptive.org, there is an artifacts repository. We have about 40 or 50 artifacts there over the years. It would be cool to have something like that for architecture conferences too. So yeah, why we don't do replications? Why do we have so small submissions when it comes to the artifact track, even though we do care about the evaluation? Why do we try sometimes to go for numbers when it's clear that quality matters, right, in the evaluation? These are my 3 points. Thank you.
So maybe again, do we have an immediate question for Ilias while I'm setting up the next talk then? You can use the time.
Yeah,
I think Katja
sure.
has one.
Yeah. Go for it. No, Gogi, go for it. Go, Thomas.
Yeah, so thanks, Ilias, for your talk. I want to add something because I was co-chairing the artifact evaluation. Yeah. So you are right, there were 4 submissions. I think that it was also because there were these conditionally accepted papers. So in the first round, we had 1 submission, and then we got 3 more. So I agree on creating a repository. We can start at looking the previous edition of ICSA and collecting all the papers that were then producing an artifact, so that it's a starting point also for the others and to attract others to do the process. And one more thing that I would like to add for this reproducibility is that it's really a lot of work. So I can share an experience in ICP, Performance Engineering Conference. We had a PC member in a past edition of a conference that was reproducing our paper, and there is an archive report on what he got comparing with the figures of our paper. So
right, which would be this category of, indeed reproducibility. But
So what we have to think about, in my opinion, as a community is how to reward these people that do this extremely hard work in reproducing the results of your paper. So that's an open question.
Because this is kind of building on giving more evaluation on an existing idea, right? Or so there are several layers of evaluation that we can build upon, and we don't build upon each other's ideas to evaluate further and further. We don't do that, right? And we need incentives, I think,
We should reward the reviewers, in my opinion, in some way.
Could I briefly comment on that?
With this one, it's online, I don't hear. I think this is not connected.
Okay. So I've seen some communities that do a better job in motivating the submission of the open science artifacts. And one of the most successful methods has been the Rose Festival. So this has been running at ICSA as well as other communities like ICSME. And it's literally a festival where, people that have submitted these artifacts come together and they kind of demonstrate them towards the whole audience, and there is a lot of awards, and you really put your work into the spotlight. So indeed, it takes work to prepare the artifact and make it good enough to earn one of those badges. But having the spotlight on your work gives you a bit more attention, and there is a higher probability of also people citing your work and eventually, attracting more, let's say, attention. So I think this Rose Festival is something I would recommend our community to examine and apply perhaps in one of the following ICSAs. Perhaps the general chairs of the next edition could. Is Raghu here? Okay, he's over there. That's maybe you can look into it and see if we could have a Rose Festival as well, just to elevate these artifacts into a bit more of a celebratory moment and put the spotlight on this hard work that the authors are doing. May I also?
That would be great. Then maybe we would have a first outcome of this session already. That would be good. We also have one comment from online from Ralph. Okay, sorry.
Oh, that's okay.
I don't know.
Yes, so thank you. Just a small comment. I think it's pretty clear when doing a review of a paper, you not only should look at the validation. I think that also that was not the point I wanted to make. The point is, but when you look at the validation, can we get an agreement what to validate? But it's fully clear, and I totally agree. Of course, originality, depth of thought, importance, relevance, however you estimate that as a reviewer is of course also very important. I think also the point is, with the statistical significance of number of people in empirical research, there's also quite interestingly, comments from Walter Tichy saying actually we should probably better go for case study research at all, because mainly these controlled experiments, as advocated by many, also including himself, are often has been seen of limited, value actually for the community. But I think that is not the main point of the discussion. What I find is the important question: what to validate. The other question is then, can we agree on the methods? But I think agreeing on the methods, we are much fairer than agreeing on what to validate.
Okay, let's have one more question, and then also Paris can say his part.
Okay, I don't really have a question, but
okay, then comment.
Well, I would afford or dare having a bit controversial comment. I believe when we look at the badges, I think they are ill-formulated. Because if you look at the badges, the first two you can get just by pushing whatever you have on GitHub. It doesn't matter, because it is not evaluated by...
Go ahead.
Yeah, because it is not evaluated by the reviewers. It is actually not supposed to be evaluated by reviewers. They are only supposed to say that it is available. So there we don't really evaluate what is there. The two remaining badges are almost unachievable, because we can't, if we don't even want to ask the reviewers to run the artifact, it's difficult to ask them to whether they would actually replicate the experiment. And having a separate paper that just replicates the experiment is something that I have not really seen published in this community, and I believe it wouldn't go through.
Exactly. This is the idea, to have a separate paper. And I'm asking, why don't we have those, even though these badges are there for like 5 years?
Yeah, and I'm telling you, because if you create a paper that just tries to replicate something what some others have, then it would be extremely difficult to do it. Most likely you would just figure out that it just doesn't work, that you don't have enough information, etc., etc. So most likely you would just end up halfway, and then the question is whether you can write a paper just rambling about not being able to replicate another paper. And then even if you succeed, then we have a paper which says, okay, we measured works.
The same.
It's sort of the same. So I don't really trust this community that this would go through. Maybe I'm mistaken, but my experience tells me that this probably wouldn't go through. So in my view, those badges have to be a bit better formulated so that we have something in between. That's number one. And then I believe that the other problem with the badges is that you first have to have a paper, and then you can get a badge. There is actually no motivation to do this. I would say, for instance, Seams is much better in this, because you can get the artifact as a separate publication. And honestly, in the end, what counts when we graduate a student or when we are evaluated at the university, it's the number of publications that we can get at a ICSA conference. So if I just add some extra work by providing artifact and getting a badge, there is no reward for me.
I'm like a nice person.
Yeah, but what is it good for when we graduate a student?
Yeah, but that's a good concrete suggestion. Another one, actually, the second one already. But now let me hand over to Paris so that he can also say his part before we really jump into the discussion.
If I may, just to follow up on one comment, it's a working session after all, and we can have a discussion. So for replications, there's also a specific format that other conferences use. One of the communities I also often frequent is the empirical community. And their conferences have a special track called Negative Results and Replications. Have you ever heard of this? So they actually publish papers with negative results. Like literally you're trying to find out something, you make a hypothesis, your hypothesis is not really accepted. Your result is negative. Usually in this community, we would just not submit it. But these guys say, okay, there's actually value. You tried out, it didn't work out, it's a negative result, and it still gets published in a conference. The same track publishes replications. You took someone else's case study design, you executed it, you did a lot of work, you found something that's sort of similar and maybe different, you still publish it, replications. So this could be another track. You hear this, Raghu? We may be giving you too much work for ICSA 2024, but perhaps this track on replications and negative results, could be another thing. Having said that, so here's my kind of a different perspective on validating software architecture research. So I very much appreciate the work that Ralph and Angelica have presented with respect to trying to classify all of the different kind of research outputs that we have and then try to validate them. But what I'm going to offer are some thoughts on more generically validating research in our community. And I will speak a little bit with a different hat now. I'm co-editor-in-chief of the Journal of Systems and Software, and I do see a lot of architecture papers there. In fact, this community is one of the main source of submissions to JSS. Shameless plug, please submit your finest papers to JSS in the not so near future. So in JSS, we actually publish a lot of architecture papers. And if I have to be brutally honest with you, I don't see a big difference between architecture papers, requirements papers, testing papers, or whatever other kind of research field in software engineering when it comes to how it gets validated. So I'm going to go back a little bit to the basics of how a scientific article gets evaluated in a conference or a journal, because some of these things, I think, sometimes are kind of lost in translation. So if you look at the criteria, for example, that ICSA is using, it's the usual suspects, right? We always try to see how a paper fares against these 5 things. And these are not even things that we came up with. These come from ICSA. So we stand on the shoulders of giants, so to speak. But we don't always understand what these criteria mean. Sometimes you see PC discussions and one person says, oh, but this work is not sound. And if you ask them what do they mean by sound, they will tell you about something that relates to novelty. So I think we misinterpret this criteria very often, and you can see this very clearly in PC discussions. So let me try to just recap very briefly what is the main significance of each of these criteria. Now this doesn't work anymore. I don't know what you did.
No, it should work. I put the focus back on.
Excellent. Okay, so the soundness criterion is basically how well you design your study. What kind of research questions did you ask? Have you justified them well? And depending on those research questions, did you select the appropriate research method? If you asked questions about causality, for example, and you did not select an experiment, but you selected a case study, you may have done something wrong. So does the selection of the research method follow the questions you're asking? And then, do you design the specific study according to that method, according to the specific guidelines for experiments, for case studies, for surveys, and so on? The second one is the significance, and this is basically the so what question. You often read a paper, and at the end of reading it, you're like, so what? What are they trying to tell us? What can I do with this? So the significance is really about the implication. It's not enough to have this wonderful, scientific work and complicated plots and diagrams and numbers. You actually need to say, okay, this is how you can use my results. This is how practitioners can use them. This is how researchers can use them. So you have to be very clear about the implications of the work, both for researchers and for practitioners. The novelty is a very clear one. Do you describe related work in this field clearly? And do you delineate the difference between your contribution and the related work. We often do not do that. We use related work as, oh, okay, you know, such and such published a few more papers in this field, and, you know, this is kind of cool, but we're doing something else. Well, this doesn't really cut it. You actually have to say, this is what we contribute compared to these other guys. The verifiability is basically what Elias has been talking about. Do you describe your study design well enough for someone to replicate it? Do you understand what this means? Someone should, by just reading your paper, repeat the exact same study. We often do not do that. We don't give enough details. We say, oh, you know, well, we kind of collected a bit of data from that Apache repository, and we, you know, crunched some numbers, and we came up with some results. Well, your study design should be described in such details that if you give it to someone completely different, they should be able to repeat the exact same study. And the open science artifacts Elias covered, I think it's a very important topic, and we're not doing enough as a community. We should be putting more emphasis. Maybe, you know, have a Rose Festival next time, or just, you know, put more emphasis there. And finally, presentation, you know, how well your English is. Can you tell a good story? Is it simple enough? Is it consistent, and so on? But this is something very, very generic. Now, we're talking about how reviewers look at validating research and how authors. So here's just a couple of thoughts from the reviewer's perspective. Often as reviewers, we are really strict. You know, we look at the paper and basically we look at these 5 criteria and say, well, this is very sound, very significant, very novel, but it's not very viable. Reject. Guys, you know, take it easy. There's no such thing as a perfect paper. There's no paper that satisfies all of these 5 criteria in an excellent way. It doesn't exist. It's a fiction of our imagination. And if I may, it's also a bit of a cultural thing. We have been trained as computer scientists, and we look for bugs, not just in software, but also in papers. You know, we are very happy to find bugs in a paper and say, oh, there it is. These guys, you know, they forgot to do a good statistical or choose the right statistical test. Reject. Come on, guys. We are really getting very hard on ourselves, on each other, and we are being very strict. We should look at it from the opposite perspective. Do I find enough value in this paper? We should be more positive. We should try to say, okay, this work, it has, you know, a couple of flaws, but it also gives value. You know, we should allow for publishing this work, having it discussed in a conference. And a final note from the reviewers, I often see in conferences like ours, like ICSA and EXA, PC discussions being really relaxed. You know, some PC member says, oh, guys, I think we disagree here, but this looks like a reject, right? And everybody says, yeah, whatever, you know, just let me get on with my life. We should really have good discussions. We're supposed to go into details and say, oh, wait a minute, you said it's not novel, but I don't agree. Let's have some arguments, some debate about this. I know we're very busy people, but we end up rejecting very good work because we're not active enough in the discussions. 2 more points and I'm done. From the point of view of the authors, we often say, you know, oh, we're doing this brilliant research work and we've written this amazing paper, but the reviewers, they're idiots. They just don't get my brilliant work. Well, you know something, perhaps you could have written it better, you could have used better language, you could have used more time to, you know, make the message more simple and, you know, make a consistent story. The PC members of any conference or any journal are very busy people too. They're spending 2 hours of their valuable time to give you feedback. So make it easy for them. Make sure that the paper is easy to read, that the replication package is easy to access and well organized. make sure that they actually have a good mood reading your paper. They're not pissed off. And then, you know, it'll be much more easy for them to reject the paper. And finally, because I've been interacting with the empirical community quite often, I have to tell you, as an architecture community, we're not really doing a great job in our empirical studies. I cannot remember how many times I've been cringing on the study design of papers from our community. We say things that are completely untrue. We are not aware of the basic guidelines for doing empirical studies like case studies or experiments or surveys. And we have a complete disregard for threats to validity. Threats to validity in our community is an afterthought. You've done the work, you've written the paper, oh, wait, there's this little section just before the conclusions about threats to validity. Let me make something up. Yes, you know, external validity. Our results can be generalized, maybe, but, you know, I'm not quite sure. Whatever, just write something. We should really become better at empirical research. We should educate ourselves more. And I think that was my 10 minutes of fame.
Thank you. Okay, also here, let us have some immediate opinions and discussion. That's good. While I'm at the background setting up something so that we maybe can vote on what to briefly discuss before the next session starts. So, yes, please, do you have a microphone?
Thank you. I would just like to thank you, Paris, for all what you said, because, and I couldn't emphasize this more, and now I would kind of like put on the hat of ICSA 2022 General Chair, and we were exactly facing exactly the same problems. The program committee was extremely negative. It was like almost impossible to get a, like evaluation where we would have all the PC members positive on a paper. So of course normally like what one would do is that you accept papers where the PC members tell okay, accept or accept or we accept. But if we really went with this criterion, we would probably have accepted 1, maybe 2 papers. So, and I believe this is the fault that lies on the shoulders of the reviewers. They really have to look for a value. And one thing that I have not really seen pretty much never was when there is a discussion, I always see that the discussion tends towards negative outcome. So whenever there are a few voices and one of them is negative, it would be like if our aggregation function was minimum. So we always go with the lowest possible outcome that is suggested. And essentially what I'm actually missing courage. I'm missing courage among the PC members to just say, well, the evaluation is a bit bogus, but the idea is lovely. Let's just give it a try. I mean, they can fix evaluation in the next paper or whatever. Let's just let it see the light of the world. And I have really probably never seen like a discussion where someone would really stand up and would say, you know what, I like this paper. Forget about your objections. I mean, of course, everything is not perfect. I mean, let's give it a try. Because people would typically say, well, yes, you're right, the evaluation could have been better, so let's reject it.
Yeah, thanks very much, Thomas. If I can offer one thought just to complement what you say. In a PC discussion, it's more work to champion a paper than to reject it. Because if you want to champion it, you have to read again your review, everybody else's review, make some arguments, you know, have a clear argumentation to champion it. The rejection is like, yeah, but you know, evidence is not strong and study design is not good, so you know, let's just get rid of this. So it takes a bit more work to champion a paper, but again, you know, we need to do the work. We're really, you know, doing damage to ourselves by being so grumpy and rejecting, you know, everything.
Honestly, to even emphasize this more, if we continue doing this, we are probably not going to meet anymore in 5 years.
Okay.
On that bombshell.
Let's stop. No.
Can I?
Okay. Okay, Patricia.
I'm hiding here. So I wanted to make a comment and an extension. Naturally, I agree with what you presented. Just if people didn't notice, there is a difference between valid research, as you emphasize, and validated research. So we are having this discussion in that direction indeed, just if people didn't think about that. An extension is related to the replicability in open science. I want also to disagree a little bit in that we praise a lot the collaboration with industry, public and private sector. And replicability doesn't mean that every research should be replicable in every single aspect if you have an NDA. So it happened to me in the past that you have certain ethical constraints that you want, of course, to fulfill, and then some things cannot be shared. Yes. Now, that doesn't mean that a paper should be rejected because it's not fully replicable. So this nuance should be also embraced by the reviewers and not say, oh, now we are in the open science, open access age, and then everything must be open, and if it is not open, no, that's not good. So I want to emphasize this aspect because it's equally ethical as for open source, open access to actually share good quality data sets and results, etc. Thank you.
Yeah, and it's even really important to have the practical part, and we should never put roadblocks on that, so I completely agree. We have one more question there at the back by Raghu. While the microphone is traveling to you, let me comment quickly on the criteria that you showed, wondering where actually what Ralf and Angelika were saying fits into that. And I think it's an aspect of soundness, because you're saying what research questions are asked, but maybe even a bit on top and maybe not quite covered by the soundness. So the question is, okay, if I have a prediction method, I can ask many research questions, but they may not be fitting maybe to the significance somehow. So I can ask about developers and their shoe size. I think that's one of Ralf's example, and they can do a perfect valid question and study, but what does that particular choice of question then also tell me about the significance of the approach? Okay.
The significance, I think, is something completely different. It's the so what question. So you have results, they came out of a study. Okay, if the study is perfectly designed and you have no flaws, mitigated all threats to validity, good for you, you have your results. But sometimes you read these papers and they're like, yes, our machine learning classifier does, performs 3% better than the state of the art. Yeah, and so what does that mean? So you have a perfectly, designed study which basically gives you no results at all in terms of significance. I think these are very different dimensions, and you have to address both of them if you want to actually make a validated contribution.
Sorry, now I have to respond. Sometimes maybe there's a gap between the significance of the story of the paper overall, the narrative. So I'm doing a new design decision support method, and of course it will help architects around the world. But then the research question I'm asking for evaluation is related to the string length of the decision records, not connected.
This has to do with valid versus validation.
Maybe. Yeah, okay.
Because these categories basically are meant to judge a paper, not its evaluation.
Okay. Yeah, maybe I'll add another of these orange sticky notes. Those are the ones I meant to maybe do some smaller discussions soon. But yes, please.
So some great points being made here. So one factor that I wanted to see and get your feedback is,
Is there a different level of validation when industry is involved versus something that's written where it's purely from academic perspective, right? Is there
like an implicit trust or bias in what the industry provides? As a result, validation is a lot more simpler, and it becomes that much more easier to judge in that sense.
So that's a very good question, and I think it's often a very misunderstood part of validating research in our field. Sometimes you see a study that has mined the repositories of 1,000 Apache projects, and it's a massive amount of data, and they have done an amazing work. And then there's another study that has asked 2 architects for an opinion on something. It's very sloppily done. And people, the reviewers, will still say, oh, this is industrial, we should just accept this one. And the Apache thing, this is just academic, open source stuff. It doesn't matter. I think we need to evaluate each one for its own merit. If it's open source, we evaluate it as open source. If it's industrial, we should evaluate it as such. So we cannot use the same kind of criteria and standards for both cases. Both have merit. We should not just say everything that's industrial is golden and everything that's kind of open source, it's kind of a second-class citizen. They both have merit. They both should be first-class citizens as long as you do a good job with the study design and all of the other criteria.
Okay, now we have even one more question by Ralf from the audience, but before Ralf is saying something, let me now open the voting here. So on the Miro board, you see a lot of activity and also some parallel discussions going on. You can maybe have a look at later if you would like. And the idea is now that with these orange things, if you think that more things are actually topics for discussion, then please move them more into this area so that we can vote on just these orange ones or maybe a few more on discussing them for another 15, 20 minutes in small groups. Let's see how far we get. So that I'm opening the voting now, but Ralf, you can also comment before we then split.
Yes, I think there was one important point also by Paris, of course, saying that, soundness is also one dimension. And of course, all what I said about validation is probably in this one dimension. The other dimensions are also important. But when I look now, when it comes to this relevance or significance discussion, that's something which I find very hard academically to evaluate. And I think we also should have a clear understanding what can we expect in an academic setting to reasonably really to validate or to demonstrate with data, whatever kind. And I think that is not so easy because sometimes, the impact is not clear in the beginning, and then that's something you could only look in, 20 years later on. And also, whether it really, can have an impact is probably something which only the practice can show. And if we look around, many significant things nowadays we would see in software engineering are probably never really academically validated. They were just, made it in practice, and then people used it, and they experienced some benefits in projects. That is not an, let's say, controlled experiment. It's just, that you observe it on the long run. And so that's something probably we can't ask for in a paper submission, because then, of course, nobody has really a clue whether it really will have an impact or not. So in my opinion, we should also clearly see the boundaries of what we can do academically in academic settings.
Okay, thanks, Ralf, and thanks a lot, all of you, for the different inputs. Now, I think this time, for the other session, it was not this way, but this time we have to stop on time because there's the next session coming up. So let's actually now see what people are interested in to discuss further, and then we have, well, at least 15 minutes in smaller groups to discuss, or at least also identify people who are interested in discussing something maybe further. So the Miro board should now be enabled for voting, so you can go to this short link here if you haven't done yet, bit.ly SA validation, and join this board. You don't have to log in, so you see all these anonymous people here, and you should be able to add some votes, and then we see. If you have problems, let me know now. Are you in the Miro board now? So there should be some join voting thing. So here on the top there is the 2 minutes voting. If you don't see it, it should pop up automatically, but you can also click here, then say join voting, and then it should look like this. Is one of the nodes missing that should be voted on? then let me know. Does it work for all of you? So I see here 10 out of 23 voted, so let's wait a bit. All good, or is anyone experiencing some problem of voting for something? Okay, for this one here in the middle, what are the aspects to validate? And then I said instantiate this for a certain contribution we would like to discuss. Maybe now we can't add more anymore. So if you are interested in any type of contribution and want to discuss how to validate it, then please vote for this one, and we can split even more than in that smaller group. Yeah, it's here. Oh, it's not shared. So the link is this board bit.ly SR validation. And it's also in the chat. For the ones in Zoom, I just posted it in the chat as well, this link. So everybody should be able to access it. Ooh, actually, I set some time, and in 22 seconds, it's over. But that's maybe fine. We have a lot of votes now. Okay, I'll give you this another 8 seconds. Then I'm curious to see what happens, actually. I haven't tried this, I have to say. Okay, so here we see some results. Let me click on see all results here. We have to move Ralph away. So let's see. So 10 of you would like to discuss what do we need to change in order to, in our contributions to have architectural papers accepted in ICSA. Yeah. Also 7 votes on valid research versus validation. Now this one I can't read, but that's the one on the research, the types of research contributions. Then, it's small. Should we classify according to research objects and contributions? So maybe these two are related as well. And how to increase the amount of evaluation batches, how to formulate evaluation batches. So maybe that's 4 groups that we can do. Let me scroll down a bit whether I'm missing something, but no, that's fine. So that, now, here on this side of the room, people can meet who want to discuss about the first one. What should we need to do to change in our contributions to have papers accepted at ICSA? Then in the back, the discussion about valid research versus validation. That's good because Patricia is sitting there. Then in that back, let's meet about discussing the relation of research object and validation. And then finally here, those people interested in artifact evaluation can meet. So now you'll have to move a bit, which is good because next session will be right after, so you don't have to sit all the time. Okay, so now you have to get up and move. Okay, and for those of you who are attending online, that of course doesn't work now with the hybrid setting. Okay, to remind people about the corners of the room, we don't have so much time, so if you could go to the corners, that would be great. So it's the contribution types here, valid research over there. No, sorry. Oh no, it's the getting papers accepted at ICSA, let's say here, valid research in the corner up there, then the types of contribution over there where Raghu is standing, and artifact evaluation down here around Tomasz. So do you want to go there? Ralph, you're raising your hand. Did you want to say something? Okay.
Actually, no, but of course, I think we, as you said, we online people are probably out here.
Sorry, I don't hear you anymore.
We only have 15 minutes left anyhow, aren't we?
Yeah, we will just have some short starting discussion now in the different rooms, and then that's it, because we have to end on time sharply, because there will be the keynote next. No break. So now the discussion here in the room is starting. That's great. We have those 4 groups. Yeah, and they'll discuss a bit, maybe see whom to collaborate on this in the future, and then no conclusion at the end. Let's see. So thanks for all who are participating or were participating online. And bye-bye already. Okay, just a brief interjection, let's say. Thanks a lot for discussing a lot, and you can continue even a bit while this next presentation is being set up. But please, so that we can follow up on this, potentially, if you like, for those 4 topics that we're discussing now, I forgot to ask someone to take notes, sorry. I hope if you have been taking notes, then please share them later also here, or send them to me. But Now, if you want to follow up on this, please put your names in the respective fields here, so that later we can contact you again, or you can discuss among the group. But now you can continue for a little bit, but I'll take down the presentation for now. So thanks a lot for joining. I see there have been active discussions around. That's great, and let's see how we'll follow up on these things. Thank you.
Welcome to today's keynote speaker session. It's personally a great honor and pleasure for me to introduce the today keynote speaker, Bran Selic. This is due to several reasons. Formally, Bran Selic is founder and president of Malina Software Corporation since 2007. He is adjunct professor at the Faculty of Information Technology of Monash University since 2017. He has been actually lecturer and scientist in many academic and research institutions around the world, I would say, among which I would like to remind Object Time in the 90s, and for the ones that are as old as me, I was a PhD student at that time, and I have been dealing with Object Time product and technologies. He has been part of Rational and IBM in 2000, where he has been leader of several standards like UML, SPT, and Marte profiles. More recently, I have to say, while at dell'Aquila we were fighting with our academic institution for the introduction of formal regulation, University of Malardalen up there has been quicker and has given to Bran an honoris causa PhD, I think well-deserved. So it is yet another great success of Italian bureaucracy, but I think they have repaired. No, I'm Italian, so I can say. But it's a great achievement, well-deserved. Less formally, I can definitely say that Bran has been a founder of the model-driven engineering discipline. His seminal work has opened a new perspective to deal with models as first-class citizens in the software lifecycle. In parallel and several times in conjunction with the software architecture community that is here, the model-driven community in the last 3 decades has worked towards the introduction and adoption of modeling artifacts beside the pure software code. And Bran has certainly been, and is still today, a leading actor and a reference in this process. A whole generation of researchers like myself, but this is not important myself, has been inspired by his work and by his long-term vision in this context. And finally, it is always a pleasure to host Bran here in l'Aquila, where we maintain a quite continuous scientific collaboration beside a personal friendship with him. A few days ago, Bran wrote to me, coming to l'Aquila, it's almost like going home. So, welcome back home, Bran. The stage is yours. Thank you.
Where did you dig up that? You've taken 5 minutes of presentation time. Okay, no, I really want to thank the program committee. I want to thank the audience for sticking with me. You might regret it after you hear what I have to say, but that's how it is. But I'm also, it's really is a pleasure to be in L'Aquila. I have some very good friends here, and as Vittoria said, I'm very thankful for everything they've done to me, and we've done some very good work in this place. Unfortunately, I don't know if anybody uses Zoom, you'll get actually a much better picture of what this background here is. This is the resolution, screen resolution here is not very good at all. But it's a very messy diagram, if you like. And it'll be a little bit clearer. So this is the title of the talk that I gave to the organizers because they asked me to give one ahead of time. I wasn't quite sure exactly what I wanted to say. So that was the title that you have in your program. But I really meant to do this, you know, because I understand this is a research community, and therefore I'd like to tell you what I think would be a very useful avenue of research. But before that, I want to tell you what's wrong with the world of software today, because I have a long history in software. I wrote my first program in the world's best language ever, Fortran 4, in 1969. And it really is quite amazing what has happened in between. And somewhere along the way, I've gotten some opinions that I hope I can share with you. So, in preparation for the talk, I went and looked at all the books. I went to Amazon and I said, okay, give me books on software architecture. I got 75 pages worth of about 5 or 6 samples on each page. So it's a topic that, you know, is pretty well studied, right? There's, you have all this stuff at your disposal. There's the reference architectures. There's Grady Booch has an excellent, by the way, online catalog of architectural patterns that you can find. Like I said, there are hundreds of textbooks. So it looks like it's a topic that is well explored, and it's fair to ask this question. So are there any real research questions? Because I looked at some of the more recent books on software architecture, and they seem to be repeats pretty much of what was already said. Although I have certain opinions about how well these things are understood even by the authors. So, you know, if there are some research questions, and I think there are obviously, otherwise I wouldn't be talking, what are they and why have they not been addressed? So I'll have opinions expressed in all of these. So, if, you know, if there is, has anything changed since those books were published? And, you know, we've explored the field quite well. Like Grady has, I think, over 100 patterns, architectural patterns. So it looks like a well-explored field. But before I answer that question, I'll begin with a cautionary tale. That's a sidebar for those of you who are not necessarily aware. A sidebar is, you know, when you get into those articles, there's that sidebar on the side that deals with some peripheral question. And somebody once compared that, it's like, you know, going to answer the doorbell on your wedding night. You know, you're trying to read the article and now you have to go and deflect. Okay, so I'll give you this example. It's actually a true story from a very credible and very well-respected automotive manufacturer in Europe. I won't name them. But I don't know, I've worked with these people on automotive, and if you can save 5 cents in the manufacturing process, you get rewarded with thousands of dollars for that, because it's that important. So the idea came, can we get rid of the traditional parking brake? Because, you know, I mean, first of all, it's a piece of hardware that needs to be installed. There has to be those cables that run back and forth. And nowadays, in fact, I just got a new car on Monday, and it works this way as well, although it's a different manufacturer. No, let's do it this way. It's all going electronic. We're going to press the button, and that will arm the parking brake. Okay, and that looks kind of cool because, you know, the information will go to some software, because it's all done through software now. It's all electronic, and that will enable the brake. So that looks cool, but there was one big problem. It said, well, you know, how do you disable, you know, or release the brake? Okay, why is it a problem? Well, you know, you press the button and you don't know how many times have I pressed it. You know, is it a toggle kind of thing? Or even if you put a light on it, because some manufacturers did that, they put a little LED on it. The trouble is lights can go off and not work and so on. So you could end up driving with your parking brake armed. And so they came up with this idea, which by the way is actually the same one that Toyota is using, it turns out. Toyota is my new car. So when you press the accelerator, this is detected, and is detected, and therefore it means that somebody wants to move. Therefore, I'll release the brake. So if the car is parked and somebody hits the accelerator, presto, it works. So here's how they decided. How does the software, brake control software, know that the accelerator has been pressed? Well, they go to the electrical generator, the dynamo. So when you hit the accelerator, it speeds up the dynamo, of course. And what they did was they put an RPM monitor, revolutions per minute. Okay. And that goes to the brake software. So now they know what's happened is this accelerator has been pressed and it'll be released. Because these are fancy cars, there's also other systems, many, many other systems. There's the air conditioning system as well. And that's a simple system, relatively speaking, right? There's a sensor, there's a compressor that drives all that fluids that have to do with cooling, and of course there's a piece of software in there. So the software gets input from the temperature, and that goes to the compressor, and the compressor starts working fine. And these are two different systems designed by different people. In fact, now with the AUTOSAR standard, these things become commodities. There are people who specialize in doing, maybe brake software, and they compete against each other, and they all plug into the same backbone, AUTOSAR backbone. Now here's the scenario. So there was a very hot day, and they built this, actually put this into a test vehicle, and the driver enabled the parking brake, or armed the parking brake, opened the door, went out to open a gate that was in the way. Okay. It was a pretty hot day, as I said. The temperature went up inside the car. Some of you may already guess what's happening. This created a power demand. The air conditioner started working because it detected the temperature was high, created a power demand. The compressor started working, the RPM sensor detected and the car started moving with no driver indoors. And of course, it's one of those things you say, oh, who would have thought of that? Because not only, it's not just opening the door, it has to be a hot enough day. Okay, so this is this unfortunate sequence of circumstances that somehow couples these two uncoupled systems. Okay. So what does this have to do with software architecture? There isn't much software that I've shown here, and it doesn't look like a software architecture problem. I'm going to get to that because it's very relevant. So what are the challenges of 21st century software? Back to the question, has anything changed so that we need more work on software architecture? Well, here's, smart homes, smart cars, smart robots, smart cities, Internet of Things. All of these things are smart. And this was actually, I was working on a project, the H2020 project in Norway, and this was the official slogan at the time. I don't think it's there anymore, but it's smart anything everywhere, right? In other words, we are going to really make things very smart. However, what exactly do they mean by smart? And I think it's a badly chosen term. I really dislike it very much because it creates a certain impression and a sense of what it actually means. Everybody interprets it differently, especially the people who may not know that this is a bit of hype. So here's a definition I use. So a system is a smart system that has the following capabilities. This is my understanding, what sort of trying to capture a consensus on what there might be. It can sense what's happening around its context that it's embedded in. It can detect changes in that context and detect them in its, as well, maybe changes in its internal state, and it does that in real time, so there's no delay in detecting these changes. And then it can respond in a timely manner. I avoided the term real time because that's, again, another ambiguous term. But it responds in a timely manner to some of these changes, like the temperatures going up. This is an optional part, but it's pretty much understood when you're talking about smart, you should have some kind of artificial intelligence, machine learning, or whatnot, and therefore it autonomously adjusts its behavior based on the experience or data that it has or whatever it was trained on and so on. Okay. And here's the key thing, it gets networked. We want, in a smart city, obviously we want the traffic control system to be somehow connected to, I don't know, the road system, the plumbing system, the waste management system, whatever. That's what smart cities are all supposed to be. It's all about networking. Okay, so we're going to have all of these smart systems and they're going to be all networked into one huge smart system. And so what we really mean is that we would like the system to respond in the same way that a good, highly knowledgeable, expert human person would respond. Whether it's a known issue or an unknown issue, we want it to react in the way that we want a person. And what stands in our way of this? Okay, let's look at that. First of all, we don't know how to design these systems. That's not stopping anyone, by the way, especially in the commercial space. Everybody's rushing to claim that they have a smart refrigerator and whatnot. Right, or smart TV. I don't like smart TVs, so I'm trying to find a good enough stupid TV, and I can't. You can't find stupid TVs. Okay, but why don't we have this? Why don't we know how to build these systems? First of all, we don't have enough experience, but worse yet, and this is what I'm going to try to convince you, is it's a wicked problem. Okay. It's a really difficult problem for a variety of reasons. One of them is that all of these systems involve some kind of interaction, timely interaction with the real world. And the real or natural world is an unfriendly place. It doesn't do what we expect it to. It's not precise. Murphy's Law happens all the time. And the only way, it's extremely complex. The only way we can deal with complexity, the only way we humans, especially engineers, deal with complexity is through abstraction. Okay? And that, we know, is a success story, if you like. So we need abstract representations of these. It's, like I say, one of the most powerful weapons we've got. And here's part of my thesis here that some of you may challenge. I think this is a problem. Let me go into that. In other words, what does abstraction mean? We take out things that we don't think are irrelevant or that are of no concern to us and focus on those things that are of concern to us. So it means removing information, and maybe generalizing it, which is another kind of removal of information, and so on. So let's go back to our, it's all about divide and conquer. We say, okay, we can break up this problem into these sub-problems and work with that. So here we have the brake control problem, and we have the air conditioning problem. If we look at the software architecture of this, so there's these two applications running on top of a common platform. This is standard now. I think almost all manufacturers support this AUTOSAR standard. And you can just plug in, if you respect the interface rules, you can just plug in your version of the brake control system. The AUTOSAR itself has a standard for how it can, all these different manufacturers of brakes and whatever, they produce a standard interface. Okay? And beneath is the actual hardware, of course. Now here's one of the things, we have this architectural rule, which by the way is pretty much misunderstood. You're not supposed to go down more than one level. It's, by the way, wrong for a variety of reasons. But, if we take that as a given, I mean, there was a talk, I think the keynote yesterday talked about, well, there's this platform that you get from, say, Amazon Web Services and so on, and that's all you have to care about. My experience is different because I find that unless you worry about the whole system, you may have trouble controlling that system or managing it, whatever word you want. You know, one of the biggest issues I found, and I worked on some very complicated systems, telephone switch had literally 2,000 developers working on it, 30 million lines of code. It was quite a monster. And the thing that we found, by the way, was that the biggest part of the code, 80% of the code had to do with bringing the system up and maintaining it in an operational state. So only 20% of the code was dedicated to the telephony. 80% of the code had to do with, because they have high fault tolerance, you know, so you had to recover, you had duplication, redundancy of systems, and so on. I worked on the software that actually did the switching from one processor to another, which is quite a tricky bit, and you have to do tests and whatnot. Anyways, it's probably even worse having the switch than not having it switch over, but it sounds good. You can claim that you have 99.999 availability. But here's the thing, if you don't look, if all you look at is your layer immediately below, you won't see this. Okay? You won't see that there is actually a shared element that can lead to feature interaction. This is known as feature interaction from telephony, and it's an enormous problem for us. There were conferences on the feature interaction problem, different attempts to solve it, and so on. And in telephony, it was quite sophisticated. Even before these mobile phones, it was quite sophisticated. There were about 400 different features. And you never knew who was going to combine which feature, which customer, which user was going to combine which feature with other features. So different Bell operating companies would buy different versions and have their own, configure their own features and so on. And it was impossible to find, literally it was impossible to find all possible feature interactions. Remember, some of these feature interactions depend on the ordering. You know, the same sequence, the same two features work fine 90% of the time, but occasionally they come into conflict because of the timing issue. Okay. So the term feature, we can generally say any kind of ordered actions, set of action steps that performs or realizes a desired outcome. So the feature interaction occurs when there are two, well, actually it could be even the same feature but used on two different instances of the same feature. Right. And they can interfere with each other in a way that nobody forecast, like the people who did the air conditioning and the brake control system. And here are the necessary conditions for a feature interaction. There has to be, of course, a hazardous precondition. So it may have to do with timing, when do they start, and so on. There has to be a shared resource somewhere. And when you're dealing with things like the cloud and so on, you have no idea where the shared resources are, or it's not that easy to find out. And like I said, it's a temporal overlap. It depends very much on when things started, how fast are they progressing, and so on. So literally, it is impossible to detect this. You know, and say, okay, now I've looked at all possible features. You know, I put up a matrix, feature X, rows and columns, and then check every box in there. You know, that's 10,000 boxes in telephony, but now we're dealing with much more complex things. So what makes feature interactions highly problematic? As I said, the cause of the conflict is difficult and not obvious at all. It's, you know, you only find out, unfortunately, when it actually happens. All of this stuff happens because these features are defined, you know, in telephony you define, say, call forwarding and call blocking independently. But it turns out if you use them together, they can interfere with each other. So as I said, in telephony, we worked out there's probably around 10,000 different possible feature interactions, although nobody ever listed them. Okay, that's a simple system, okay, even though it had 30 million lines of code. Now we're dealing with something like a smart city. You know, there's this famous saying that says, the law of unintended consequences. Well, in my opinion, this is scary. I don't know what it means, but we're going to run into this problem all the time because we're going to be networking these different kinds of smart systems or dumb systems, whatever, And they're going to interfere with each other in unpredictable ways, which might even be safety related. And one thing that is for sure is that we'll never be able to, if we couldn't do it for telephony, we can't do it for something like a smart city. So this is going to be an immense problem that is now people who are designing these kinds of architectures. It doesn't have to be a smart home. We already find, you can go on the web and find stories of conflicts between, the doorbell and the lights. It's all networked now. So these things will happen because there's so many people involved. So there's more stuff here. And this is a point I would like to, and this may be debatable, although I don't think it is. How many people here have heard of Gödel's theorem? Okay. Gödel's theorem was a response to the famous Hilbert program. Hilbert was a mathematician somewhere in the I think it was in the 1920s, when he said, we have to put mathematics on a sound foundation, and therefore, rather than come up with these axioms which seem to be arbitrary, we're going to have a foundation for mathematics, a formal foundation for mathematics. And Gödel tried to prove that, and unfortunately, he came up with the exact opposite. He proved that any formal system either doesn't cover all possibilities, in other words, not all truth can be covered with a formal system, or if you cover all truths, you will have a system that is inherently inconsistent. What does this tell us? Well, this tells us that nature itself is not formal, at least not in the way that we think of when we talk about formal in mathematical terms. So there's a fundamental dissonance here. We're trying to control this world using something like a computer. After all, a computer is, the circuitry is based on basic logic. The programming languages and all of that is based on this kind of stuff. So we have this dissonance that we're trying to control something which is, for example, continuous with something which is not continuous. We have solutions for some of these things, or good enough ways of bridging this thing, but in general, I think it is a fundamental issue. So, we have these smart systems, and there are these dragons. And one dragon I really want to make everybody aware of, because this is part of some research that I'm doing these days. This is the biggest source of all of these things: concurrency, unpredictability, inconsistency. But I do want to make you aware, because as software architects, you are responsible to those. You are responsible to those. So if you're a software architect, and by the way, if you end up using the term end user, I would say you're a bad architect. What's wrong with end user? Two things are wrong with it. It gloms together all these different kinds of users. Literate, computer illiterate, different cultures and so on. It's all one thing. It's something called user. Like I said, I work with the automotive people. There is no concept of end user there. There is the mechanic, there's the driver, there's the passenger in the front seat, the passenger in the back seat. They differentiate all of these things because in classical and traditional engineering, what you do is you are very much aware of the context. This is very important. Architecture is not, of course you have to understand the technology and what you can do with it. But it's not a technical problem, or not purely a technical problem. And nowadays, because we're forcing people to use computers, modern society works fundamentally depends on the internet and computers. You're forcing all of these people to use computers. If I want to make a reservation on the bus to the Rome airport, I have to do it over a computer. So please, the job of a software architect is not dealing with just these things, but that. And, my experience is that end users, and I'm guilty, end users are somebody like me. If I didn't study them enough, well, they're probably going to get it, right? This is the sequence that, you should hit this button first, then that button, and so on. And instead, people do what we say, stupid things. Oh, look how he broke this beautiful piece of software. But it really is the other way around. The responsibility is on the architects. Anyways, that's a bit of a side. I am upset, by the way, that even here, it's all about technology. Most of the talks, I didn't attend many. I apologize. I had some other work that I had to do. But most of the stuff had to do with technology. That's good. It's useful. But software architecture has a fundamental human-centric aspect to it. And there's more than, end user, by the way, means that all I care about are the people who are directly interacting. But there are so many people who are affected by it. The people who are not necessarily directly interacting, the owners, the people, like the people who are recognized by incorrectly recognized by facial recognition software. Right? So there's the, if you like, the community impact, then there's the social impact on, if you like, on society as a whole. All of these things are what software architects must care about. And I know, we're technical people, we're not psychologists and so on. And this is why we need help. It's a multidisciplinary. Software architecture should be a multidisciplinary activity involving all different kinds of relevant anthropology, psychology, what have you. Okay. Because these are the difficult, we can deal with controlling tractors and cars and things like that, even though, because they're a little bit more predictable, but people aren't. Okay. Now, here's the kicker. In order for us to deal with this natural world, we have to have in the software somehow a model of that world. I don't necessarily mean a UML model or a formal model. It could be data structures, it could be the code itself, etc. But all of that reflects my understanding of what it is that I'm interacting with. And unfortunately, the current technologies we have, and this is why it's partly why it's a wicked problem. The current technologies that we have are not powerful enough to do this. And there's a history behind that. I think I have a couple of slides on that. But I'll give an example that Alfonso Pierantonio and I worked on. And it was part of this idea, well, how can we bring the modeling world closer, the modeling world as understood in software engineering, closer to this natural world? So, if we look at this problem, we started actually with this problem. There's a frog. It evolves, from a tadpole and so on, right? And it has a tail which it loses eventually. It grows legs and so on, and so on. And we were saying, well, how do we describe this, say, using classical inheritance and class modeling and so on? So if you like, the class of the instance changes dynamic. In fact, it changes continuously, which is an issue, right? At what point do we actually switch from one class to the other? But let's say we arbitrarily decide, well, a tadpole is up to this point, and full adult frog is up to this point, and this stuff in between is maybe. But you notice what we've done here? This is arbitrary. This is nothing. The frog knows nothing about classes. Classes are our way of dealing. They're abstractions. We mustn't confuse our models with the reality that they're modeling, which is a common mistake. So once you put these classes in there, you think you're applying it to all frogs. But I have a better example. Let's say this is these are two frogs. They're both 7 weeks old. In other words, the exact same age, but one just grew faster. I have an example. My grandson plays baseball on the under 14s. Right, so the league is classified into under 6, under 12, and so on. And in this under 14 team of my grandsons, there is a young man, under 14, who has actually a full beard. And my grandson doesn't even have the shade of a whisker. Yet they're both in the same class. Well, so this is a problem with classification. What is classification but our abstraction? So you can see that abstraction can be, as much as it's powerful and useful, it can be a problem with us, right? So what we try to do, if those are interested, is that we basically are allowed for something like overlapping classes and coming up with ways of programming language constructs eventually, but right now meta models of how to deal with this, because no conventional language can deal with this kind of thing in a sufficiently accurate manner. And it requires a different approach. So there's a paper there. You can talk to Alfonso, he's over there. But here's another example. And now let's look at why this is. I love this example by a friend of mine, Edward Lee. He says, you know, I'm a real-time, or I was a real-time guy for the longest time, for decades, and still work on cyber-physical systems and so on. And one of the things is you look at all these theories of computing, love the idea that time takes zero. All the actions are zero time. And it's obviously an annoying property that time actually takes time. But here it is. You see, I trace this back, and this is my opinion. You see, much of current computing theory evolved from its mathematical origin. I mean, computers, that's why they're called computers, is they're used in computation, right? Code breaking, numerical analysis, mapping out artillery tables and whatnot, okay? And naturally, the technology, the languages, if you like, and other related technologies, including the underlying hardware, were based on formal mathematics. So the theory of computing was developed primarily by mathematicians or mathematically oriented engineers. And this has been assimilated by the next generation. So the initial generation, Turing and so on, they were mathematicians. And then the next generation of software developers, and it was instilled in the languages. You know, I give this example. My favorite example for this is that, I don't know how many people have heard of the Mars Climate Orbiter. Anybody hear of the Mars Climate Orbiter? The $500 million, $500 million project that failed? It was a satellite that was supposed to go around Mars and monitor the climate of Mars. And it worked well in testing for some reason. And then it went up to Mars, and when they deployed it so that it can go in orbit around Mars, it crashed. Okay? $500 million down the drain. Why did it crash? It turns out that one development group was using metric. The other development group was using imperial measures. And of course, you know, there was this huge discrepancy. I don't know what kind of testing they did, but that's beside the point. The point is that this is a classical type error. Why wasn't there a compiler that detected that I'm, adding inches and centimeters? Why? Because all the numbers, reals, integers, they're all dimensionless. This idea that I should include, for example, the notion of a kilogram into my programming language is, I actually asked that question about 20 years ago. There was a conference in Montreal where all the Java language designers, Bertrand Meyer with his Eiffel and so on, they were all there on the panel. I asked them, well, to what extent is the physical world going to be present in our programming languages? And they all looked at each other. And the only one who dared answer was, I think it was Meyer, Bertrand Meyer, and he said, well, maybe time. Okay, but these, in other words, the languages are built on these classical foundations, which go back to something which has nothing to do, or hardly anything to do with modern software. I'm exaggerating. I mean, there is certainly a small portion of software that deals with code breaking or whatever, and so on. So here's another example. One of the giants of our industry, Dijkstra. He had this beautiful dream. He wanted certainty. If I develop my program as I develop my math, theorem, theorem, proof, theorem, proof, theorem, proof, I'm going to have, this is the right way to develop software. And then in another one of his notes, and by the way, this gentleman did not, I don't know how many of you know, he actually wrote everything in longhand. He didn't even use computers to write his his documents. You can get all these documents. EWD stands for Edsker Dijkstra. These are posted online, and you can find these. And then he said, we were working on this operating system called THE in the Netherlands. And they found there was a bit of a problem that, you know, the CPU had to wait for the printer. And CPUs at that time were very expensive things, so you wanted to maximally utilize these things. So they introduced this interrupt, right? That says when the printer is ready, it will interrupt the software. And he said all hell broke loose, meaning that you can it's no longer a reproducible thing because there is a random element in the way these things occur. And it's working, for example, with concurrent things, that becomes a huge issue. Now, I would want to point out it has nothing to do with efficiency, really. The interrupt is the fundamental way in which software interacts with the physical world. So if you want to work with the physical world, with the natural world, you cannot avoid interrupts and this phenomenon here. So this was a nice dream. It's laudable, but it's unrealistic. So this is what it means. The loss of certainty, and uncertainty is a theme here, which I'm very, very happy to hear, and there's a nice workshop coming up, as I understand it. How should software engineering deal with uncertainty? How should software architects? Interesting, just before we came here, we listened to a talk from a civil engineer who uses computers for some of his work. And he says, you know, I asked him, well, you know, you talked a lot about uncertainty because they have, you know, the measurements have to be very precise, the models have to be quite exact and so on. And I said, to what extent are you guys working with uncertainty? How did you fit that into your methodology? And he said, it's a fundamental part of our methodology. And I said, I wish it was true for software. And he said, I don't believe that. You mean, he had a much nicer view of software than the reality is, right? So how should it deal with uncertainty? And I spoke to David on this last night, and I sent him these slides. He and I worked actually on uncertainty for the object management group. There's a standard out, by the way, on how to model uncertainty. Whether the standard will be adopted or not, but it's worth a look. Okay, so he wrote in a very short paper, I think it was some kind of workshop somewhere, and it was, look at that, it's just 3 pages, 3.5 maybe. Okay, and he said, here's what I think. Now that we have uncertainty and we have to, how do we deal with uncertainty? First of all, utility instead of correctness. That is that thing, you know. So what Dijkstra was looking for is correctness. And it would be great if we could do that, except that the real world knows nothing. Correctness is something that we impose. You know, we decide as non-computers, we decide what is correct and what is not correct. The natural world does what it does. Right? Bounded approximation instead of precision. Again, you know, for example, you have variability. Even in requirements engineering, variability is an enormous problem. Now you can imagine it's there also in the design world. So maybe we can deal somehow, we have to deal with it. This is quite fundamental, the use, you know, and this has been done. There are these so-called MAPE, monitor and analyze, plan and execute methods of putting in essentially feedback control into, in this case, mostly into cyber-physical software. So there's a known pattern for dealing with that. The nice thing about feedback control, and that is quite fundamental, the nice thing about feedback control is regardless of what caused the system to go sideways, so to speak, what caused it, it doesn't matter, because I can, with my feedback control, when I detect that the system has gone wrong, I can correct it. So it could be due to a bug, it could be due to a failure, whatever. Okay. So that's a beautiful thing, and that is the only, and by the way, I think it was in IEEE Computer, I wrote an opinion piece where I talked about the need to put these people together, control theory people and software people need to work together. Because I'm a control engineer by bachelor's thesis. On the other hand, I went to the dark side very early on. After about being a real engineer for 2 years, I went and started working on computers, and the rest is terrible. Nasty story. This is the autonomy part. Something I didn't expect happened. I still want to be, and closed loops are partly the answer to that. I still react in a smart way. We need new formal methods for reasoning about uncertainty. So as much as we can, we want to realize Dijkstra's dream, but what is reasonable as well? How do we define what is a reasonable response, especially when we don't know what it's going to be? I think this is a wonderful research program, or at least for researchers. Here's a set of challenges. Okay. Solve them. Okay. So here's my challenge for software architecture researchers. Also, people from industry, by the way. And I've worked mostly in industry, but I've also have a fair amount of contact with academia and worked on many industry research, industry academia joint projects and so on. Here's something, I haven't done this systematically. Most of the real innovation happens in industry. I don't mean this as any kind of insult or anything. Industry has certain problems that are economic problems or whatever, the business problems that they have to solve. The problem is that they solve them for their particular situation. There isn't a general solution. Right? And I think one of the nicest ways that these two communities can collaborate is that go to industry, ask them what they do, say, for fault tolerance or for dealing with uncertainty. And get their input and then generalize it. Okay. So this is for researchers, if you like. Okay. You know, we know the rules for currently good architecture. Each module should focus on one thing. Right? Nicely encapsulated, whether it's a brake module or an air conditioning module. You don't want to have a mixed air conditioning brake module. The number of connections is minimal. Okay, why? Because, yeah, I mean, the more connections you have, if you remove something or if something goes wrong somewhere, the impact is everywhere. Okay? So that is deemed good design. And if we do the opposite, you know, we might put some things that kind of seem to be related. The example Alfonso and I had was the liver. Now, the liver is part of the cardiovascular system. It's also part of the digestive system. If you wanted to model that in UML, you couldn't do it. You would have to put the liver in one place, right? But it shows you that everything there is connected. So a large number of intermodule couplings will give you so this is known as bad design. Now, this is the part where, unfortunately, you won't see, the main message of this slide is going to be lost. This is the slide from the beginning. It really is very clear on the screen. All I can tell you is that there are literally thousands of connections in this thing. This is how a human cell keeps you alive. Okay, it's against anything that we know about how engineered systems are engineered. Okay. So these are so-called metabolic processes. You can find this. There's an HET. You can find that there. There's actually, this is just the first schema. There's another one. And here's a definition. What is metabolism, right? So here be the dragon. So let's just give you, maybe this is going to come out better. Let's just take one little portion of that and magnify it. Okay, that's one little portion. That's probably about an eighth of that whole big picture. Okay, now you can actually see roughly. I'm sorry about that. Not my fault. It's Henry's fault because he couldn't get it right, the proper resolution on this. Okay, but look at it. It's all lines. There is some modularity there, some modules, so to speak, and most of these modules actually have many lines coming in. So again, it's against all our, but this is how nature does smart. And who are we to say this is bad design? It's much more effective than whatever we can come up with our smart systems. So as I said, there's a bewildering forest of these connections. And no crisp modularity, right? There is some of it, but, and like I said, this is bad design. It is from a human, for sure. Okay, so I'm not actually advocating we have to build systems like this. We can't. And after all, depending on which side of the big argument you're from, either this took billions of years to get to it, or it happened in one instant by an extremely brilliant entity. Okay, but let's see how we would do this. So let's say this is our problem domain. Let's say we have to build a simulation of this. Okay, so there's the complex problem. What do? Oh, well, what we do is famous divide and conquer, right? We divide that complicated thing into manageable chunks, and therefore it's already subjective in a sense that, what is a manageable chunk depends on how big my head is. And so, it's not a perfect, you see there are lots of spaces left uncovered, and there are some things that are over generalized and they go outside this space and so on. So this is not a perfect picture. Okay, and then because we have limited this to a small number of modules, we put in the connections between them. And again, what you saw were literally thousands of connections reduced to some relatively small number of connections. And then we do the famous conquer. So this was the divide part of the problem. Now we do the conquer part. Okay, what is the conquer part? Well, we look at these subproblems and solve each one of them individually, because that's something we can manage. This is the part where we're terrible on. Integration, right? Now that we've taken things apart, it would be nice to know how do we put them back together, right? We don't, this is the part of the problem that we also, but that's why, by the way, and I'm from industry, the biggest issue when you deliver software is the integration step. Okay. And that's how we produce our model of that complicated space. And you can see that it is tremendously underpowered. This is something else. It's a beautiful diagram, that one, in the sense that it all works, right? The real diagram of the metabolic processes. But you see, there's this difference between the analytic and synthetic approach to, say, a complex system. Now, acupuncture is actually a synthetic approach. In other words, they don't go inside and look for all the traces. I think actually that's a mistake. They should do all. But, there's the funny thing. If you go to acupuncturists, they'll say, oh, your thumb is connected somehow to your brain. And if I poke the right nerve endings or whatever, it'll affect the brain somehow, which tells you that basically in these systems, everything is connected to everything else, right? There is no clean isolation, modularization, and so on. And therefore, our traditional approach will not be able to produce systems like this. So that's analytical. We take this, and frankly, it is a Western approach to science in general, and it has been very successful. But it ignores the synthetic part, and vice versa. And this is too bad, because I think we need both. Okay. And this thing I do want to see, one of the things you notice about that diagram, if you could actually see it in reality, is that the number of relationships is enormous. And you know what? I worked on UML. The modules are boxes. The relationships are lines. Okay, there's a good reason for that. However, as a result, I don't know if it's subconscious or not, we focus on the boxes. And if what does UML have? It has associations. Okay, well, they can have multiplicity. You can do a little bit of refinement there, but there's really hardly any semantics. And the semantics of those lines on that diagram are extremely complex, and therefore maybe there is some hope. Well, first of all, we should not say, okay, this is automatically maybe this is the bad design, the one on that one is the bad design, and this is the right kind of design. And I don't want you to think that I'm saying, oh no, you have to now produce these organisms, right? But here's the thesis, the natural biological systems, if you like, or social systems that are much better at being smart than any software that we can produce. Of course, we cannot match that. It might take billions of years if we're still around, whatever. But what I'm advocating and hoping for, if we study these systems, these biosystems, if we study them, maybe we're going to learn something about different kinds of patterns, relationship patterns, semantics of different kinds of relationships that we might be able to use. I mean, we're doing that with machine learning, right? We're finding it to be more effective at doing certain things than, algorithmic or whatever deterministic thinking. So that's a biologically inspired, and of course there were also like genetic algorithms and so on. There were excellent examples of how introducing some of this biological brilliance into the design process somehow. It may be that after we've studied it enough, we'll say, well, this is way too complicated. We just can't make sense of this. And we'll say, no, we can't do this. But even that's a wonderfully fundamental and important result. Right? If we know that, this is our limit, we can't go and can't do systems of this kind, then that's a useful result. It's a devastating result, but so I guess I'm running out of time. There is existing work in complexity theory, another discipline that I think would be wonderful for software architects to collaborate with. There are nice books. This is just one of them that I found very interesting. But I would think that all of this study should focus on this business of relationship. What kinds of relationships make that system work? Is there some kind of generalization that we can, abstraction, if you like, that we can draw from that so that we can end up using this? Oh, it ran out. So no wonder the back row is asleep. Yeah, the battery ran out on it. I guess I was talking too hard and had to work extra. So study the architecture of natural organism. It's a multidisciplinary effort. Focus on relationships, and then map these to design patterns. Or if you like more generally, you start off with the objectives. Don't jump to patterns right away. What are these smart objectives that we want? Look at the architectural principles, and then understand how these principles can be realized through design patterns, and eventually that they get realized. But it should be a top-down kind of research. Okay, let me just complete here. How am I doing on time? Okay. So we've come a long way. This is the first computer I worked on. It's an IBM 1130. It had an amazing 8K of memory. It had 2K disks, which are about this big. And, it's of course programmed in batch fashion. You punched the cards at a special machine. You handed them over to the operator. He put them in a queue, and then the jobs were executed one after the other. Paper tape was also something that we used quite extensively. And now we're into this Internet of Things situation. So I've been kind of through this whole evolution, and it boggles the mind how it has evolved. And it also boggles the mind in what ways it has evolved, in the sense that certain things, phenomena have come out as a result that I never expected. And others that I really hoped for have not. But that's beside the point. The whole is the scope and complexity of software has just grown enormously. And especially in the last 20 years. And by the way, most of this has to do with hardware. I hope you folks are humble enough. I tell my students when I teach that they should all have a picture of a hardware guy above their bed, and every morning just bow to this picture, because these are the guys that make you look good. Because stuff that could be, perceptrons, which is something I worked on way back in 1973, essentially, these are neural networks. It's the basis for neural networks, which were, by the way, invented during the Second World War. But it was impractical to have, thousands or millions of connections from one cell to the other. It's only because of the hardware that we're able to do this. huge amounts of memory, very fast computers, parallelism and whatnot. The trouble is we are vendors, if you like, are under tremendous pressure to produce something smart. And what worries me, I'm really scared of the Internet of Things because of the feature interaction problem. What worries me that there's going to be some serious catastrophes as a result. I mean, we know nowadays that, for example, in Ottawa, in Canada, where I live, somebody hacked into the hospital computer network, and basically everything stopped. You know, and people were dying as a result. The doctors couldn't get the, you know, the data on time and so on. And the whole system was built without any thought really given to what happens if this happens right away, if this happens instantaneously. And it was all done optimistically. And a lot of this work that is going on with smart system is optimistic. You know, people are focusing how wonderful it was all going to be, without giving much thought about what are we opening ourselves up for. So there's a rush to this, and my job, I see, as the old guy here, who's gone through this, is to warn people that be careful. Please be careful. Think about also the things that may not go right. Okay, so we don't have that expertise yet. That was the claim I made. I'm quite firm in believing that. It's, in a sense, in many ways, a discrepancy between the clean world of our computing and our languages and all that, and the unfriendly Murphy's Law world of natural world. You know, can we bridge it in some way that is acceptable? And we need new approaches and new knowledge to deal with this somehow. So that's David's call to action. There may be other, maybe even better ones, but this is the one I really found inspiring. In fact, when we were working on certainty, this had a whole huge impact. So all of them have a huge impact on software architecture design. And since we're trying to create systems that are almost of biological complexity, perhaps we should look at these systems. Can we learn, right? Is there something in here that we can learn? And maybe the one main thing we could learn is that we just can't do it this way. Which is, by the way, like I say, very important. If you can't do it that way, you should then live and design within your limits. Should not try to do things that you know you cannot do. Okay, that's it. Thank you.
Thanks a lot, Bran. Question time.
Objections too, by the way. I was asked, I gave an early version of this talk at Monash, where I'm an adjunct, and somebody asked me, but what's the solution then? And unfortunately, the answer might be that there's no solution, right? We believe that we can conquer this, but maybe we can't. Maybe we have reached the level of, you know, our abilities. I hope that's not true. Our mental abilities are finite. And trying to overreach them could be dangerous. So nobody disagrees.
Any question? Please.
So first of all, thank you very much. Something came into my mind. We frequently relate what we do in our software and how we organize our teams, right? So this one-one mapping. And I was thinking that this idea of decomposing is reflecting also in a negative way in our communities. The idea of decomposing mathematics, engineers, computer scientists, and inside computer science, algorithms, software engineers, and all the other things eventually brought us to do exactly what you said. We have our time to communicate together. We speak different languages. We try now to invest more on interdisciplinary things. But as soon as we put data scientists and software engineers talking together, we're telling yesterday about some, work, then we speak different languages, we use different tools, and everything is different. So I can totally understand what you were telling, from this decomposition also in the human as we work today as a community, as researchers. But I don't know what is in the intersection that you were showing, but I think it's very important to understand how to make it working on the intersection. Thank you.
It's definitely an issue. We cannot all speak the same language. The one thing that is fundamental, though, to make that a necessary condition, not necessarily a sufficient one, is the eagerness to actually collaborate. Now, here's another one of my theses based on almost 50 years of experience with software. Software people in particular are not that interested. They're interested in technology because computing and programming are essentially very seductive experiences. In computing you can go from idea to reality in 5 minutes. It works. Wonderful reinforcement. No wonder people get hooked on programming. These people who go and spend 3 nights without sleep, drinking some awful thing to stay awake, because they love the reward that they get. And unfortunately, software often attracts, I'm not generalizing, but it often attracts these kinds of people who don't really want to do anything but program. That's the thing that they're really, and they don't, I don't know how many times we ask people to go, developer to go and talk to the customer, and they don't want to do that. Many of them just don't want to do that. First of all, there's this disrespect of customers because they don't know how to program. And anybody who is worth anything should know programming. And I, of course, am a genius and I know how to program well. So I think if blame has to be assigned anywhere, I think it's more on our side. There's not that interest. You see, I'm a traditionally educated engineer. And this notion that you have to interact with the environment, with the users, with the people, and the effect that this thing is standard in traditional engineering. They look for it. Here they're trying to avoid it, and they come up with this concept of end user. Right? Personas concept is a very nice idea. It's an attempt to make it a little bit richer. Although it's very much focused, and there's still no agreement on what, that's one of the things I'm working on in Monash, is to see if there is a way of modeling people in a way that, of course, as we said, people are the worst thing to model, but maybe we can do something there. But this idea of an end user who in my poor imagination is just somebody like me. I know, I designed software like that. I designed software and I said, okay, I know how this, I know these people, I know how they're going to use it, and they always surprise you. So that's the arrogance of the software people. So my message to software people is, please be engaged, and that's why I focus so much on this human aspect. Please be engaged a lot more with the environment. And as a software architect, if all you're talking about is technology, how do I use machine learning in where do I put it in? How do I put it in? That's an important thing for sure, but it's only 50% of the problem. And if you don't understand your problem well enough, you don't understand, and you don't want to understand, then you're the wrong person. I hope I didn't insult anyone.
Other questions?
Thanks a lot for the talk. It was very interesting, and actually I agree with you about the fact that we need to talk with people and to understand each other. But the question is, do we really need all this complexity? So we are doing actions in imposing technology in all our life, okay? So if we want this, we have to be able to manage the complexity, and we have to talk with the other people, with the other experts, in order to realize something really useful for us, all of us. Yes, the system is very complex, and we need to make a requirement.
I think I agree with, you asked the question at some point where you said, do we need all this complexity? I just bought this new car, as I mentioned. And my God, is that ever a complicated thing? Even though this is the base model, I didn't go for the fancy model. But you know, there are 3 screens, each one with maybe a dozen features, right? And I was given a course of about 20 minutes by the dealer on how to use this thing. And I am computer illiterate, after all, to a certain extent, although I'm less and less so. But what I'm finding is that it made no sense to me. Right? I mean, where do I look? You know, so I say, well, where do I find? They say the control of the percentage of, you know, it's a hybrid. How much goes into the generator? Into the battery? How much goes? Well, it's on that screen, but it wasn't this kind of screen that I expected it to be. It was on one of the other screens and so on. So do we need this complexity, right? There is this demand for smartness. People are buying into it because they trust us. They trust that we know what we're doing, and therefore you tell them, oh, you're going to have a refrigerator, and your refrigerator is going to tell you you're out of milk. Sounds like a cool thing, by the way, but if that causes the air conditioning to break down because of some feature interaction, obviously that, you know, I wouldn't buy it, right? But if I knew about that thing. And by the way, a lot of these smart things are, let's face it, minor conveniences. They're minor conveniences, and to what extent does this impact us as people? You know, we found out that the mobile phone, and anybody who does teaching here knows the effect of the mobile phone on teaching, right? And the distraction that it created, and kids no longer actually focus, and all these kinds of things. You know, again, whoever released the phone should bear some responsibility for it. Whoever released ChatGPT, I'm serious. Because now, you know, people are open to it. They looked at the wonderfully. I mean, it is a truly impressive thing. But you know, it definitely is going to create an expectation that this, you know, smartness is here to stay. But I really think we have to, but that's hopeless, right? I think ideally we should say, okay, let's really focus on what kind of smart things do we really need? But, you know, in capitalism, somebody's going to come up with an app that says, oh, I'll find a parking space for you. I mean, that's a problem in l'Aquila, right? Everybody's looking for parking spaces, right? And that's kind of cool, right? But if that has other consequences that I hadn't foreseen, maybe it's not a good idea.
Other questions? Please, Raghu.
So there was a really nice talk, and especially the statement that you made about bowing down to hardware people, right? So given the trend that Moore's law at some point is going to end, right? You know, there's going to be limitations with hardware. So do you see the role of software increasingly going up relative to the system overall, and hardware and the limitations of hardware impacting what software can do?
Yes. Yes, I see that. Okay. More and more, of course, is going. You see, the nice thing about that is that we can have. It's easy to control hardware, relatively easy. Although when it fails, my God, is it ever a problem? I was aware of that problem in my telephony experience. Right, when one of the processors fails and you have to switch, while keeping the telephone calls up. Existing telephone, you know, that can be a huge problem. But that's a lot easier to control than the people part, right? So I'm less worried about cyber-physical systems so much than I am about the social, and you know, software entering the social domain. And again, we're seeing a lot of software and its impact nowadays on social domain. I mean, I don't know how many people here are looking at their phone. Not right now because they're hoping I'm almost done. But during the talk, there was a number of people. Of course, it's quite natural. I do it as well. I don't have a mobile phone, but I do have an iPad. So you naturally, you know, I mean, we like distractions. And it has had an impact on us. And so software has entered the social domain. It has created a huge impact in, say, the politics, everyday politics. I mean, I can tell you in the US, it created a huge rift. And people only now talk to those people who they agree with, and they hate the other people. You know, who could have thought of that? But you know, we have to think about these things. It's our responsibility. We should take the blame. We should take the blame for the social networks. I take the blame, even though I hate them. Member of only one. I don't know if I answered your question, but here's another.
Oh, Alfonso.
Yeah, Alfonso is going to pitch me a soft pitch, right? The one that I can answer real easily. So we made an agreement.
Also, my question will be easy. Anyway, during the talk, you stated that we need new tools to deal with uncertainty. I tried in the past, like to model to deal with uncertainty, but I tried to include probability in my models, like stochastic model. Is this not enough for you? I try also in my everyday life to do that. Actually, there is a book from Daniel Kahneman called Think Fast and Slow. It's a famous book.
Okay, which probability distribution did you use?
I don't know. I always try to think like the probability that this event could happen can break, for example, a constraint, like a non-functional, so a constraint. So I use like for verification and validation, let's say.
Okay. You just stepped, by the way, on another one of my minds. I hate the term non-functional because you do not define things by what they are not. You define things by what they are.
Extra functional.
No, I'm kidding. Sorry, no. But your point. My point though is that what you have to do, you have to have a sophisticated enough model. So just putting, you know, maybe that's in some cases it's sufficient to put in non-determinism, but not all of these things are necessarily non-deterministic in arbitrary ways. Maybe they have a particular distribution or they come with other phenomena that are equally, in other words, it probably isn't a sufficiently refined model. So to answer your question, no, I don't think that's enough.
Can you make an example of something like exceptional that we could not model?
A human, you know, a human user who uses my software and says, wait a second, which button do I hit? Oh, it's this one. Bang, oh, that was the wrong button. Now, there's an example of, you know, of randomness that has to do with the culture of that individual, what training that individual has had with that particular domain, let alone the particular piece of software, et cetera. Even there's now software that I'm an expert at that there's parts that I never use and don't understand how to use or anything like that. But my point again is that you need more sophisticated models. If you want to model the real world, you need to have at least an accurate enough model of that world to do a good job with it. Accuracy, faithful model is important.
Okay, there was Alfonso raising the third time the hand. Alfonso. We don't want your question, Alfonso. So just
I want it.
Yeah, you want it, right? Indeed, it's not your turn. No, Alfonso.
Oh.
Thank you, Bran. Thank you for the refreshing talk.
That's just because I added your name to the slide. Yeah.
In a few slides, I could spot the term is synergic. I would like to ask you, what do you mean by synergic? Is it synergic designs, synergic computing?
Let me start with an example. The liver. That's a synergy of two different, what we would call systems. There really isn't. There's 11 organ systems, they claim. This is an abstraction. There's only one system. It's the body. And the way that we divide these things and so on. But there's a synergy there between what we would call circulation, how circulation works, and how digestive processes work. And it's all concentrated in one place. And there's a good reason why that is. And I can't tell you, I'm not a doctor or a physician of any kind. But there must be a very good reason why these things. So synergy means happy combination of two, if you like, behaviors. Some very nice folding in, like, you know, gears matching. That's what I mean by synergy, right? Synergy means you produce, you know, the sum is greater than, the output is greater than the sum of the parts.
And do you think you can translate this to software, or do you think
I don't know, but that's why I'm here. That's why I'm asking people here to look at. Yes, you can. There are some things that can be translated into software for sure, but I don't know how general that is, or, you know, is there a general pattern that I can use, or architectural design principle that I can use to detect these things? But it's a wonderful thing, isn't it? I mean, look at the possibilities. What are all kinds of interesting things you can work on. Wow, I wish I was younger.
Thank you.
Okay. Other questions? Last one down there. Oh, Patrizio. Extra work, extra salary for you.
Yes, okay. 20%?
Yeah, okay. Yeah, you kind of described this potential solution of these complicated systems from nature, right? Which is, to me, it's kind of a BOGO sort, right? That nature has found some functional, working, imperfect, because otherwise we live forever, version of a system to go with, right? But to me, the problems you describe, such as with the, like the unintended acceleration, you know, not being able to brake, are these not kind of the BOGO sorting for profitability in software, so that we are kind of massively pushing out quite badly engineered software, which has these problems and possibly unintended social consequences, rather than a sort of structural issue in how it is designed, that it is more that we are overly, you know, obsessed with profitability when designing new systems.
I'm sorry, can you just repeat the question more succinctly, because I've lost you at one point. I was trying to follow up.
I was just wondering, you know, as a counter to that the problems you are describing are more a result of an obsession with profitability in the software that is being created, rather than, you know, something about how it is being designed or architected. Specifically, as in you could be making better software, but we aren't making more detail-oriented software because we are making quicker software for profit.
Yes. Yes, in fact, profit is our biggest issue, right, in the sense that, and that has to do with professionalism, and again, professionalism is not something that is, you know, widespread in the software community. There are some organizations and ways of dealing with it, but it's the professional that says, okay, this has to work exactly like this, rather than saying, well, it's good enough, let's ship it and see what happens.
Yeah. Thanks.
Okay, last question, Patrizio, and then we have a coffee break.
Watch out, Patrizio, I'm paying for your dinner tonight, you remember?
Oh, that's why it's the last one.
So thanks a lot for your talk. I was thinking to your slides when you have the user there, that is user, mixing all the possible users and with a lot of mess. But what I'm missing is that probably the user is not the one making mess. Sometimes are the systems, no? Because we have systems that are obliging us to do something. When we go in some office, I got this answer sometimes, that they are filling some form and they say, I need this information. You ask, but why? The form is asking that. No? So well, maybe we should engineer systems that are for humans.
Actually, you're, I think, reinforcing my point. You should never blame the user. User is whoever it is. And now that you were forcing these people, you know, it's in the past you did software for specialists, and then you expected them to train up on the software and so on. But now you're doing it for the whole population, right? Society demands it. And therefore, never blame the user. Anytime a user makes a mistake, you should think of it primarily as something I did wrong. And one idea that we had, and we're exploring it, and you see different people react differently, right? Everybody's an individual. Wouldn't it be nice if everybody had a profile that they took along with them, and there was a standard? So you would, you know, if you approached a piece of software, you would somehow let it access your profile. It would present the interface that is adjusted to you based on your profile. It could be machine learned profile, whatever. But I think that's an excellent idea. Yet, you know, we're still forced, you know, software is so eminently pliable, right? I mean, a piece of hardware over here, right? There's a button here and a button here, and I can't move those. Right? They're there. But with software, you can do anything you like. You can change that whole interface nicely just by one instruction, right? And why aren't we doing that? Why are we still stuck? Well, this is the interface. I mean, look at modeling tools. They're awful. I counted 340 menu items on one, and I maybe use 15 of them, right? Or at least in one mode, I may use just 15 of them. Well, show me the interface that is good for me for this 15. Don't show me the whole thing. Again, that has to do with being human-centric. And that, I think, is a bigger challenge than all the other ones.
Okay. So let's thank Bran again.
Chocolates. Well, thank you.
And we will restart at 5 p.m., okay? With the closing session, I don't know, Henry, if you want.
Yeah, well, we have a most influential paper, short presentation, best poster, and ICSA 2024. Okay, 5 p.m. Okay, we are almost done. So, as we announced before the break, we have a presentation from the most influential paper. You know that it means that in the 10 years, when even there was no ICSA, but was WICSA, Comperch, and a set of events, we selected as a steering committee the paper that had most important influence in terms of research and also practice and software architecture published in one of our previous venue. So it's my great honor to invite here Thomas and Elias presenting what's going on after 10 years and on behalf also of the other co-authors of that paper. Please.
Okay, use this mic. Okay, so let me do it like this.
Hold on.
Okay. You have to click here. No, you can sit here and you can click. Okay, thank you. First of all, thank you very much for this recognition. It honestly means a lot to us. So thank you very much for that. Today with this, I don't want to repeat the paper, but I would like to give you a bit of the backstory, so kind of like behind the scenes and maybe some lessons learned. By the way, this is the team. We somehow tried to pick up the photos that roughly corresponded to that time when we created it. I'm the guy on the bottom left.
That's clear,
I'm not so sure anymore. So that was me. That guy on the top left, that is Elias. That's also not so clear anymore. The rest was the rest of our wonderful team. Sort of the backstory of this is that someone in 2011, we became part of this FP7 FET project Ascens. It was FET, so it actually belonged to the first pillar of the FP7. So it was a basic research. And for whatever reason, sorry, I mean, there's transition. For whatever reason, this project was somehow focused on something which was supposed to be called autonomic service component ensembles. And still my impression from the project was that the project was built around the term, and sort of the aim of the project was to investigate what the term means. And so we actually went for this, and we started looking into this concept, and in the project there were a lot of wonderful partners, mostly Italians, I should say. And they were doing a lot of formal methods, and there were quite a number of partners doing process algebras, which was very far from what we would do normally. And one of the things that was quite important that we figured out very early on was there were a lot of process algebras where there was no architecture. And though the project was supposed to be about autonomous components, services, ensembles, etc., there was actually no architecture. I mean, there were only process algebras there. So we sort of saw it as our chance, and we thought that actually the architecture might be something that we could actually contribute in the project, because we always had quite a lot of experience with building component models. So we created at that time this component model that we call DECO. I still always have to think what the abbreviation means. I think it was totally wrongly chosen, but at that time we somehow thought that it was a good idea. The idea was that we would essentially very strongly focus on the runtime dynamism and situational context, and we wanted to develop something which was fresh, something that would really show some fresh ideas. So we didn't want to have the old plain boxes and arrows. We wanted to really give it some fresh thinking. So now let me pass to Ilias to explain what we actually...
All right, thanks Thomas, and thank you very much also for this award. So the tutorial now. 2 minutes tutorial. So in DECO, that's a component model where we basically, in the end, decided to go with two basic concepts, okay? So we had the concept of the component and the concept of something that we called an ensemble, okay? So contrary to the traditional, let's say, component models up to this point in time, that will be basically composed of components and some connectors that will be static. Our connector, our idea of a connector was this ensemble, which would be a very dynamic connector. Actually, you can look at it from the perspective of connectors and think of it as a dynamic connector, or you can look at it from the perspective of agent-based computing, and you can think about agents forming coalitions, okay? However you think about it, actually, in the end, we were able to model applications such as this one, where you have some cars, they have some parking lots, the cars and the parking lots are components, components have knowledge and have also processes which kind of work like real-time tasks, right? And then we have certain DSLs that will basically describe all this. And then these ensembles were kind of key, because then the ensembles will bring in when these components should form a coalition. And whenever a coalition would be formed, we will kind of instantiate an instance of this class at runtime, right? And then the when was checked based on a formula, right? So it would be a logic predicate there that we called membership. So, for instance, when you are approaching a parking lot, this is the only point in time where the car should basically get in a coalition. That was generic, right? We didn't talk about a particular parking lot or a particular car, okay? So that was the main idea. And when you form these coalitions, you can do things, mainly exchange knowledge with each other. We had also some kind of, yeah, example like that. And now the funny part is that the cars keep moving. It's a slide that took like as much as to develop the component model itself. So, but you can enjoy. They come again there, they make another coalition, then there is a kind of, what was that? Something kind of in the street, some exception going on, then basically dynamically the system adapts, let's say situational aware, right? And then picks another parking lot, and then finally, if I keep clicking, I think the cars will go to their destination. So that's in a nutshell, like 2-3 minutes, how this thing works. So for the rest, back to Thomas.
It actually turned out that this idea, which was relatively simple, but that's at some time we believe it was relatively novel. Wow. Actually became start of a number of things that came afterwards. We published this at CBSE 2013, and actually at the same CBSE, we could somehow skip the transitions, but somehow at the same CBSE, we actually had another paper which was accompanying this component model already with some requirements engineering approach. And that at that time, like the other paper actually got the best paper award. So it's very nice now to have this first paper also getting awarded. And then we actually developed this approach further. What turned out to be quite interesting is that we coupled it with sort of more of the hardware perspective. So we would actually, for instance, reason about knowledge propagation, and for instance, knowledge propagation in ad hoc networks or in mesh networks. And we will, for instance, couple it with a simulator of, really, physical simulator of the network. So we could actually reason about how long it takes until some knowledge propagates from one component to another. We also had there this concept that that Brown mentioned today with reference to David, that we wouldn't really reason about correctness, we would reason about utility. So that was one of our important concepts there, that we say, well, the systems are always incorrect because they never work on the same data. But we can speak about utility because as long as we can, for instance, minimize the delay between the knowledge propagation, or not maybe minimize, maybe bound it, then we can actually speak about some boundary on correctness, and we could quantify the utility. And this actually turned out to be relatively, relatively strong idea for building other research. As a result, we actually wrote something like 45 papers that were based on this one. And figure out that there were probably close to 90 other papers from other groups that we even didn't touch. What was actually nice is that even during this conference, we could still hear references to our model. We graduated 5 PhD students in our group on this, and I know about other PhD students in other groups that are somehow at least working with this to an extent. It also became one of the starting points for the CES CPS workshop, which we did with Danny and Bradley and John Fitzgerald and others. And we actually managed, I counted it like to keep it for 5 consecutive years, which turned out to be quite long. Good.
Software engineering for smart cyber.
Yeah, that's the software engineering for smart cyber physical systems.
It actually has smart in the title.
Yeah. Let me conclude with a few random observations, kind of like in a retrospective. I was somehow asking why the success, and honestly, I have no idea. I mean, if I had, I guarantee I would try to replicate it, and I don't know. I think this is just one of those moments when you are just lucky, when the different things somehow converge together at a single point, and you are just standing there, and it just happens. Because at that time, we were lucky enough to get this project, which provided us the necessary motivation. But we were also lucky to get another project, because at the same time, we actually received a Marie Curie Initial Training Network, which allowed us to, for instance, attract Ilias and fund other students. So we could kind of like get quite large team with good people, because we actually get a lot of funding for it, which even asks for students coming from different countries. Can you go to the previous one? And also what was interesting was the combination that this Ascens project was actually a basic research project. It wasn't applied research. And as it was basic research, it allowed us to develop more crazy ideas than we would normally do in applied research projects. Now, I mean, having also the experience of applied research projects, it's not so easy to do it there. Let's go on. And like last slide of my random ramblings. But what's interesting, also kind of like looking at it at retrospective, and also like relating to this discussion that we had, I mean, just after the lunch today, regarding the evaluation. Interestingly, the paper had no real evaluation. So it had, like, when I say no real evaluation, I mean, like, we didn't really compare to any baseline. Why didn't we compare to baseline? Well, because there was none. I mean, till nowadays, almost there is none for this. So we actually couldn't do that. But we tried our best to somehow make up for it. So one thing that we did is that we developed an implementation that we made open source and already referred to from the paper. We had runnable examples that were part of the implementation that were demonstrating the key concepts in action. We had this use case that was implemented there, and at least as somehow to make up for the missing evaluation, we had a section there which was more like a subjective experience and lessons learned of the authors, where we at least try to explain why we believe that those concepts that we featured there are somehow more useful than what has been around so far. But honestly, pretty much that was the only thing that we could do. And still we somehow dared to publish it at CBSE, which now seems it really paid off. And can we go to the next slide? And so what I would like to do is I would like to thank of course all those who contributed to this research, who supported it, who continued on it in various ways. But what I also especially would like to think about, I would like to think about to those who were at that time open-minded enough to appreciate it and accept it. Because you see, if it wasn't really appreciated more like because it was a novel, maybe a bit crazy idea, we wouldn't be standing here today. So thank you very much. Thank you.
Okay, now I'd like to call Daniele and or Michele for the best poster, please.
Yes. So, first of all, thank you for the award, because it's a long story behind this theme in our research. So, the multi-objective software architecture refactoring driven by quality attributes was part of my PhD, and now is part of our research. We just recap the history of our papers behind this research. So the first paper was in ICSA 2018. We introduced the approach of multi-objective optimization on a specific performance architectural description language, Emilia. Is a part of a team of Cortellessa and the University of l'Aquila. Then we work on introducing different languages on the topics, and we work now on UML. So we work on introducing a concept on this topic by changing the changing the language, the design language, to augment the audience of this talk, this approach. So, okay, now we have a lot of we have several publications on the same topics, and we discovered that search-based activity requires time and consuming resources. So we are working on introducing concept of budget. So basically, we introduce a time budget as a first
example to optimize the time for optimizing also the refactoring actions to optimal architecture. So then we will work on different topics, and finally we have a last paper on these topics. We submitted a paper to JSS, so we are on part of this community. So we are, let's say, proud to be a member of this community. And how it's going. So now we have a poster. We are glad to receive this award. I'm glad to work with Michele. And Michele give you data on technical aspects.
Yeah. So as you could probably tell from the poster, we didn't get the award for our graphical design skills. So it took us almost 5 years to come up to draw this, but this is what we actually do. So we start with an initial model, which is usually UML, an architecture, and we have a catalog of automated refactoring actions through model transformation, and those actions are designed to improve performance. And we use genetic algorithms to apply those actions in sequences and modify the architecture so that we can hopefully improve performance while detecting performance anti-patterns in there, also evaluating reliability of the architecture, and we also try to estimate the cost of applying those refactoring actions on the models. And what comes out of it is a Pareto frontier, so basically a set of solutions that the algorithm were able to, design alternatives that the algorithm were able to improve up to that point. It doesn't really. Yeah. This is just an example of one refactoring action that's called move method. What we do. So the actions are applied on the model, which is UML with a static view and dynamic view. So it has to deal with all this diagram. So in this case, for example, if we want to move the operation to from component C, what we will do. So that one will do. Those are the points in which we will interact automatically, and in this case, we will create a new component so that hopefully the performance will be better. The new component will be deployed on a new node, and the sequence diagram will be updated accordingly. And there are other refactoring actions like this, and we're working on more. So every new design alternatives that we get, we evaluate with respect to those 4 objectives. One is PerfQ, which is basically a summarizing indicator for performance improvement of the treatment. What it does, it takes indices computed from an LQN, and it tries to put all of them together to give you an idea, like something like it improved of 10%, or I don't know, performance decrease of 5%, stuff like that. Then we have a closed form model for reliability, actually reliability on demand, with error propagation. It is in closed form, so it's very quick for us to compute it on the model. And we detect performance anti-pattern on that, which are design patterns that usually lead to performance issues. And then, as I was saying before, we compute this architectural distance, which is the last formula on the right. What basically does, it attributes a cost to a refactoring action, a type of refactoring action, and that multiplies that cost for the actual target on which that action is applied, taking into account the complexity of the target. These are just some of the latest results we got. We experimented lately with FATSI detection of the performance anti-pattern so that we can, in a way, assign probability to that detection. And have different weights for different anti-patterns. So that is a way, from a designer point of view, to focus first on anti-patterns that have higher probability. As you can see on the right, those are the Pareto front that we get when we change the probability of the performance anti-pattern. And we're working on a lot of stuff. These are just the main things. One is we try to introduce some quality metrics for architecture that we can like quantifiable metrics that make sense in our problem. We're also working with people from traditional optimization to work on a problem formalization and try to see if there are techniques that could help us. And one of the latest things we're working on is to bring human back in the loop. We're doing this within spec, and I think we're almost there with this. So thank you again. We really appreciate it. And yeah, thanks for the work. Thank you.
So now is the time for introduction presentation of ICSA 2024.
Feedback is not here?
It's there. Yes. We are on.
For the audience, is this audible or do we need to use the hand mic?
For the audience?
For the online audience?
No, it's okay. Just get it close. Yeah, it's only.
They asked me to use the hand mic.
No, that's as far as I know, it works. The only thing, try to get. No.
Okay.
No, just put in presentation mode.
Yes, put it in presentation
mode. And play it. Oh, yes. Guarantee forget.
Okay. Presentation mode.
Hello?
Yeah, just play it.
Play?
Yeah.
Please.
Thank you. So, I know many of you have gray hair, some don't. But how many of you were there for 2014 ICSA? So, 10 years, welcome back to ICSA 2024. And to all of you who haven't been there, this is a fantastic opportunity for you to come experience rich culture, 400-plus-year-old city, right? Lot of changes in the last 10 years. It's one of the technology hubs, not only of India, probably the world, if I can say so. It's a pharma capital. So if you really look at it, you would be surprised to know that a significant amount of pharma manufacturing happens in India, right? Including the COVID vaccines that some of you probably have had at some point of time. Hyderabad is known as the pharma capital and tech capital at this point. We have plenty of educational institutes, research institutes, as well as training institutes, and it also has the largest film studio in the world. So that's a great opportunity for you to visit, right? great place for food. That goes without saying, anywhere in India. In terms of the venue, so the place where I currently teach and I head the software engineering research group over there. So it's called IIIT Hyderabad. It's a IIIT. So the IT in the last stands for information technology, right? So it's specialized in information technology, so it's not broadly engineering per se. So as a result, we are one of the topmost institutes in India for computer science. And it's about 35 kilometers from the airport, so quick 30-40 minute cab ride and no traffic, don't worry, all right? It's a very well-connected road. And internally also, if you transfer out of Delhi, Bombay, any major city that you probably come in, there are flights with regular frequencies. So transport-wise should not be an issue. Yeah, just some, whatever I could find quickly, I just put it out there. Obviously, I can see Rome is missing. It is there, okay? So whatever it is, I blame it on Karthik. So this is the venue, IIIT Hyderabad, the campus. It's a lush green campus. So interestingly enough, lush green campus in the middle of an IT hub. The tall buildings, and then you will see just in our campus, pretty much greenery. We could do anything we want in our campus in terms of the amount of research and freedom that we get, but if we have to cut down a tree, oh man, the permissions that we have to go through is just like hell. So we've maintained that in terms of the greenery on the campus. It's some of the facilities that are in the campus, right? And most of the companies, any major company that you could probably name, the big tech companies, are in a 5 to 10 kilometer radius. So our campus, is pretty adjacent to Microsoft, the Infosys, Wipro's, Google's, just name it. Salesforce, whatever it is, right? It's in a 5 to 10 kilometer radius. So we are in the heart of the IT hub. So as such, location-wise, it's a fantastic location. And also we house one of the largest incubators in India. So that's a huge startup ecosystem within our campus itself. In addition to what's outside campus, which I'll just show you in a minute. And again, in a 5 kilometer radius, there's plenty of hotels, 3, 4, 5 budget hotels, service apartments for students if necessary. So all options are available, and we will definitely facilitate some of these where we will negotiate the right pricing, right, in due course of time. Plenty of things to do, yes, of course, conference is there, and then what's outside of the conference. In terms of arts, in dance, obviously, traditionally going to India, it's rich in culture. I don't need to tell you anything about it. In addition to that, we would probably be looking at facilitating some tours, going to various places. Like, for example, if you look at this, so this is now touted to be the world's largest incubator of startups. And this is one of the largest prototyping centers. So you bring your idea, you can actually go out with a prototype. So probably we're hoping that when we do ICSA next year, we will plan for some trips to some of these places so you can kind of go in and see and interact as and when necessary. So there's the team, and hopefully I'll see many of you and many more of your colleagues in India next year. And the website will come up soon. The tentative dates will be end of May, beginning of June, which means you have plenty of time to write papers. Thank you.
Ipek, please. Interesting. Emotion is coming now instead when we opened. Really? So, let me see if this is gonna work. Or we will do traditional. Okay, not even. That does not depend on me. Oh, relaunch it. Relaunch it. Okay, with the mouse. And now. Yeah. Okay. Okay, so first of all, a few elements from the ICSA steering committee, okay, that we want to share with the community. So you know that we had a meeting, you may know that we had a meeting a couple of days ago, also to discuss about and approve, you know, elements coming from the next editions and to check where we are and where we want to go. And we defined, when I got elected as a steering committee chair, and Ipek is my vice chair, we defined some short-term strategic elements that we really want to get, okay, and especially myself, because it's my, let's say, wish when I propose my candidacy or others propose my candidacy. So, engage next generation software architects and open up the community. I believe this is extremely important. I don't know you, but we noticed that sometimes we are always the same running these conferences. Honestly, I'm doing honest speaking, okay? It's time to give space and to grow the community. And it's on purpose that we add 23 student volunteers. Please stand up.
They are ICSA.
They are ICSA, yes. And they are future ICSA. So we really wanted, you know with the student volunteer what happened? We opened the call, we had like one person making a request. We said, oh, and dell'Aquila was managing it. We were in touch. We said, what shall we do? Okay, let's send again. And then eventually, in between locals and internationals, so we ended up with 23. And then my point, handling the budget, was, what shall I do? But we managed, and we managed to get all of them here, all of them free registration, all of them as it shall be. I'm not saying must be, because it's difficult, okay, but it shall be. And really, I wanted, even if at a certain point I was like, oh, where should I put my hands with the budget? Because we need to push on next generation. In between those ladies and guys, there are some of them that didn't attend a conference for COVID, or only one conference. That's why I really wanted, and as a community, we wanted to get as many, not only as student volunteer, but all the young generation coming, staying with the others, meet each other, okay? Because we may have forgotten, but again, some of them didn't attend any single conference or just a very few. So, I'll push also you guys, okay, trying to do your best. And we also reduced as much as we could the registration fee for students, more than what IEEE requires to do, okay, because it may be another element affecting the participation. Indeed, we all travel with budget, but we know that travel budget is limited sometime, okay. So please, any of you for next edition, try to push your students to come. And I really appreciate it, for example, so many posters, so many new ideas, okay, because we need new ideas. We need also simple ideas, not yet ready, to get the community reshaping together, staying together and growing. And it's so nice when you see those guys and ladies getting together and speaking and say, oh, let's be ready for the next conference. I have this idea. Can we meet next week and start writing a paper? Then we create more collaboration, we can create more integration, and we make our software architecture community growing and staying, for the next years and decades. So this is one of the points. We also want to support the community in increasing quality submissions and participation, okay? The numbers in terms of technical papers were very good, not yet at the scale that we had before COVID, okay? Then, again, we are taking actions, and one of the actions was to organize this edition in a way that we try to make as much as social, interactive, participated. As all of you, may understand, it was totally on purpose, and if we made it correctly, we are so happy, because we wanted really people to get together, and especially those, youngers, and get together, and maybe next year they see again, and they recognize, and we recognize them, and they grow, and they will be, in some years the next chairs, or some tracks, and so on. Okay, so. We believe it's very important to work on quality submissions, and if we will circulate, by the way, a questionnaire at the end of the conference, not today, okay, not today, and if you have any suggestion also on how to improve and how to permit other people to submit and contribute, let us know. We are open to understand how to make the community growing and getting again together next year and making another, very great experience. So another thing I think that is important, and we think as a steering committee that is important, that we regain visibility inside the more general software engineering community, okay? For those of you that are young, maybe you don't know, but for some of us, we know. Software architecture was, I would say, quite a hot topic, and general software engineering community a number of years ago. And then eventually things got slower and slower and slower, and we are taking actions, and indeed we want you to stay here as well, okay, but also to think about how the community can have more visibility. We tell people, and we believe, because it's true, that software architecture is everywhere, more than it was 5 or 10 years ago, okay? But our general participation and contribution to the main software engineering venue is not reflecting this. There can be many reasons. We had no time. We can talk, individually later. But we believe it's also important to be there and to get disseminate and interact with the bigger. For example, this year, in a couple of months, at ICSA 2023, there will be this ICSA showcase. So it's an idea from the steering committee of ICSA, and when they proposed to our steering committee, we were totally happy that 3 papers has been selected and will be presented on software architecture in the last, that have been published in the last few years, that we consider to be representative and important to be shown to the general audience of software engineering at ICSA. Okay, but again, any proposal, any idea, we are very happy. We believe it's important to be there and to interact and to see again how these communities intersect. It's a big family, but sometimes we kind of close a little bit too much in ourselves. Instead, it's important to open up again. Just another couple of things. We believe in industry academia collaboration. That's not an easy task. We have different purpose, we have different goals, we have different ways to be rewarded. While a paper or a most influential best paper for us is, I remember, and I think I will remember for a long time, Paris' face yesterday when we nominated best paper. I was so happy. And this means a lot, okay? Because if a senior member of this community had that reaction that maybe many of you noticed, okay, it means that we really believe on that. We are really happy for that, okay? But companies, indeed, they have other rewards. They have other goals. We are working in the steering committee. We have members from industry, and we are also looking for more active members from industry to be in the steering committee, okay, to understand how we can make them coming more frequently. I think that, among others, Tatiana's speech was, at least for me, extremely opening mind and telling myself, be careful, Henry, we are doing excellent, nice research, but let's talk with those people, okay, because maybe we are not doing exactly what big companies in the world are planning for their next future, okay, and maybe we are just sticking on something that they don't consider anymore so relevant. So let's keep an open eye. And something that we did on purpose, and it was started at this steering committee 2 days ago, we created an industrial subcommittee inside the steering committee of the conference of industrial people and we will give a voice to them at any meeting, okay, at the beginning of the meeting, to listen what they have to tell. One of the comments in the previous meetings was, yes, nice to be in the meeting. It's typically 1 hour, 1 hour and a half. But let's say 90% of the things that you discuss, like co-ranking. So it's very important to you, but not to us. And then we said, okay, let's give you a space dedicated to industrial needs so that we can attract more, okay? And that's one of the other things that we are pushing, and again, any idea is welcome. And for sure, the working conference format that was initiated with ICSA, if you remember, was the working conference on software architecture. As you may have noticed, I hope, we want to revitalize. We never lost it. But at a certain point, especially with COVID, that was more difficult, okay? We had 5 working sessions, we had a panel, because we believe that interactivity that we had is really the way to go to make an active conference and not just a passive conference, okay? So for sure, we will continue and push on interactivity. It's not easy. When we got all the papers from the technical track and the other tracks, and we had to try to balance how can we use the 3 days, not to create too many parallel sessions, okay, but still to get 5 working sessions. So some of you may recognize that the work was dense, the program, but that was, I can tell you, we changed, I don't know, with also Rad and Vittorio, I think 10 times, okay? And that is the best, let's say, fit, and I believe it was working. But again, I can promise you that whenever papers we get, there will be always a space for working sessions and panels and interaction and speech and, all those kind of things. Just to conclude, thank you very much. This is a photo we made before, okay? Yeah, I asked them to make a photo. It was, and it is still, impressive, okay? I was counting. I like to count people, okay? Doing a Brand-Sellich keynote, even it was already evening on Friday, day 5, there were in this room at least 70 people, okay? So this is a lot. This means a lot. This gave us a big of energy, okay? And that's energy that we need, especially this time after these 3 years that we couldn't meet together. Okay, so we put our energy, but you gave us a lot of energy with all your participation, interaction. And when I was sitting there and looking behind, I said, "Oh, wow! I mean, that's wonderful." Also because we didn't know, honestly. You know, we put a keynote and we put ICSA 2024 at the very end. It was by design, indeed. It was not by mistake. But we were like, you know, some kind of question mark if it would have worked. We filled in the morning with many papers, you know, on purpose to see if we could keep people staying. And thank you really much for staying the whole week with us to interact, to give your inputs and to give your feedback and all the other things. Just to conclude, we were discussing with Deepak, and we eventually wanted to do that. Yeah. We wanted to do that. Okay. They've been both very active members of the steering committee. They've been shaping this community, running this conference in many different roles. And I personally was thinking, we did already at ICSA last year for Ibiza, but then unfortunately Matthias just passed away a few months ago. Not that we want to collect, honestly, but we really felt, okay, as general co-chairs of this conference, that we wanted to, not just to say, oh, at once, ciao Ibiza, bye-bye, or, you know, not even to the others, but we felt that we really wanted, as members of the steering committee and as them, member of the steering committee, contributed so much. And if you knew both of them, that's their face all the time, smiling. Okay? That's why. So thank you, Nizza. Thank you, Matthias, for what you did. And have a nice trip back.